Thank you for joining us today. We're now in session. I'm Jennifer Homendy, and I'm honored to serve as the chairwoman of the National Transportation Safety Board and chair of this Board of Inquiry. I'm joined by my fellow board members, Member Michael Graham, Member Tom Chapman, and Member Todd Inman. Before I begin, I want to yield a little bit of time to Member Chapman.
Thank you for the opportunity to speak briefly, Chair. With regret, I'm going to excuse myself from this morning's session and for the remainder of the investigative hearing. Before doing so, I want to explain why I will not be participating in the hearing nor any of the proceedings related to this investigation going forward. As I have formally disclosed in various public financial disclosure filings, my family and I continue to receive flight privileges from American Airlines pursuant to an executive change in control and severance benefits agreement. That is an arrangement which dates to a circumstance and time much earlier in my professional career. American Airlines is not a formal party to the investigation. However, I am recusing myself from further participation in light of the business and corporate relationship between American Airlines and PSA Airlines, which is a party, of course. I commend our team and all of you participating in the hearing for your contributions. I am following the investigation closely and will be observing the hearing by video from my office here in the building. A thorough determination and examination of the facts is owed to those who lost their lives in this terrible tragedy and to their loved ones who are grieving the unimaginable loss. I know that some of those folks are here today and will be with us throughout the next few days. Our hearts go out to you. I'm confident the lessons learned from this investigation will help ensure such a tragedy can never be repeated. Chair, that concludes my remarks, and my thanks again for the opportunity to explain my situation.
Thank you, Member Chapman. And for those in the audience who may not be familiar, that's pretty standard. We all have different recusals that we come on board with, and so I appreciate that, Member Chapman, and we'll see you later. Member Graham, Member Inman, and I will comprise the Board of Inquiry for this investigative hearing. The notice for the hearing was published in the Federal Register on July 11th, 2025. I now recognize our hearing officer, Dr. Dan Bauer.
Thank you, Chairwoman Homendy. Before we get started with today's meeting, please silence your electronic devices if you have not already done so. Restrooms are in the lobby to the left as you are exiting the boardroom. We will now share important safety information for those here in person. Please play the video.
Hello and welcome to the NTSB boardroom. Before we get started with today's meeting, I'd like to quickly walk you through our emergency procedures. First things first, please take a moment to silence your phones or other electronic devices. If you need the restrooms, they're just outside the boardroom on the left side of the lobby. Now, in case of an emergency, here's what you need to know. If someone experiences a medical emergency, our on-site Federal Protective Service officers are trained to respond. They'll call 911, perform CPR if needed, and use the automated external defibrillator device mounted in the lobby between the boardroom exit doors. They're also trained to provide first aid. There's a first aid kit at the security desk in the lobby. If we're asked to shelter in place, like during severe weather or a security incident, please stay seated and listen for instructions. Our security team will manage the situation and let us know when it's safe to leave. If the fire alarm sounds, please follow NTSB staff to the nearest exit. There are two main options. You can exit via the stairs next to the stage, or you can exit the same way you came in through the lobby. Please walk, don't run. Once outside, you'll be directed to an assembly area. Stay there until we're clear to come back inside. If there's a small fire, our security officers are trained to respond using one of the fire extinguishers. You'll find them in 3 locations: by the stairwells on either side of the stage at the front of the boardroom, mounted on the wall in the back of the boardroom, and near the security area in the lobby. For anyone who needs an accessible evacuation route, you can use the door to the left side of the lobby, which leads into the parking garage. From there, turn right and follow the walkway to the street level. NTSB staff will be available to assist anyone who needs help. And finally, safety is everyone's responsibility. If you see anything that seems off or concerning, please let a staff member or security officer know right away. Thank you for helping us maintain a safe and secure space.
Chairwoman Hamady, that concludes my remarks.
Thank you very much, Dr. Bauer, and thank you to Sherry for that video. For those who may not be familiar with the National Transportation Safety Board, we're an independent federal agency that's charged by Congress with investigating every civil aviation accident in the United States and significant events in other modes of transportation. At the conclusion of our investigations, we issue a final report that's deliberated at a public meeting and includes factual information gathered in the course of that investigation, analysis of that factual information, a set of findings, and a probable cause or causes. We also issue safety recommendations aimed at preventing recurrence of that accident or incident. The NTSB strives to identify and report accurately all relevant facts, conditions, and circumstances relating to each accident and incident we investigate. And when necessary, we hold investigative hearings. An investigative hearing allows the NTSB to gather sworn testimony from witnesses on issues identified by the investigative team for a specific event or systemic safety issues. Investigative hearings are fact-finding proceedings. The purpose is to receive testimony and evidence which may be of aid in determining the cause of an accident. This hearing is a critical part of our ongoing investigation of the fatal midair collision involving a Sikorsky UH-60 Lima operated by the U.S. Army under the call sign PAT-25 and PSA Airlines Flight 5342, a CRJ 700, that occurred over the Potomac River near Ronald Reagan Washington National Airport at about 8:48 p.m. Eastern Standard Time on January 29, 2025. As a result of that collision, the 2 pilots, 2 flight attendants, and 60 passengers aboard the airplane and all 3 crew members aboard the helicopter were fatally injured. Both aircraft were destroyed by impact forces. I'd like to take a moment to address the families who lost loved ones in this tragedy. On behalf of the entire agency, we are so sorry for your loss. We wish we would have met you in different circumstances, but please know that we are working diligently to make sure we know what occurred, how it occurred, and to prevent it from ever happening again. On behalf of everyone at the NTSB, we also are providing a transportation disaster assistance team today to be here to provide support for each of you. Can our colleagues from TDA stand? Just to make sure you know where they are in the audience. If you need anything, please don't hesitate to call upon them. I also want to thank the American Red Cross for being here. Volunteer mental health clinicians from the Red Cross will be here for the duration of this hearing to provide emotional support for anyone attending. Again, please know that your loved ones are why we fight so hard for safety. They are why we are meeting here today for this investigative hearing. Thank you. I do also want to commend each of you for your remarkable selflessness. In the wake of a tragedy, you have courageously spoken out and advocated for important reforms to save lives and improve aviation safety. I hope the information that we uncover during this hearing will support your efforts. Among those who perished on January 29th were 3 brave and highly respected soldiers who dedicated their lives to defending our nation. To their families, I say, you made their service possible. Alongside our condolences, please accept our enduring gratitude on behalf of a grateful nation. The contributions of military families like yours, through your love, your support, and your resilience, cannot be overstated. I'd also like to acknowledge and honor the many active duty service members and military veterans here today, as well as their families. Thank you for your unwavering commitment to our nation. Each of us is forever in your debt. I specifically want to thank Colonel Matthew Parker. He was our party representative for the Army, and I appreciate your support. Finally, I also want to thank the first responders on behalf of the board. Our over 90 organizations responded to the scene of this tragedy to support search and recovery efforts and assist us in our investigative work. Law enforcement, fire officials, dive teams, federal, state, and local agencies. We don't often talk about it, but they're human too. And what they experience can also be quite difficult. So thank you all for your public service, your dedication, and your heart. I'd now like to introduce the NTSB staff. Next to Dan in the front row, we have Mr. Bryce Banning, who's our investigator in charge, or IIC, of this investigation. Mr. Chihoon Shin, aerospace engineer for helicopters. Ms. Marie Moeller, mechanical engineer for vehicle performance. Mr. Sean Payne, branch chief for Vehicle Recorders Division. And Mr. Michael Portman, aerospace engineer, recorder specialist. In the middle row, we have Mr. Brian Soper, lead aviation accident investigator, air traffic control. We have Ms. Sarah Lewis, aviation accident investigator, air traffic control. Dr. Catherine Wilson, senior human performance investigator. Dr. William Bramble, national resource specialist, human performance. Captain Rocky Stone, aviation accident investigator, air carrier operations. And Captain Van McKinney, aerospace engineer, helicopters. In the back row, we have Mr. Brian Fuchs, materials engineer who will operate the audio visuals. Mr. Anthony Lamb, transportation safety specialist who will operate the timer. Dr. Jana Price, transportation safety specialist. Dr. Lauren Groff, chief data scientist. Mr. John Flynn, aerospace engineer, systems. And Mr. Tim LeBaron, director, Office of Aviation Safety. And behind me is Mr. Daniel Baranovsky, who will provide legal support. Now let's turn to the parties of the hearing. Thank you for all your cooperation with our investigation to date. Federal regulations guide how we designate parties to an NTSB investigative hearing. They are those persons and organizations whose participation in the hearing is deemed necessary in the public interest and whose special knowledge will contribute to the development of pertinent evidence. The parties to this hearing have been designated in accordance with these regulations and selected for their technical expertise in their respective fields. As I call the name of each party, I ask the designated spokesperson to identify themselves and then introduce others at their table. Please push the microphone button to talk and then push it again when finished. We'll start with the Airline Pilots Association.
Good morning, and thank you, Madam Chair. I'm Captain Daniel Mullen, for the ALPA Party Coordinator and Spokesperson. With me today, Chris Heck, Captain Matt Gorshey, Shay Bohm, Captain Mike Palazzolo, and Captain Russell Page. Thank you.
All right, thank you very much. And continuing in alphabetical order, Federal Aviation Administration.
Thank you, Madam Chairwoman. I'm Todd Gentry with the manager of the FAA's Accident Investigation and Prevention Division. With me is my lead investigator and party coordinator, Patrick Lush. Beside him is our helicopter subject matter expert, Matt Rigsby, as well as our air certification helicopter expert, Andy Shaw, and my general counsel as well, Chris Stevenson.
Great. National Air Traffic Controllers Association. Thank you, FAA.
Good morning, Chairwoman. John Murdoch with the National Air Traffic Controllers Association, Safety Chair. To my right is Karina Marinas, ASI investigator, Natalie Moffett, NACA employee, Seth Myers, Air Safety Investigator, Cher Oxenberg, Voluntary Reporting Representative, and Sandy Fulmer, Eastern Service Safety Area Representative.
Thank you so much.
Morning.
PSA Airlines.
Good morning. My name is Darren Hall. I'm the Vice President of Safety and Security and Development for PSA. On behalf of the entire PSA and American Airlines family, we continue to mourn the lives of our passengers and team members lost in the tragic accident involving Flight 5342. With me here at the table, Captain Lucas Bowden, PSA's Director of Flight Operations. Next to him is Chris Saylor, PSA Airlines Director of Safety and Regulatory Compliance. Next to him is Captain Grant Clow, PSA's Assistant Director of Flight Operations and Technical. And finally, our legal counsel, Ben Allen. Thank you.
Thank you very much. Sikorsky.
Morning, Chair Hamady. I'm Dave Blair, the Chief Pilot for Safety at Sikorsky Aircraft. And on behalf of Sikorsky Aircraft and all of Lockheed Martin, also want to express our sincere condolences to those affected by this tragedy. Behind me is Jill Browning, our Chief Air Safety Investigator. To my right is Paul Bowles, Counsel. And behind him is Kyle DeLong, our Director of Aviation Safety and Airworthiness for Sikorsky.
Okay, and the U.S. Army.
Thank you, Madam Chairwoman. First, I'd like to also provide my condolences to all the families of both aircraft involved in this accident as we get to the facts today. I'm joined here, I'm Brigadier General Matt Brayman. I'm the Director of Army Aviation. I'm joined here by my fellow colleagues, Colonel Matt Parker, who's the Army Party Coordinator, Colonel Kevin Easter, the Deputy Director of the Aviation Directorate, Colonel Noah Fontenez, our legal counsel. I've got Mr. Mike Osman, Technical Services from the Utility Helicopters Project Office, and Mr. Robert Braniff, also from the Utility Helicopters Project Office.
Thank you so much, General Brayman. As a reminder, only the designated party spokesperson may question the witnesses on behalf of their respective organization. Parties are essential in helping us develop the facts around an investigation. We appreciate your valuable time and look forward to working with you further as the investigation proceeds. On behalf of the board, I'd like to thank the many witnesses testifying at this hearing in support of aviation safety. Witnesses will be questioned under oath. They will remain under oath until the conclusion of the hearing. We ask that all witnesses, and this is important, to be present for the entire hearing, all 3 days, unless you have coordinated in advance with the hearing officer, who will then coordinate with me, because you may be recalled later for further questioning on another panel. The witnesses have been selected based on their ability to provide the best available information on safety issues that are pertinent to this investigation. The witness list was reviewed by the parties to the hearing last week at the pre-hearing conference. In the interest of time, I'm not going to describe the witnesses' credentials. Instead, we have pre-qualified each witness by documenting their qualifications in writing. You may review each witness's biographical information in the public docket, which opened at 9 a.m. this morning. You can find that at ntsb.gov. I'd now like to provide a general overview of the hearing. You may wish to refer to the hearing agenda for more details. We obviously began at 9 a.m. today. We'll begin at 9 a.m. sharply on tomorrow and then the next day, and conclude around 7 p.m. today and 7 p.m. tomorrow. We expect Friday's proceedings to wrap up earlier, but please be prepared to stay the full day. We want all questions to be answered. I will not rush the technical panel, the parties to the investigation, or the Board of Inquiry. We'll break for lunch as needed throughout, so please remain flexible, and we will take smaller breaks as well. This hearing will address key issues relevant to our investigation, which are organized into technical panels. The topics for each panel were finalized at a pre-hearing conference with the technical panel, parties to the hearing, and the Board of Inquiry on July 17th. There will be 5 panels that are brought together over the period of 3 days. Today, panel 1 will run until about lunch. The topic is overview of the accident, helicopters, air data systems, and altimeters. Following lunch, assuming we're done with panel 1, we'll move to panel 2, overview of the DCA Class B airspace and helicopter routes. That panel will run until about 7 p.m. Tomorrow, we'll begin with panel 3, training, guidance, and procedures applicable to DCA air traffic control, which will take us to the lunch break. Following that, assuming we're done with panel 3, we'll move on to panel 4, overview of collision avoidance technology, which will take us until about 7 p.m. The last panel of the hearing, panel 5, will take place on Friday, and that will cover safety data and safety management systems at various organizations. Again, please be prepared to stay that full day. We'll follow the same process for all panels. Dr. Bauer will introduce the topics to be addressed, as well as the technical panel members and witnesses. I'll swear in the witnesses who will be questioned in the following order. First, by the NTSB technical panel. Next, by the parties to the hearing. And finally, by the Board of Inquiry. Parties will have designated time during each panel to question the witnesses. During party questions, I'll recognize each organization one by one, round-robin style. Each party will keep their questions to 5 minutes or less. We have a timer to help you stay on track. Given that there are 6 parties to the hearing, we should have time to accommodate 2 rounds of questions per party. That goes for all panels. I'll make all rulings on the admissibility of exhibits, appropriateness of questions, and pertinence of proffered testimony. If a party spokesperson objects to any question asked during the hearing or wishes to discuss the admissibility of an exhibit or the pertinence of proffered testimony, please raise your hand and wait to be recognized by me. A word about conduct. This is not an adversarial hearing. The board does not permit cross-examination of witnesses in the legal sense, nor do we permit questions related to fault, outside litigation, or legal liability in general. Such questions are not relevant to the fact-finding purposes of an investigative hearing conducted by the NTSB or our statutory mission. This does not mean difficult questions won't be asked. They will be, and they should be. This is an investigation. We are here to improve safety. That is our sole focus. So with that, Dr. Bauer, please describe the exhibits.
Thank you, Chairwoman Homendy. Exhibits for this hearing include reports produced by NTSB investigative staff, videos, and other documents submitted by the technical panel members, witnesses, and parties to support the testimony and questions you will hear over the next 3 days. The exhibits for this hearing are in the docket. The docket number is SA-544. That's Sierra Alpha 544. The NTSB is authorized by statute to disclose information to carry out its mission, but we protect confidentiality and proprietary information to the extent possible. As such, the exhibits contain redactions. These are the results of negotiations between the parties and the NTSB regarding the disclosure of information claimed to be personally identifiable, security sensitive, or proprietary in nature. Though redacted, the exhibits contain sufficient information so that members of the public can refer to them during the hearing and throughout the NTSB investigation. The exhibits entered into the record in any presentations, along with other records of the investigation, become part of the NTSB public docket and are available via the NTSB website, ntsb.gov. The public docket opened this morning. Party spokespersons and witnesses have been provided electronic copies of the public docket containing the exhibits identified above. The docket is located on the investigation page, which you can access in one of 2 ways: by visiting ntsb.gov Or if you've joined us in person, you can scan the QR code on the hearing agenda. On the investigation page, you will find the link to the public docket on the right-hand side, just below the map. A transcript of the testimony taken during the hearing will be prepared and entered into the docket as soon as possible. In addition, Mr. Baranovsky will keep a list of any documents admitted during the hearing that are not currently exhibits in the NTSB public docket. These documents will be submitted after the hearing and entered into the docket. As a reminder, if a party to the hearing has a new exhibit to propose in accordance with 49 CFR section 845.9, it will not be admitted unless the chairwoman determines that a good cause has been shown. While parties do not participate in the analysis of evidence, parties can submit written comments for our consideration. This is where parties can state their views for the record, such as the potential conclusions that may be drawn. We strongly encourage the parties to submit written comments, which are beneficial to our analysis. Our regulations provide 2 separate opportunities to do so. First, parties may submit comments on the hearing. Per 49 CFR section 845.13, following the investigative hearing, any party to the hearing may submit proposed findings to be drawn from the testimony and exhibits, a probable cause, and proposed safety recommendations designed to prevent future accidents or incidents. The proposals shall be submitted within the time specified by the investigative hearing officer at the close of the hearing and shall be made part of the public docket. Parties to the investigative hearing shall serve copies of their proposals on all other parties to the hearing. Such comments are due to me, the hearing officer, within 30 calendar days after the close of the hearing, by September 1, 2025. We ask that any submissions be sent to us electronically. The second opportunity to submit comments is through the traditional party submission process outlined in 49 CFR section 831.14. Any party to the investigation may submit to the NTSB written proposed findings to be drawn from the evidence produced during the course of the investigation, a probable cause, and/or proposed safety recommendations designed to prevent future accidents. A due date for this submission will be provided by the investigator in charge at a later time. Parties may avail themselves of one, both, or neither of these opportunities. If you do send comments at any point, they will be included in the public docket. As mentioned, we will consider party comments during the analysis phase of the investigation and in the preparation of the final report. Chairwoman Hamady, that concludes my remarks.
Thank you. And just to reiterate, those comments for the hearing due 30 days from the close of this hearing, September 1st, 2025, by September 1st. Thank you so much, Dr. Bauer, for going through that. And I'm now going to turn it over to Bryce Banning, our investigator in charge, to provide an overview of the accident.
Morning, Chairwoman Hamady and members Inman and Graham. I'll begin my presentation with an animation. The animation is about 11 minutes long and will cover a summary of the event, depict the flight tracks of the accident, aircraft and show air traffic control communications as well as helicopter intercockpit communications. There will also be audio associated with the communications mentioned. The animation will conclude with an airport security video of the accident aircraft in flight and ends immediately when the collision occurs. Events after the collision are not represented in the video. We realize that some attendees and remote viewers may find this animation and security video difficult to view and hear. We would like to take a moment to allow those currently in the boardroom to leave for the duration of the video, or turn away from your screens if viewing remotely. We will inform you when the animation and video are finished playing. We will begin the animation now. On January 29th, 2025, about 8:48 p.m. Eastern Standard Time, a Sikorsky UH-60 Lima helicopter operated by the United States Army and a PSA Airlines CRJ-700 collided in flight approximately 1/2 mile southeast of Ronald Reagan Washington National Airport, or DCA. The 2 pilots, 2 flight attendants, and 60 passengers on board the airplane, and all 3 crew members on board the helicopter were fatally injured. The military helicopter flight originated from Davison Army Airfield, Fort Belvoir, Virginia. The flight was an annual evaluation for the pilot with the use of night vision goggles. The airplane was operated by PSA Airlines, doing business as American Airlines Flight 5342, a scheduled domestic passenger flight under Title 14 of the Code of Federal Regulations, Part 121, from Wichita, Kansas to Washington, D.C. Night visual meteorological conditions prevailed at the time of the accident. In the radio communications, the accident airplane was using call sign Blue Streak 5342, and the Army helicopter was using call sign Pat 25. The Federal Aviation Administration provides charts that specify helicopter routes to facilitate operations in high-traffic areas. The helicopter routes have no defined lateral boundaries, but they do have maximum altitude limits. The helicopter routes are depicted by a blue line on the Google Earth image. Helicopter Route 1's western section begins in Cabin John, Maryland, and follows the Potomac River southeast to Washington, D.C., through the Tidal Basin and the Washington Channel to Haines Point, and then turns east along the Anacostia River. At the time of the accident, helicopter Route 4 intercepted Route 1 at Haines Point and continued south along the Potomac River's eastern shore past DCA and the Wilson Bridge. North of Chain Bridge, the maximum altitude is 1,300 feet. Between Chain Bridge and Key Bridge, the maximum altitude is 700 feet. Between Key Bridge and Memorial Bridge, the maximum altitude is 300 feet, and south of Memorial Bridge to the Wilson Bridge, the maximum altitude is 200 feet. At 8:33 p.m., 15 minutes before the collision, Pat 25 requested permission to travel from Cabin John along Helicopter Route 1 to Helicopter Route 4 to Davison Army Airfield. The DCA local controller approved the request.
25 is looking for Captain John, Route 1, Route 4 to Davidson.
Pat 25 approved.
There was no communication between Pat 25 and the DCA local controller for 12 minutes. At 8:39 p.m., 9 minutes before the collision, Flight 5342 was cleared for the Mount Vernon Visual Runway 1 approach to DCA by Potomac Terminal Radar Approach Control. Select in-cockpit communications between the instructor and the pilot in PAT 25, primarily about altitude, will be shown on a black background in the animation. At 8:43 p.m., 5 minutes before the collision, Flight 5342 was handed off to the DCA Tower Local Controller. The local controller asked the crew of Flight 5342 if they could switch their approach from runway 1 to runway 33.
Bush 5342, Washington Tower 1 star 32017, gust 25. Can you take runway 33?
The crew accepted the change and they were cleared to land on runway 33. This magnified satellite photograph shows the locations of runway 1 and runway 33 at DCA.
Yeah, we can do 33 for Bush 5342.
Bush 5342 at the Wilson Bridge, change the start for runway 33, clear to land.
Change runway 33, runway 33 for land, Bush 5342.
There was no further communication between the local controller and the crew of Flight 5342 before the collision. The following animation shows the positions and altitudes of the accident aircraft for the final 3 minutes before the collision. An altitude profile view of the two accident aircraft is also displayed. Audio of the air traffic control communications will be played during the animation. The local controller was operating on 2 channels. While all aircraft could hear the local controller, helicopter crews could only hear radio transmissions from other helicopters, and airplane crews could only hear transmissions from other airplanes. Only communications between the local controller and PAT 25 will be shown in text on the screen. The controller twice advised the crew of PAT 25 about the conflicting traffic on approach and circling to land for runway 33. Both times the crew of PAT 25 reported that they had the traffic in sight and requested to maintain visual separation. The controller approved the request both times.
Pat 25, traffic just south of Wilson Bridge is CRJ at 1,200 feet, circle runway 33. This separation roof. American 1630 Tower, runway 1, lot boy, traffic throughout circle runway 33, this traffic on 6 mile funnel.
Flight up runway 1, American 1630.
Tower muscle 7, approaching Springfield, request around 3.
Runway 1.
Most 7, stand by. Bush 5307, keep rolling out to November, ground 47, good day.
November 307.
American 1630, wind star 32014, gust to 5, traffic 2 mile low base, runway 33, no delay, runway 1 clear for immediate takeoff.
Number 1, clear for takeoff, American 1630.
Muscle 7 0 request.
And Muscle 7 request, route 3 to Zone 6.
Muscle 7, you said route 3 to Zone 6. Muscle 7 approved.
American 472, National Tower, good evening. Air Care 1's within a single medevac helicopter, 1,000 feet, 29901 on the altimeter, requesting Zone 6 for Fairfax.
Medevac Air Care 1, Washington Star, National Altimeter 29900. Approved through Washington Class, Robert Airspace, Portland, Sheridan, Fairfax.
29990 for Air Care 1, copy.
Pad 25, do you have a CRJ in sight? Pad 25, pass behind the CRJ.
This club has a aircraft in sight, precision separation.
Miss Separate.
The following video shows the airplane and helicopter leading up to the point of collision. The video was recorded by a camera located near the approach end of runway 33 at DCA, oriented to the south. The video shows the night lighting conditions and the appearance of the aircraft lights against the cultural lighting of the city. Aircraft lined up on approach to DCA can be seen in the right corner of the screen. The flashing lights identify the touchdown zone of runway 33's landing threshold. Flight 5342 is visible in the upper left corner as it approaches runway 33. Pat 25 appears from the left side of the screen, moving to the right as the two aircraft cross flight paths. This concludes the animation.
Thank you, Mr. Banning. We're going to turn to the first panel. So Dr. Bauer, will you please provide an overview of the panel topics and introduce the technical panel and the witnesses?
Chairwoman Hamidi, the first panel is overview of the accident helicopters, air data systems, and altimeters. The panels will address helicopter static pressure and pressure altimeter systems, static system error and instrument error of the altimeter, total error effects on the accuracy of barometric altitude, military and civilian design requirements for helicopter air data systems and altimeters, design challenges for helicopter air data systems and altimeters, helicopter altimeter accuracy, standards, checks, and verification, and how accuracy of parametric data is verified and maintained for both civil and military flight data recorders. The NTSB technical panel, starting on my right, is composed of Mr. Chihoon Shin, aerospace engineer, helicopters, Ms. Marie Moeller, mechanical engineer, vehicle performance, Mr. Sean Payne, branch chief, vehicle recorder division, and Mr. Michael Portman, aerospace engineer, recorder specialist. Witnesses for panel one are composed of the following individuals, starting from my left, nearest the board members. Mr. Dan Cooper, Senior Technical Fellow for Avionics, Systems Integration and Test with Sikorsky. Mr. Lance Gant, Chief Scientist and Technical Advisor for Rotorcraft with the Federal Aviation Administration. Chief Warrant Officer Kylene Lewis, Department of Evaluation and Standardization with the U.S. Army. Mr. Steve Bradham, Chief Airworthiness Engineer with the U.S. Army. And Mr. Scott Rosengren, the UH-60 Chief Engineer with the U.S. Army. Chairwoman Hamady, these witnesses have been pre-qualified and their respective experience and qualifications appear in the docket as exhibits.
Thank you, Dr. Bauer. Will the witnesses please stand? Please raise your right hand and answer by saying, "I do." Do you swear or affirm that the testimony you will give in this hearing will be the truth? Thank you. You may be seated. As a reminder to the witnesses, you'll remain under oath until the conclusion of the hearing. We ask, and this is very important, we ask that you answer questions factually. Please avoid analysis or any speculation. If there's a question about the question, if it leads to speculation or you think it might, just direct the question to me and I'll make sure to clarify. Also, I'm going to ask our staff, we've already talked, but just a reminder, and then also the witnesses, please do not use acronyms. We all use it frequently, but there are a lot of people, both in the audience and watching virtually, who don't know what those acronyms mean. So we want to make sure that they can follow along. So please try. I know it'll happen, of course, but if we can try and do our best, I think that would be much appreciated. Finally, you have microphones ahead of you, so just push the microphone button to talk and push it again when you're finished. Thank you so much for being here, and I'll turn it over to Mr. Shin.
Good morning. We will begin panel 1 of this investigative hearing with a presentation from myself and Ms. Moeller. The purpose of this panel is to discuss the air data system and altimeters on the UH-60L Black Hawk helicopter. Investigators identified discrepancies related to the accident helicopter's altitude, leading to additional investigative work to determine the validity of the altitude information displayed to UH-60L pilots and the altitude data recorded by the helicopter's Flight Data Recorder, or FDR. To begin, it's important to start with some definitions of altitude, which is an aircraft's height above some reference point. In this image, there's an example of 2 different ways that altitude can be measured: above mean sea level and above ground level. We will discuss pressure altitude, which is then corrected to height above mean sea level, and radio altitude, which is measured by bouncing radio waves off a surface below the aircraft to determine its height above ground. A third type of altitude, GPS geometric altitude, will also be referenced. Generally, atmospheric pressure decreases with increased altitude. The air is thinner on top of Mount Everest compared to near sea level, such as Washington, D.C. The International Standard Atmosphere Model, or ISA model, defines an altitude for a baseline pressure of 29.92 inches of mercury at sea level. If you measure the static air pressure around an aircraft, it can be compared to the ISA model to determine how high the aircraft is. However, as you know from weather forecasts, atmospheric pressure can change, so a correction factor for local atmospheric conditions is needed to be applied to more accurately determine an aircraft's height above sea level. A barometric altimeter is essentially a barometer that measures static air pressure and displays an altitude in feet. The image on the right shows a UH-60L barometric altimeter. Local atmospheric conditions that necessitate a correction factor can be applied to the altimeter using a barometric adjustment knob. This local altimeter setting corrects the ambient pressure altitude to the helicopter's altitude above mean sea level. The barometric setting for the altimeter is shown on a 4-digit counter in the altimeter setting window, also known as the Colesman window. Local altimeter settings are broadcast on Automatic Terminal Information Service, or ATIS, and by Air Traffic Control, or ATC. Multiple cockpit instruments, including the barometric altimeter, measure static air pressure surrounding an aircraft as part of their function. Static ports supply static air pressure to these instruments via a series of tubes. Static ports can be located on the fuselage as shown in the yellow arrows in this image. Static ports can also be incorporated into a pitot tube, which is called a pitot-static probe. The UH-60L helicopter, as shown in the image on the right, has 2 pitot-static probes that are located on the left and right sides of the cockpit roof, immediately aft of the cockpit doors. The UH-60L helicopter has 2 independent static systems, identified as Static 1 and Static 2. Each pitot-static probe has 1 port for its pitot system, 2 ports for its Static 1 system, and 2 ports for its Static 2 system. The right pilot's barometric altimeter uses static air pressure from the Static 1 system, while the left pilot's barometric altimeter uses static air pressure from the Static 2 system. The simplified diagram on the right shows how the Static 1 system supplies static air pressure to the right pilot's barometric altimeter. An air data transducer also uses static air pressure supplied by the Static 1 system. Outputs from the air data transducer are used by multiple helicopter systems. One of these systems is the remote data concentrator, which receives uncorrected pressure altitude data and supplies that data to the Integrated Vehicle Health Monitoring System, or IVHMS, which includes the Helicopter Flight Data Recorder, or FDR. Next, Ms. Moeller will discuss the pressure altitude data from the Black Hawk's FDR that was analyzed for this investigation.
With that explanation of pressure altitude and barometric altimeters, I'm now going to discuss the altitudes recorded by the accident helicopter. This plot shows the FDR recorded pressure altitude in blue for a portion of the flight. The blue dotted line is the pressure altitude corrected for the local altimeter setting. The red line is what we determined to be the actual height above sea level of the helicopter based on radio altitude and terrain, which will be discussed further in the next slide. The Army crew was trained to fly the helicopter routes around DCA using the barometric altimeter. The triangles show 3 pilot altitude callouts recorded on the CVR during this portion of flight. Altitude callouts showed a possible lower than actual altitude understanding by the crew. To explain how we determined the helicopter's actual height above sea level, I'm going to start by walking through the altitudes recorded by the accident airplane. The CRJ recorded 3 types of altitude measurements: pressure, radio, and geometric. As discussed at the beginning of the presentation, radio altitude is measured by bouncing radio waves off the terrain below an aircraft, and geometric altitude is determined by GPS satellite triangulation. These 3 types of altitude are shown in this plot as recorded. Like pressure altitude, radio and geometric altitudes must be corrected for local effects. When these 3 independently measured altitudes were corrected for local conditions, they showed good agreement by being within 10 to 20 feet of each other, confirming they were reliable measurements of the airplane's height above sea level. After some additional checks at known ground locations, the CRJ's altitude was considered well validated. This plot shows the CRJ's corrected pressure and radio altitudes as solid lines, and the Blackhawk's corrected pressure and radio altitudes as dotted lines for the end of the flight. The Blackhawk was not broadcasting to ADSB, so no geometric altitude was available for comparison. For the final 5 minutes of flight, the helicopter was flying over the tidal portion of the Potomac River, so the radio altitude would be equal to the height above sea level. Additionally, later testing of similar helicopters, which will be discussed next, showed good agreement between geometric and radio altitudes while over the river, adding an additional level of confidence to the radio altitude's accuracy. While the radio altitudes of the CRJ and the helicopter, which are shown as red lines, were within 10 feet at the approximate time of impact, the helicopter corrected pressure altitude was 100 feet lower than the CRJ's corrected pressure altitude. This picture shows the instrument panel of a UH-60L. On the right side of the image, the radio altimeter is circled in red, and the barometric altimeter is circled in green. The discrepancies between the radio and pressure altitudes recorded on the accident flight data recorder and questions about what altitude was displayed to the crew based on their altitude callouts led to a series of altimeter tests. 3 UH-60L helicopters from the same battalion as the accident aircraft flew a formation flight where the right seat pilots wore cameras to record the instrument panel. After the flight, the data recorders for each helicopter were downloaded for comparison to the in-cockpit instrumentation videos. This led the lead helicopter was broadcasting to ADSB, so geometric altitude for that aircraft was also recorded. The altimeter testing found that on the ground, before the engines were started, the barometric altimeters of all 3 helicopters were within 20 to 45 feet of the field elevation, which would be considered within tolerance. Once the main rotor was producing enough lift to hover, the barometric altimeter readings dropped significantly and were lower than the helicopter's actual on-the-ground elevation or hover altitude. Notably, the barometric altimeters continued to be 80 to 130 feet lower than the helicopter's determined altitude above sea level when flying at speed over the tidal portion of the Potomac River later in the test. Additionally, the corrected pressure altitude recorded on the data recorders did not match the video captured barometric altimeter readings on the ground for any helicopter, but did show good agreement when flying over the Potomac for 2 of the helicopters. The results of the flight test led to on-ground tests of the pitot-static systems for each helicopter. For these checks, the pitot-static probes are connected to a test rig that simulates set altitudes by increasing or decreasing the pressure the probes see. The altimeters on 2 of the test helicopters performed well. On the 3rd helicopter, the altimeters still performed within or near the tolerance, but were less accurate. So, while the altimeters showed an 80 to 130-foot differences in flight, they were within 20 to 55 feet under a controlled test environment. A helicopter's rotor system produces the lift and thrust that allows it to fly. The wind that you feel when you are near a helicopter taking off is the downwash produced by the rotor, which changes the air pressure around the fuselage of the helicopter, making it challenging to measure an accurate static pressure to determine altitude. The controlled environment of the pitot-static ground checks eliminated all rotor downwash effects, and those results also match the flight test altimeter readings that were made before the engines were started. But once the helicopter rotors were turning and producing lift and thrust, the altimeter readings lowered significantly and stayed lower throughout the flights. In summary, we found discrepancies between the FDR pressure altitude and determined height above sea level for the accident helicopter. Subsequent testing showed discrepancies between the cockpit barometric altimeters and the determined height above sea level on 3 other UH-60Ls. The objective of this panel is to learn more about the design of pedostatic systems and the altimeters, the unique challenges in designing such systems for helicopters, and how the accuracy of these systems is determined and maintained. Another objective of this panel is to learn more about how parametric data, particularly from the air data systems, are validated for flight recorders. This concludes our presentation. Mr. Shin will now begin questioning.
For the witnesses for this panel, we'll ask our questions in 3 distinct topic areas: air data system design, pilot operational considerations with the barometric altimeter, and air data accuracy for flight recorders. So we'll start with air data system design. Mr. Cooper, can you please describe some of the engineering considerations on the placement of static ports on a helicopter?
When placing the pedo and static ports on a helicopter, you must first consider the total set of customer requirements, and then consider the complex flow dynamics, as was shown in your presentation, that occur throughout the whole flight operational regime of the aircraft.
And when you say customer requirements, can you expand on that, please? What that could entail?
For example, they have where they're going to operate. So if they have to land in austere conditions, sand, grass fields, have to consider impacts to material entering the probes or damaging the probes. Must consider maintenance operations on the aircraft. If the probes are placed lower, there is risk, of course, to the maintainers bumping in injury as well as damaging the probes. And then another area that needs to be considered: what other sensors are populated on the aircraft? Those sensors have their own needs for placement to meet their performance requirements, and they can create disturbed airflow in themselves in different locations that, of course, would affect that probe location.
And Mr. Cooper, how does the location of the static port affect the cockpit instrument readings during different regimes of helicopter flight, such as hover, cruise, sideways flight, backwards flight?
It's a function of the static position error that exists in those different regimes of flight. So the helicopter has, of course, a wide operational movement, forward, rear, sideward, rearward flight, as well as side slip limits. The static port placement must be able to handle the whole regime, although accuracy is normally presented in forward flight.
And Mr. Cooper, how are the aerodynamic effects of the cockpit instrument readings due to placement of the static ports identified during the design phase for the air data system?
When this aircraft was originally designed in the late 70s, placement was done by experience and general practice. Military helicopters from Sikorsky at that time placed the probes over the cockpit and was generally found to meet the requirements. Of course, today, computational fluid dynamics could be used to analyze, but in the late 70s, that was an opportunity. So the placement is made, and then flight test is utilized to gather the data to identify the resulting error of that placement.
And is there a design target for the amount of difference between indicated altitude and the actual altitude for the helicopter when designing a system?
Can you clarify, please?
So for the difference between what's indicated in the cockpit instrument to where the helicopter is actually at for altitude? Is there a target during the design phase that you try to achieve for the placement of the ports, for certain airspeeds?
For the UH-60, it would be based on any government requirements.
And what about for commercial helicopters that Sikorsky has designed?
Again, it depends on the category it's being certified. FAR 291325, provides guidance for static position error, as well as it provides wording that you must use a certified altimeter.
Okay. And with the complex flow environments that we've identified that are present with helicopters in designing these systems, can you please describe some of the mitigation strategies that may be used to account for these aerodynamic effects that you see in the indicated altitude?
For the Black Hawk, at the time it was designed and with the government requirements that were provided, really probe geometry, placement, its installation angles is the primary tool. The UH-60 government requirements specified a specific altimeter to utilize. So that would not make the altimeter indication system an option to address any corrections. Present day, of course, with advanced equipment, air data computers give you more of an option. But again, 1970s, late 70s, that was not available, and the government requirements specifically called out the altimeter to be used, and it was provided as government furnished material property.
And Mr. Bradham, how would the Army evaluate mitigation strategies developed by a manufacturer?
Yeah, so typically in flight test, but if I could just back up for 1 second and just to clarify, so for a pedostatic system, we talk about instrument error, which is the actual calibration error in the physical altimeter itself, and that's what you're checking when you check on the ground without the rotors turning. And then you have what is called position error or installation error, which is the error caused by aerodynamic effects around the aircraft. And those are two independent errors with different standards. And I would say the standards that the Army used and the standards that the FAA uses for civil aircraft are very similar, and these issues are not unique to military aircraft. But your question is how would we evaluate that? And you do an airspeed calibration in flight test, and that airspeed calibration determines, for a given flight condition, determines the position error of the pedostatic system, and then we can mathematically convert that into altimeter error, and we can assess that against a standard. So for the Black Hawk, the position error, that standard was a mil spec called mil-I 6115, which has a very similar, slightly more stringent standard than Part 29.
And if a helicopter did not meet that military standard, would there be a required redesign, or would there be a correction factor that gets applied that pilots have to utilize? This question to Mr. Bradham.
Yes, I think that would depend very much on the specific circumstances. There were, looking back through the historical documents, there were cases where there were small out of spec issues. One knot over a standard in one place, and the decision is made, by the government and the contractor that there's no further action required there. They can provide a correction to the operator when that's necessary, but again, I think it would depend on the particular flight condition and the particular size of and the effect of the noncompliance.
Mr. Cooper, for the UH-60L helicopter, the pedostatic probes are placed above the cockpit, which is closer in proximity to the main rotor. What are the technical considerations that would lead for those pedostatic probes to be placed closer to the main rotor?
In line what I stated before, it's a balance of the total set of requirements. So again, for a military utility helicopter operating in the landing conditions it does. Placement of the probes lower, as I said, could expose it to ingress of material, danger to maintainers, damage during ground operations. So that would tend to give guidance, provide an alternative by putting it above the cockpit, as was done on other military models, Sikorsky and others produced at that time.
And Mr. Gant, can you describe how the FAA approaches certification of static systems and barometric altimeters on civil helicopters?
Yeah, so as mentioned previously, for altimeters in civil transport category helicopters, that is regulated by Federal Aviation Regulation 29.1325 for altimeters. And the expectation is that the applicant for certification would comply with all the requirements within that paragraph, including the position air requirements that are in there. There are allowable tolerances.
And from the FAA's perspective, would there be a concern with the placement of the pedostatic probes as seen on the Black Hawk?
I don't have any opinion on that. I think there's different ways to design, just as you've shown in your presentation. Maybe typical today is more on static port locations on the fuselage, but there have been many instances where static ports are also co-located with the pedo system. So again, it comes down with compliance to the requirements and not necessarily the aspects of whether that's incorporated one way or the other.
And Mr. Cooper, aside from customer requirements, what would be other technical considerations to select a pedostatic probe versus a pedo probe with a separate static port that's on the fuselage?
Again, I sorry to come back to it, but it is the total set of requirements. In that picture you showed for the fuselage placement, that was a Naval Hawk aircraft, a Sikorsky-produced Naval Hawk aircraft, but it does not have a requirement for a sliding cabin, or also known as the gunner's window. So that area would be covered when the gunner's window is in the open position, as it can be in flight. So that would take that location, that example you've shown. It comes down to available real estate, the dynamic conditions in that area. In your discussions with me earlier, you mentioned tail ports, static ports, but again, there's equipment on the Black Hawk that would impact that operation. So it's considering all the requirements that the helicopter must meet, what's fitted to achieve that, and what available area on the fuselage can be utilized, and then with that, understanding the dynamic conditions that may be present on that fuselage if it's static, if it's suitable for a static port.
And Mr. Bradham, aside from the static 1 and static 2 systems on the Black Hawk, are there alternate static sources?
No, not on the Black Hawk. The S1 and S2 are redundant, and each static system, as you mentioned in your presentation, pulls from each side's pitot tube. So S1's fed from both right and left, and S2's fed from both right and left.
Okay. Can you please, Mr. Cooper, this question's for you. Can you please describe the types of errors that can add up to ultimately affect the indicated altitude on the barometric altimeter?
As was stated by the other gentleman, there's two prime areas. One of them has several contributions, but there's the static source error, and then there is the instrument error. The instrument error for this altimeter has several factors that builds up to its estimated error. Instrument error, consider a tolerance. There's a plus and minus. So when you come up with that error, there could be in the plus direction or the minus. Static source error, which is identified, the resulting is identified during flight test. It's usually a number as a function of airspeed, and it is not constant, but I would not call it a tolerance. There's not a plus or minus. There is a number that's identified during flight test as a function of airspeed.
And Mr. Bradham, from the airworthiness perspective, how are the stack up of these errors managed by the Army?
So for the, from an airworthiness perspective, right, we have standards for each of the individual errors as they occur. So instrument error, so for the altimeter itself was handled for the Blackhawk by mil spec. It was a mil spec. It was 81852 and 81851, and that lays out a number of individual tests under specific conditions for a number of specific errors. So for example, inside the altimeter, there's two separate calibration tests, one for the Colesman window gearing and one for the expanding aneroid capsules. And there's different standards for those, and those are independent errors. So we don't have a standard to roll all that together. We do it by each individual error that occurs to make sure it meets tolerance. And I believe that's how it's done, not just in the Army. But then you have position error, and as I said, that's a mil spec 6115 alpha, which has a standard for that. So and then, yeah, so that's how we manage it. Each one of the errors has its own tolerance defined, and there's corresponding civil standards. The FAA has a TSO, a technical standard order, that defines altimeter instrument error, and FAR Part 29 talks about altimeter position error, same as the mil specs used to.
Mr. Cooper, can you tell me about other designs for barometric altimeters? In this case, the accident helicopter's barometric altimeters uses aneroid wafers or capsules, as Mr. Bradham mentioned. Can you tell me more about other designs that ultimately allow for higher precision and accuracy for barometric altitude or pressure altitude?
So first, the time period, that was a common design. And as I said, in the government requirements, that altimeter was specified to be used and was provided by the government. As time has gone on, and certainly current day, air data computers became available, which provided they did not have the mechanical wafers, the mechanical indicating dial. They did not have the mechanical correction for the Colesman window. So those errors could come out. So the implementation of air data computer, which requires a different display medium, allows you to achieve a lower error at the instrument error analogy.
And Mr. Bradham, what are the factors that are considered in transitioning existing helicopters to newer technologies such that Mr. Cooper just talked about?
From an airworthiness perspective, we're just looking to see if it meets all the standard requirements. I would say that, the Army, DOD, we've moved away from the very prescriptive mil specs, and we use commercial standards more typically going forward.
And Mr. Gant, from the civil helicopter side, at what point do the design requirements warrant transition to newer technologies that we're talking about here with air data computers?
Well, we don't prescribe when a new technology has to be introduced unless it's one that we think would improve safety to the extent that we would go through the whole process of rulemaking to make that technology available, or a requirement, excuse me, in the federal regulations.
And Mr. Gant, with changing operational requirements in the national airspace key into that decision of whether rulemaking is needed to require newer technologies?
I would say it could factor into that.
And this question is for both Mr. Cooper and Mr. Bradham. Aside from rotor wash considerations, what other challenges are there in designing an air data system that provides accurate indicated altitude to the pilots?
I go from my perspective, the main issue is low speed operation, right? And that's the influence of the rotor wake, which is what you talked about, right? It's why you see, when an aircraft picks up to a hover, why you see the altimeter decrease, right? It's the rotor wake coming down on the static system, and that's at low speeds, common to helicopters, that can be an issue. It's why the Black Hawk pressure instruments, really below 40 knots aren't used. So I think that's the primary issue, but the configuration of the aircraft can affect the static position error.
Yeah, for low speed, it is obviously the rotor wash, but at more forward speeds, that rotor wash is not impinging on the probe, so that is not a factor at the higher speeds. Certainly above 60 knots normally is where we don't see that effect. Again, depends on the install, but it is the configuration of the aircraft, what else is installed, either originally or as the model has been utilized, and certainly the customer has updated configuration of the aircraft. So installation of items can have an effect on the static position error.
Thank you. I'll hand it off to Ms. Mueller.
Good morning. Mrs. Lewis, when flying at low altitudes, do you normally reference the radio or the barometric altimeters?
In my experience, when flying at low altitude, I would be referencing the radar altimeter.
And when would you transition roughly between the two?
In my experience, certainly 200 feet and below, I would be referencing the radar altimeter. However, if I was flying on a published MSL route, I would be referencing barometric altitude.
Ms. Lewis, can you go over the procedure for setting up the barometric altimeter and checking it before flight?
Yes, as part of the cockpit equipment checks, the barometric altimeters are set on the ground before the aircraft is started, and the requirement for the Army is that they are within 70 feet of field elevation.
And where do you get the barometric setting from, usually?
From ADS, the Automated Terminal Information System.
Thank you. Mrs. Lewis, what reason might you flag your barometric altimeter as being inaccurate?
Aside from the initial check on the ground, in my experience, the only reason I would have to question my altimeter would be if ATC were to call me and question what altitude I was flying at, if I was supposed to be flying at an assigned altitude or on a route at a particular altitude.
So moving gears a little, Ms. Lewis, what other helicopters have you flown?
I have flown the Alpha, Lima, Mike, and Victor versions of the Black Hawk, and those are the only helicopters that I have flown.
Okay, thank you. So on those other models, have you seen any differences between the Lima model and those helicopters for the barometric altimeter?
Can you clarify the question, please?
Okay, so when you're at hover in that flight regime, have you seen between like the Alpha to the Victor and the Limas different, like do they feel different? Like what is being displayed on the barometric altimeter?
In my experience, I'm not referencing the barometric altimeter to hover. I would be glancing inside at the radar altimeter while at a hover. I would not be paying much attention to the barometric altimeter to hover.
Okay, thank you. Mr. Bradham, could you please describe the standards related to the design of the static system for the Army helicopters?
Yeah, absolutely. And I think it's important, of course, to point out again that the standards are very similar between military and civil, particularly the ones used for the Black Hawk. And so we'll talk about all the different kinds of error, right? So the standards, you have a standard for the instrument itself, which was the mil-spec 81851 and 81852, which have the same tolerance. And that has a number of different tests inside it, a number of dynamic tests for things like hysteresis and friction. But I think the main ones to focus on here are the two calibration tests. You have a scale error test, which is where you test the calibration of the capsules themselves. And then you have a barometric scale setting test where you test the calibration of the Colesman window gearing itself. So you have standards for each one of those, and those standards vary by temperature and they vary by altitude. So for example, in the scale test, the standard at sea level, standard temperature is plus or minus 30 feet. But at 500 feet, that's plus or minus 35 feet. It changes. At extreme temperature, that can go to as far as 60 feet. And then the barometric scale setting is generally plus or minus 25 feet, but it too changes. And that's very similar to the FAA TSO, which is based on a Society of Automotive Engineers standard. And then you have the position error standard. As we talked about, that's for aerodynamic effects on the system, and that's in this case that was from MIL-I 6115, which is plus or minus 25 feet per 100 knots of airspeed, and that's very similar to Part 29, which is 30 feet per 100 knots of airspeed. And then I'll just mention it here, just that if you compare radar altimeter to baro altimeter, you have to keep in mind that radar is measuring true altitude, like if you put a tape measure out the aircraft to the ground. Pressure altitude is measuring a pressure altitude based on a temperature assumption, and so you have to correct for non-standard temperature as well. Thank you.
Thank you. So, Mr. Cooper, what amount of difference between the barometric altimeter and the helicopter's actual height is expected for EUH-60L?
Based in my review of the government requirements prime item development spec, I've not found a standard cited for static position error, not defined. Instrument error is identified by the MIL specs that were cited, 81852 and 8851. The MIL spec that was cited, 6115A, was identified in a report, but have not found it defined in the government requirements. So ultimately, the resulting error was identified by flight test.
So those identified by flight tests, and we've kind of already talked about this a little bit, but the error changes at different regimes, in different flight regimes.
So yes, the flight test data is presented as altitude error as a function of airspeed. So it is not necessarily constant number. And as in the report for the UH-60 Alpha, which the configuration is the same for the Lima, it is changing for the clean configuration, so I can't give you a singular number. For the configuration, it's called high drag. It's when the external storage support system, also called ESSS, and we often, at least in this course, we call it ESSS, so there's a lot of acronyms used there in case I say it again. That also has a different static source error curve That one is more consistent, though, and is a nominal above, I believe, 40 knots is a nominal 50 foot. I'll have to check on the speed, but it is, as you stated before, as is the clean, higher in a hover, but in forward flight, it's a nominal 50 in that configuration.
Thank you. Oh, and just for people who are listening, the ESSS, or the picture of the accident helicopter, the wing tanks out the side. Right. So how does Sikorsky manage that difference in altitude? What is it that you produce for the operator and the crew?
So the flight manual is approved by the Army. Its content is that which is approved by the Army. In the report of the test I cited, in that document, it recommended that the curves for the altitude position error for the clean, as well as the high drag external storage support system, be included in the flight manual, but it ultimately was not included in the approved version.
Thank you. So, Mr. Bradham, Mr. Cooper was just saying about how the flight manual discusses the differences for the clean configuration helicopter, but it didn't make it into the Army flight manual, the differences for the ESSS system.
I'm sorry, just clarification, both altitude errors
Both
are not
sets
in the
of
final.
altitude,
Just
sorry.
for clarification.
Do we believe that crews should be informed of this difference?
So for the external storage support system for ESSS, yeah, that level of position error between 80 knots and 100 knots of about 40 to 50 feet, that level of position error was identified, you know, in the original qualification of the system. We verified that level of error exists through the L. We've looked for records of the discussion. At the time, there would have been an operator's manual content review board, and we've looked for a record of the discussion about altitude. We've not found a record of a discussion about whether, you know, about a decision to include or exclude that information. I think it's important to put that information in context when you're thinking about what to provide to an aviator. In particular, error has no influence. Spec, and you know, in my experience, typical aircraft separation distances are 500 feet or more. So it would be, I'd be speculating if I went to the reason of why put that in record.
Now that it's been identified, do you plan on including it?
I would say we've been tasked by the program, the Airworthiness Authority has been tasked by the Program Office for Utility Helicopters to do the analysis, which we've done, and to provide a recommendation back, which is being done right now, which will then go to the PM office for their consideration as to how to whether and how to incorporate it into the manual.
Thank you.
Thank you.
Mr. Bradham, do you have the time frame for when that will be completed?
No, I can't speak to the program office in terms of the timeline. We've been.
Steve, or Mr. Bradham, I can speak to that.
Thank you.
I'm the division chief of the Utility Helicopter Programs Office. I was the one who tasked Mr. Bradham's organization to take a look at this issue. So typically we have a 30-day turnaround on tasks for the organization. We're about week 2 of that. And that's about the time we found out about this issue. And so we should have something back this fall at the latest. And we'd be happy to keep you appraised of that status.
Thank you. And I also ask that you bring your mic closer to you. Thank you.
Will do.
All right, Ms. Lewis. During our investigation, we saw the 80 to 130 foot differences between the barometric altimeters and then the radio and the geometric altitudes. Would you, as a pilot, consider this amount of difference impactful to your operation?
In my experience, a difference in 80 feet or so between the radar altitude and the barometric altitude would not be cause for alarm. Generally, I'm relying more heavily on one altitude instrument versus the other, depending on what I'm doing and what altitude I'm at. So I'm generally not looking at both and trying to figure out the difference between the two, depending on what I'm doing on that particular flight.
All right, this is for Mr. Cooper, Bradham, and Rosengren, just to start. But during the ground testing of the 12th Battalion helicopters, 2 of the helicopters, the barometric altimeters were within 20 feet of tolerance. But once we were in forward flight, 100 knot, with 100 knots of forward speed, the barometric altimeters showed errors of 80 to 130 feet. What types of errors do you believe could contribute to this 80 to 130 foot discrepancy?
Yeah, I'll start with that one, please. So when you think about all the different errors that could contribute to that, one, you have to make sure the Colesman window is clearly set correctly, and that the Colesman window actually reflects the right barometric pressure. So the flight tests you're referring to are the ones on the 15th of May, that 1 unit flight. So backing up, it's important to point out that that's really an anecdotal event. It doesn't use the standard flight test methods that the military and the FAA would use in order to characterize a pedostatic system. So there's not an independent truth measurement of barometric pressure and some of the other things that we would use here. But so in terms of the errors, one is the Colesman window. Then you have the instrument error, which is what you saw on the ground. All 3 of those aircraft were registering altimeter low on the ground, but within spec, right, for the instrument error. Then you have the position error. So 2 of the aircraft were clean, and 1 of the aircraft was ESSS. So the clean aircraft at 100 knots, you're looking at about roughly 7 feet altimeter low in position error. For the ESSS aircraft, about 50 feet position altimeter low for position error. And then you also have to correct for non-standard temperature, because you're trying to compare radar altimeter to barometric altimeter. And so that wasn't a factor for the accident aircraft because the conditions were close to standard and you were low altitude. But on the 15th of May, those flights, you were flying at about 1,000 feet and about 9 degrees hotter than standard based on the aircraft OAT. That's about 36 feet altimeter low. So the combination of those factors, the instrument error, the position error, and a temperature correction, which all happen to be in the same direction, doesn't always happen that way, but in this particular case did, that if you carry that for the 3 aircraft, those errors ends up bringing you to relatively good agreement between rat out and bear out, if you compare them that way.
Thank you.
And I concur with all the statements that were made. Just one clarification, because I was involved in that ground evaluation. One of the aircraft, the right altimeter, did fall outside the Army maintenance manual check limit, so that was out of spec, and in fact, its vibrator was inoperative. So that right altimeter data would be in question for that aircraft.
Thank you. Mr. Rosengren, do you have anything to add?
No, I just, the only comment I have there is whenever Mr. Bradham and I kind of went through the data, pursuant to some of the questions I think we'll have later, I was properly educated and pleasantly surprised. We was able to get to doing the air stack ups within 1 foot of the differences, and so we'd be happy to provide that data to you in writing later.
We would definitely appreciate that. Thank you.
Yes, ma'am.
So continuing on that, and you were talking about how it is anecdotal, and we do recognize that 3 helicopters is quite a small data, is a very small sample set, but it did line up with the existence of a possible wider discrepancy. And you have looked into that, clearly. Is there additional testing planned between the Army and Sikorsky?
So from an airworthiness perspective, we've gone back through the data, and we have airspeed calibration data for the Lima. We understand the static position error. So we don't have any flight testing planned. I'd leave that to the program office if they have other thoughts relative to that.
Yeah, no, as I mentioned earlier, I was as initial receipt of the data from the flight test and adult flight test you mentioned, I wanted to look into it, and I asked Mr. Bradham's organization to please let's get together and try to understand what's going on here to see if there is an issue. And again, after stepping through all of the various sources of error, and again, it's a very piece part manner. Everything was within specification, minus the discrepancy we've tasked them to look into. And so I don't see any need from a safety or airworthiness perspective to do any changes for the Lima helicopter. From my perspective, I advise the colonel who advises the Army the safety of the aircraft. My perspective is this is a safe aircraft.
Yeah, and we can, if you'd like, we can talk to the difference between the recorded pressure altitude in the IV in the recorder. Yeah. Oh, cool. Thank you.
So this conversation makes me conclude that this feels like this is an inherent limitation of a barometric altimeter.
That based on all the information we've worked together and along with our Sikorsky friends, I believe this is the expected errors in an altimeter system. So when we provide that data to an aircrew, there should be an expectation, as I believe they're trained to have that expectation, plus minus 100 feet or so.
Thank you very much. This is the end of my line of questioning, and Mr. Payne will begin next.
Get my microphone positioned here. Hello. I'm going to follow on with specifically pilot operational considerations, and we talked a bit more about stacking errors, and we touched upon setting the Colesman window correctly. I'm going to come back to that. So I'll start with Ms. Lewis, and I'll have some questions for Mr. Bradham also later, as he's an experienced Black Hawk pilot, it's my understanding. Ms. Lewis, earlier you described briefly setting the altimeter, or your operations around that area. As a pilot, can you walk us through in detail the process of setting the altimeter according to the Army's operational procedures?
Yes, as part of the cockpit equipment checks, the barometric altimeters are set generally based off of the local ADS information, and then it's compared to the known field elevation. And as long as there's not more than a 70-foot error, then the altimeter is considered reliable for flight.
Sure. I want to get into a bit of a discussion about the known field elevation. So you cross-check, obviously. Once you've set the altimeter according to the ADS, there's a 70-foot allowance. My next question goes into, how do you determine the field elevation for those who are unfamiliar in the audience? Where do you get that data from?
Field elevation is published on airport diagrams. It's published on approach place. It's published in a number of places for airports that we operate in and out of.
Sure, for operational airports. So continuing on with maybe where your unit was based, is it tribal knowledge or an official part of Army procedures to discuss if there's changes in elevation between where the measurement is taken, which for FAA airports typically at the highest point on the runway, if you're starting or performing that check, as you said, prior to rotors turning, are you do the Army's procedures account for a difference in the airport topography when you make that check and try to fall within the 70 feet?
The Army procedure is to check tower setting against the setting for field elevation, and then it's unreliable for flight if more than 70-foot error exists.
Sure, okay. Can you recall a circumstance where the published field elevation varied significantly from where you initiated the checklist procedure in your career?
As part of the checklist procedure, We don't attempt to determine if the elevation is different based on where the aircraft is parked. We base it off of the field elevation.
Okay. I'm just going to get, we talked about field elevation being published at FAA or, some kind of, whether in another country there's published data available. What if you're at a remote or unfamiliar airfield, you're operating there? Is there another resource you might use other than published chart, or would you rely on the topography of the chart itself in that situation?
I would rely on the known field elevation if there was one for where I was landing and taking off from. And in my experience, I would have generally departed from somewhere where I had an altimeter setting. And if I did not know what the field elevation was or was unable to determine it, I would maintain that altimeter setting until I was back in location to receive an updated altimeter setting.
Okay, noted. Yeah, I'm just trying to approach the situation from as many angles as possible. When you're flying in the national airspace system versus flying on deployment outside of the national airspace system, for example, do these procedures change at all, or there's more emphasis done in the NAS versus on deployment, or does it remain the same?
There's no difference in how we approach setting altimeters when we're operating in the national airspace system versus on a deployment.
Okay, thank you. I'm going to incorporate Mr. Bradham into this line of questioning as well, so I just want to totally lean on Mrs. Lewis. So Mr. Bradham, during flight, how would a pilot determine the barometric altimeter is erroneous and unreliable?
Yeah, so in my experience, the only time we've done that in flight right on the ground check, if you had a significant difference, between the right and the left side in the ground check before you took off. And I want to point out that ground check exists. The FAA uses that same, in the Airman Information Manual, uses a similar check with plus or minus 75 feet. But yes, and in flight again, if there was a significant disparity between the right and left side while you were flying, and I mean a significant disparity, more than 70, 80 feet, right? You would make note of that and come back. But if ATC contacted the aircraft and said, "Hey, you're not at your right altitude," and we were, according to our instruments, that then would be cause for concern. But otherwise, and I've, in my experience, I'm trying to recall if that's ever happened to me where I've had a barometric altimeter problem like that, and I don't recall one.
Okay. Yeah, Ms. Lewis, you previously mentioned being queried by ATC. Have you ever experienced that in your career, or thought to a situation where you might want to question whether or not the left and right side altimeters were comparable?
I have not had an experience in my career flying the Black Hawk where the barometric altimeter, if it passed the checks on the ground, was unreliable.
Okay, thank you. Let's say hypothetically you had a crew and the two pilots did detect an offset between the right and left baro altimeters. I'll start with Ms. Lewis. What would they do? And then as a follow-up, would there be anything in the Army's operational procedures that would require the pilots to make a report or report it to maintenance?
If there was a discrepancy between the left and the right pilot's altimeter, are you asking which altimeter we would use?
Well, no, not which you would use, but you've detected this discrepancy. It's more than 70 feet. Is there a requirement to report that then to maintenance, your command, make a note of it somewhere?
Yes, if there was a greater than 70-foot difference, that aircraft would not be flown. It would be placed on a grounding red X condition and be taken out of service until the altitude discrepancy was addressed.
Okay. I'm going to come back to this question, and you touched on it previously. You said you preferred a different altimeter for different type of operation, different flight regime. In Army procedures, is there ever an operational area where you would cross-check between the barometric altimeter and the radar altimeter.
In my experience, in a situation where I was flying close to the ground, maybe 500 feet and below, if I was supposed to be at an MSL altitude, but I was flying low to the ground, I would, in my experience, I would be referencing or cross-checking both instruments in that situation.
Okay. I understand it would be difficult because it would depend on where you're operating. If you're over sea level, obviously that calculation's much easier. Getting more into a bit of an acuity discussion, so it's discussed in our internal investigation. If you're flying in visual conditions during the day, what would the altitude visually that the pilot could recognize, would 100 feet difference be something that pilots are trained to know visually without reference to any instruments versus maybe 1,000 feet? Mr. Bradham or Ms. Lewis can take that.
Yeah, I'll give my experience.
Yeah.
And when you're very low to the ground, that's true, right? To be able to tell the difference between 100 feet and 200 feet, I would say yes. But at a much higher altitude than the difference between 4,000 feet and 4,100 feet, no.
Right. Yeah, exactly. If you're at higher altitude, also you can maybe tell difference of thousands versus lower. Let's see. Would this change at night? If you were, low-level flight, you say, I can tell the difference between 100 and 200 feet. At night, would you expect that calculation to be the same? I'll ask Ms. Lewis.
It's always more difficult to determine your altitude when flying at night, but I agree with what Mr. Bradham said, that if you're very low level, 200 feet and below, it's a little bit easier to determine, but even at 1,000 feet, 100 feet of difference is not something that in my experience, that I'd be able to accurately determine.
Sure, and then a quick follow-up there. If you're wearing night vision goggles, I guess, can you expand on the possibility of doing that under NVG at low level?
NVG's low level, if I have, it would help if there were known obstacles that I knew the height of as I was flying in the area out to the left and right of the aircraft. It really depends on what environment I'm flying in, what obstacles are there, buildings. It would really just depend on where you were flying out, how easy it was to determine a difference in 100 feet of altitude when looking outside the aircraft.
Okay.
Yeah. Can I intercede real quick?
Yeah, go ahead.
Just to follow up on Mr. Payne's question, for both Mrs. Lewis and Mr. Bradham, if you were flying in day visual conditions, could you notice a difference between flying at 200 feet versus 300 feet?
That's a difficult question to answer. From my experience, I would have to say that would depend very much on the terrain that was around and how familiar I was with that terrain.
I would agree with that statement. It would depend on where I was flying, and as I mentioned previously, if I knew the height of some of the obstacles or perhaps building or terrain in the area.
So to clarify, if you were not familiar with the terrain that you were flying through, then what does the answer change?
Can you just restate the question once just to make sure
If you're not familiar with the terrain you're flying through, could you pick up on a difference visually looking out the window between flying at 200 feet versus 300 feet? Is there enough of a difference at those altitudes?
Yeah, that's a difficult question to answer. I'm not sure if you'd be able to resolve that difference.
I agree. I don't know that I could 100% accurately determine the difference in altitude.
And my question was for day, so just to confirm my understanding, at night and under NVGs, it would be even more difficult to make that distinction?
Yes.
Thank you.
That was my kind of operations related section. I'm going to shift gears slightly for my last few to Mr. Cooper, discussing some differences between the Mike and Lima model. So, Mr. Cooper, please describe the pedostatic system design on the Mike model. Sorry, for the audience, the Mike model would be a newer version of the helicopter. If you want to just expand on that rather than me explain the why don't we just talk about the differences as well?
Again, it has its own set of requirements, to their vehicle, different engines, different, more capable rotor blades. So, but from an air data system, it utilizes the same pedostatic probes in the same location as the Lima. That is unchanged. It employs air data computers, ADCs. There is less plumbing because there are no, I will call them analog instruments equivalent to what is in the Alpha or Lima. So those probes feed directly, they feed the air data computers. The air data computers feed multi-function displays with digital data. And then those same ADCs through a redundant path provides air data information to the flight controls or any other subsystems within the aircraft which needs that information. There are two ADCs. Each go to their respective pedo probe, and the static, just as with the Alpha and Lima, is crossed. So there's the redundancy there.
Okay, so in summary, you've replaced, you said, well, older analog digital systems, there's less tubing because you have two ADCs and a glass panel display. I guess my ultimate question would be, given the differences between the Lima and the Mike, would you expect more accuracy out of the Mike versus the Lima in terms of displayed altitude?
Again, we talked about static source error and instrument error. I would expect improved accuracy for the instrument error aspect. The static source error is not changed.
Thank you. I'm going to pass the microphone over to Michael Portman, aerospace engineer from the Flight Recorders Lab. He's going to discuss air data accuracy for flight recorders.
Thank you very much. All right, good morning. So yes, as Mr. Payne mentioned, I'm going to start my questions with some design requirement questions for flight recorders. So I'll start with Mr. Gant on the civil side. What requirements exist for flight recorders in civil helicopters?
So for flight data recorders, there's a requirement in Part 91, which are the general operating rules, that if you are operating a multi-engine turbine-powered helicopter with a seating or passenger capacity of 10 or more, you must have a flight data recorder that records the parameters that are contained in an appendix. I think it's Appendix E, but of Part 91 that lists all the parameters as well as the accuracy requirements for those parameters.
Okay, and that was for Part 91. Are there equivalents in other operating parts as well?
Yeah, Part 135 has a very similar requirement for, again, multi-engine turbine air-powered helicopters with 10 or more passenger seating capacity. There's another break if you have a helicopter that carries 20 or more. There's a different FDR requirement, but still one.
Okay. Can you expand for a moment on, you mentioned that included in these appendices, there's also standards for accuracy of the data. Can you expand on that a little bit, specifically if you know anything about the altitude data?
Yeah, I think in the Part 91 Appendix E, I'll say the standards as I read them are fairly loose. I mean, for accuracy for the altimeter I think it reads from anywhere from plus or minus 100 to up to plus or minus 750 feet with a resolution of, I can't remember, either 130 feet or 150 feet on readout.
Thank you. One more question for you, Mr. Gant. What methods does the FAA require to ensure the continued accuracy of recorded flight data?
Yeah, so there's no specific rule that says how often you need to be, I'll say, interrogating a installed FDR to see if it's still providing realistic data. However, in the technical standard order, as well as in our advisory material, it is incumbent upon either the manufacturer of the FDR or the installer to come up with a maintenance program. And then our recommendation in the advisory material and AC 21-141B is that a reasonableness check for the FDR should not exceed being done beyond 18 months.
Okay, thank you very much. Turning to Mr. Rosengren. So looking at the design of the flight recorder system on the UH-60L, it's my understanding that this system was added after the initial production of the UH-60L. Can you just explain a little bit about when that occurred and what the motivation was for installing that system?
Yes, sir. So it was we call it a commercial off-the-shelf or COTS solution that we bought for the Integrated Vehicle Health Monitoring System, IVHMS. It included both a health and usage monitoring system, so a PCMCA card that a data card, I can't tell you what PCMCA stands for, a data card that you could pull out and download the parametric data that's also sent to the flight data recorder that we used for accident investigation, such as this. And so that IVHMS, the Integrated Vehicle Health Monitoring System, produces COTS. It was around the mid-2000s. So in 2005 and 6 is when we consulted with our who we purchased this. Component and DO-178 were considered to make sure that and so when we did the modification work, we got an airworthiness release from the Airworthiness Authority, the modification work order to and then before we went through the installation.
Okay, and then I'll follow up specifically on the parametric data side of things. Did you have any standards or ideas that you had for what sort of things you wanted to be recorded or what accuracy you wanted those things to be recorded with?
So the main reason we were putting the system on was twofold. It was for the health and usage monitoring system, which as the gentleman referred to, is our maintenance program that we use. So we download those parametric data after each flight or weekly. And we take a look at the data, make sure it's mainly there for regime recognition. So by regime recognition, that's where we try to determine how the aircraft was flown, so that if we have any particular parts lives that are depending on how aggressive or non-aggressive you fly the aircraft is dependent, then we can determine that from the parametric data that regime was in, and then we can decrement the parts lives appropriately.
Thank you. Next question. Which standards, or are there standards that exist that the Army uses or requires for the accuracy of the recorded flight data on the UH-60L?
So we had a digital source collector operation requirements document back from 1996. We have to provide that if we haven't done that already. And in that standard, it was encouraged to have a commercial off-the-shelf solution, for which we did. So we didn't give the vendor we bought the commercial off-the-shelf solution from a data accuracy requirement. We did make sure that Since it was commercial off the shelf, we made sure that it met the airworthiness requirements, but that it was capable to do the health and usage monitoring system requirement, as well as the flight data recorder function.
Thank you. Can you describe how the Army verifies the function and accuracy of the flight recorder upon installation?
Yeah, so at the end of the modification work order, there's a maintenance test flight that's performed. And as that maintenance test flight is performed, we have a maintenance operations check and MOC. And in that MOC, we record what the displayed altitude or other parametric parameters are. Select not all, but a select some. I'd be happy to provide that table to you. And then we record what was recorded in the parametric data.
All right, and then a follow-up to that. Can you describe similar thing, how the Army ensures the continued function and accuracy of the flight recorder in operation?
Sure. So as I mentioned, each time the particular installation has occurred, we do those maintenance test flights and we do the MOCs to make sure that the installation was successful. As we improve the system over time, we went through a substantial upgrade back in 2008, where the original 2005 system did not have an integrated flight data recorder. So the 2008 version, we put the integrated flight data recorder, of which we have the configuration today. We've had several software upgrades. During each software upgrade, they do a system integration lab test at the factory to make sure that the software performs as designed. And then we go through a similar airworthiness analysis of the MWO with the updated software. And then that MWO is then updated. And again, each time it's installed, we do the maintenance test flight and then do the maintenance operation check at the end to make sure that the data is correct.
And just to clarify, are there any requirements for downloads at certain times specifically to verify the function and accuracy of the recorded data itself?
So we download the data at the end of each flight. It's available for download and put into our data warehouse that we monitor through artificial intelligence and other means to make sure that the data is reasonable, and so that's performed on a regular basis.
And is that specifically for you mentioned for doing usage and vibration analysis and whatnot? Is that specifically for that, or is it to look at a broad spectrum of parameters?
Yeah, there's three specific parameters we look at. I can get to those particular parts, but there's three specific parameters we look at to make sure that the vibration data is not over any exceedances. And if those particular parameters are over exceedances, then we do an on-condition change to those parts.
All right, thank you. Moving on to some operational questions, although I am going to stick with you, Mr. Rosengren.
Yes,
how is the flight recorder data used within the Army? I know you'd mentioned that it's mostly used for this vibration analysis. Is there any other example of, or any times that you can think of where download of the FDR data or the flight recorder data of any type has been performed for reasons other than those you had mentioned?
In the operational Army, there has been programs over the years where we try to do a flight operations quality assurance type of effort. So those efforts have been done where we've used the downloaded data to do flight recreations, mission rehearsals, those sorts of things, but that never got out to the operational Army.
Okay. Can you describe how the data is downloaded?
Sure, there's the data card that gets pulled out of the system, and then that's taken to an aircraft notebook, a laptop computer, and you install input into the laptop computer, and then there's a procedure to extract the files and get it into the cloud-based system where we store our data.
Another question for you. When looking through the data, we did notice that that there is no GPS global positioning system data that is recorded on the flight recorder. Can you just explain why that is?
Yeah, as was mentioned before, the 60 Liam is an analog aircraft, and so when we did the modification work order and the installation to put the system on the aircraft, we got the signals that were available, and those signals were not available for incorporation into the integrated vehicle health monitoring system.
Thank you. One last question as I'm wrapping up, this time for Mrs. Lewis. On the UH-60L, the air data transducer provides pressure altitude information to the heads-up display. I'm curious, in your experience, have you ever done a cross-check while using the heads-up display between that altitude and the altitude that's in the barometric altimeter?
Sir, in my experience, using the heads-up display would be for low-level flight under night vision goggles, and I would not be referencing barometric altitude in my heads-up display.
All right, thank you very much. I'll turn it back over to Mr. Shin.
Mr. Fuchs, can you pull up Exhibit 7 Kilo Juliet, page 23? For the witnesses, that's the presentation backup slides that has the diagram for the right barometric altimeter and the uncorrected pressure altitude that it feeds to the helicopter's transponder for the UH-60L, and how that pressure altitude data gets transmitted to ATC ground radar and also out to ADSB. So, Mr. Bradham, on the UH-60L, if the right barometric altimeter provided inaccurate altitude indications, regardless of the source of the error, would the transponder transmit that inaccurate pressure altitude through the to ground stations?
Yeah, so the transponder on the right side has an encoder, and the encoder sends a signal in 100-foot increments, and that signal is based on pressure altitude, so it's referenced to 2992 as the Colesman window. So if the pilot made a mistake and put the wrong Colesman window setting in, or the setting was not indicative of the true static pressure, that error would not be transmitted. But any other errors in the system would be transmitted, but the encoder is transmitted in, it's only in 100-foot increments. So, yeah, cool. Thank you.
And Mrs. Lewis, for the UH-60L, are there procedures for what pilots should do with the transponder's functions if they detect that the right barometric altimeter has become unreliable during flight?
For the UH-60 Lima, the transponder is required for flight, so if there was an issue with the transponder, the aircraft would return to whatever station it departed from, and that issue would be addressed before flight was continued with that aircraft.
I'm sorry, if I may, could I just add one point, that the encoder, it's sending in 100-foot increments. It changes at the 50-foot mark, but the standard is at the 50-foot mark plus or minus 40 feet. So it can be 90 feet off inside its specification. Thank you.
And Mrs. Lewis, to clarify, if the right barometric altimeter was determined to be unreliable during the flight, knowing that it transmits its encoded altitude to the transponder, is there any procedures to disable the altitude reporting function on the transponder, or do you just leave it alone?
There's no published procedure for addressing that I'm aware of.
And would you notify ATC of the discrepancy that's identified if flying in the National Airspace System?
I would.
Mrs. Lewis, going back to one of the previous questions about cross-checking between the left and right altimeters, and this is a question that Mr. Bradham can answer as well. Is there a published procedure for pilots to cross-check between the left and right side for accuracy between the two altimeters?
The check is against field elevation. It's not between the two altimeters. So the 70-foot error, if field elevation was 0 feet, one could be 70 feet and the other one could show minus 70 feet. So it's not an error between, it's not checking for error between the two, it's the setting against field elevation.
Yeah, no, I concur.
And if there was a discrepancy between the left and right barometric altimeters identified during flight, let's say on the order of 100 feet, Mrs. Lewis, how would you verbalize that, or how would you triage that with the other pilot?
If there was a difference of around 100 feet, 100 feet, that's to maintain within 100 feet of altitude is the standard for us flying. So if it was right at about 100 feet, that would not give me much cause for alarm because it would still be within the standard of maintaining altitude within plus or minus 100 feet.
Mr. Bradham, when you were saying the additional 40-foot change on the transponder altitude, do you have documentation of that you could provide?
It's so the encoder standards. It's mil spec 81852, which was the mil spec for the altimeter. When you in the encoder section, it says the standard is at the 50-foot mark plus or minus 40 feet from that. And so it's in mil A 81852. It's paragraph 356. And under encoder, it said the switching point shall be at altitudes 50 feet plus or minus 40 feet removed from the nominal indicated altitude.
Thank you very much.
Thank you.
Michael Portman has another question.
Sorry to circle back. Just one last question for Mr. Gant. In Part 135, Appendix E, you had mentioned that there were standards for accuracy, in this case for altitude, that can vary between plus or minus 100 feet to plus or minus 700 feet. Can you clarify that those standards are plus or minus 100 feet that is recorded on the FDR as compared to what?
I would have to defer that question to get back with you folks.
Okay, thank you.
All right. Mr. Gant, the FAA has several restricted category UH-60L helicopters that are approved for civil use, including the Lima model. What are the static system and barometric altimeter design requirements for these restricted category helicopters?
So the FAA regulations for bringing in surplus military aircraft that have been designed and manufactured for use by the U.S. military, given a satisfactory operating history, which usually is at least 10 years, if they are surplus and they are determined to be airworthy by the FAA, they can come into the system utilizing, I'll say, the military records as well as military flight manuals. There will be no additional showing to the FAA to bring those aircraft and put them under registry under restricted category. And under restricted category, that severely limits operations, mainly to agricultural, external load operations, and forest and wildlife management, which usually translates into firefighting operations.
Mrs. Lewis, can you just clarify for us, when flying low level, what would be the primary instrument you would reference for altitude?
The radar altimeter, in my experience.
And would that change when flying on a helicopter route with a ceiling?
If it's a published MSL route, I would still be referencing radar altitude, but I would also be taking barometric altitude into more consideration than what I normally would be if I was flying at a low altitude, if that makes sense.
Okay. And is that so if I understand you correctly, you'd be referencing low altitude on a MSL route with a ceiling. You'd be referencing both the rad out and the barometric altimeter.
Yes.
And is that trained or is that a personal technique?
There's no standard for which instrument I would be looking at, but if I'm on an MSL route, I would have to be at some point referencing the barometric altitude to maintain the route altitude.
Okay. Thank you. Yeah, my question, I think, really was, is that a procedure that's trained in the Army to cross-reference those two instruments, one on a route of that nature, or is that more of a personal technique for you?
I would say that's more of a personal experience-based technique for me, but also coming back to if I'm on a published MSL route, the only way for me to maintain the prescribed altitude for that route would be to utilize my barometric altimeter as well.
Understood. Thank you.
Chairman Hamidi, that will complete the technical panel's questions.
Thank you very much. We're going to take a 15-minute break. We'll be back and start promptly at 11:35. All right, I think there were some lines at the restroom, so we'll give it a few more minutes. Don't worry. All right, welcome back. We're ready to proceed with witness questions from the parties to the hearing. I'll speak slowly as people take their seats. Okay, each party will have 5 minutes to question the witnesses. We'll have 2 rounds And parties, please remember, you must limit your questions to the topics listed in the agenda. Please also refrain from asking questions that call for speculation or analysis. Finally, remember that only your designated spokesperson may question the witnesses. We'll start with the airline. I'm going to start with alphabetical. We'll change it up every single time. So we'll start with the Airline Pilots Association.
Thank you, Chairman. This first question is going to be for Chief Warrant Officer, Ms. Lewis. You spoke about referencing barometric altitude while flying an MSL or a mean sea level altitude route. If the maximum altitude for the route is 200 feet MSL, would an error of up to 130 feet affect your operation and ability to fly that altitude accurately?
What's the 130-foot error that you're referencing?
So that's the specific potential altitude deviation we saw from 100 to 135 or 130 feet of the exemplar aircraft that was flying. So it's the potential barometric altitude discrepancy that we saw between the exemplar helos.
No, it would not affect my ability to fly that route as long as the aircraft altimeter setting is within 70 feet of field elevation for both the pilot and co-pilot altimeters. It would not affect my ability to fly that route.
Okay. Second question is going to be for Mr. Gant. As previously discussed, the NTSB and the Collins, they calculate a conceptual static error between the two systems. The error was calculated as 135 to 193 feet, depending on the assumed speed deviation. How does this affect safety of flight for helicopter routes with a maximum ceiling of 200 feet?
I'm not sure I fully understand the question.
So there was a conceptual static error that was calculated based on the forward speed of the helicopters. It was between 135 feet and 193 feet. This is from the airworthiness factual report on page 53. How do you think that error, that altitude error of 135 to 193 feet, can affect the safety of flight for helicopter routes that have a maximum ceiling of 200 feet MSL?
Yeah, I'm going to defer an opinion on that. My area is really around the airworthiness of the aircraft and not the operational aspects, flying routes, low-level routes.
Would anyone else on the panel like to respond for us on that one?
I believe you're referring to, Collins did an analysis to determine when the airspeed capsule light would come on in terms of a difference between the two sides, but that's not what the airspeed capsule light, I'm not aware the airspeed capsule light was actually illuminated. I think that was just an attempt by Collins to, I'd be speculating to the intent, but I think that's what the analysis was trying to say, and I'm not sure. I just recall those numbers.
Yeah. Yeah, I concur. Collins was trying to identify when an alert may be provided to the crew, what level of error. It did not mean that error was existing, and that alert is for something else. It's for flight path stabilization fault. It doesn't mean that error occurs. It's just they were trying to evaluate what could, at what limit would alert crew, and was that trying to scope the magnitude of the error that was present.
Thank you, sir. The next question, that is for you also, Mr. Cooper. Considering the increased airspace congestion across our continental United States, should older aircraft like the UH-60 Lima model, which lack a bit of modern instrumentation and rely on legacy systems, be more aggressively phased out, given that there's an increased potential risk in operations with commercial traffic?
I'm sorry, I think that's speculation, and my role is in engineering, design, and test, so I don't think I can comment on that area.
Okay. Last question for you, Mr. Cooper. Given that operational data from the UH-60 aircraft shows the deviations, once again, I'm referencing the 80 to 130 feet in the exemplary aircraft, between the field elevation and indicated barometric altitude, does Sikorsky view this as an acceptable margin within their flight envelope?
The data that was taken during that evaluation, understand how the test was executed, but as the Army has mentioned, that there were a series of factors, including the fact that one of the aircraft had an altimeter tested post that evaluation that was outside of the maintenance limits, and its vibrator function was not functioning, which in the mil spec for the indicator creates a larger instrument error allowance. I really cannot comment on that data because I do not believe it represents the aircraft's expected performance.
Thank you, sir. No more questions at this time.
Thank you. FAA.
Thank you, Madam Chairwoman. Mr. Gant, I just want to clarify one thing with you. Does the FAA evaluate or certify military helicopters to operate in the national airspace system?
Yeah, well, there's two methodologies to get a military surplus aircraft into the system under 2125. I mentioned earlier, like a UH-1L designed and built for use by the U.S. military with satisfactory operating experience. If surplused out and can be determined to be airworthy, it can be accepted without further showing. There are other military helicopters that were derived from a commercial aircraft before it was militarized and went into military service. And in that case, if that aircraft was surplused, you could bring it back into the FAA system, if you will, either under restricted category, or you could return it to its original civilian configuration and get it, I'll say, recertified to the appropriate part that it was certified to originally to get a standard C of A, airworthiness certificate for that aircraft. So there's two paths. Both can lead to just restricted category operations, but either way, you're going to be operating in the NAS with a restricted category airworthiness. So you're very limited on what you're allowed to do.
Mr. Brandom, how often are the static altimeter calibration tests performed on Army aircraft?
Yeah, so the maintenance, the maintenance that's required is the pedostatic test procedure, and that's done every 12 months, which is, I believe the civil requirement is every 24 months.
And I'd like to follow up. Would an air traffic controller know that there was a discrepancy error in the altimetry system?
So I'm not being a controller. I'm not sure what information they have access to. I would say that certainly controllers, well, I'd be speculating other than to say that controllers must certainly be aware that there are error tolerances for barometric altimeters.
Based on what the transponder is sending out, would they see a difference from where the helicopter actually is?
Well, the encoding transponder, right, is sending pressure altitude, and it's sending it in 100-foot increments. And again, it has the encoder could be, if the actual altitude is 110 feet, the encoder could send 200 feet.
Right.
Right. And so if the aircraft error is inside that band, then no, there wouldn't be any difference in what's being transmitted.
Okay, thank you. I yield back my time.
Thank you very much. We'll go with NATCA, air traffic controllers.
Thank you, Chair. We have no questions for the witnesses at this time. Thank you.
Thank you. PSA Airlines.
Thank you. A couple operational questions here real quick. Ms. Lewis, before I want to go back to some of the questions that Mr. Banning asked was, you say that flying at low altitudes, you use the radar altimeter below 200 feet. But when flying on the published route, you'll use the MSL. You use a barometric altimeter?
That's correct.
Is there any published standard in the manuals for which altimeter you should be using? Or is it just up to the pilots?
There's not, but to go back to what I previously stated, if I'm flying a published MSL route, I would have to be referencing my barometric altimeter to stay on that route.
Sure. So is it left up to the pilots to decide which instrument is primary?
If I'm flying a published MSL route, I would have to be referencing my barometric altimeter in order to maintain the published route altitude. That's not to say that I wouldn't also be cross-checking my radar altimeter I'd be referencing multiple instruments as I was flying the route. I would be looking at both, but in order to stay on a route with a published MSL altitude, I would have to be in some part of my cross-check relying on my barometric altimeter.
Okay. So, yeah, I understand. And that's basically, is there any briefing that goes in before the flight if you're doing the low altitude flying with your pilot or the pilots up there to discuss which instrument they'll be using or cross-referencing or which one's primary?
In my experience, the crew would discuss the altitude of different routes of flight prior to flight, but there would not be a specific discussion as to what instrument we would be looking at in the cockpit along the route of flight.
In your experience, which instrument is more accurate?
I can't speak to the accuracy. That's a difficult question to answer. As far as my experience, which instrument is more accurate? Both the radar altimeter and the barometric altimeter have tolerances, as Mr. Bradham has discussed, and as long as the aircraft is within those tolerances, I don't have any further reason to question, as a pilot, their accuracy.
Step back to my mic here a little bit. This is for you again, Ms. Lewis. You stated that at 100-foot discrepancy between the altimeters being used by each pilot would be within specs. Would your level of concern be raised where you are operating with a 200-foot ceiling?
I didn't say within specification. I said it would be within standard, as Army pilots are expected to hold their altitude plus or minus 100 feet. Mm-hmm. And as far as along the route of flight, no, that would not raise my level of concern if I was on a 200-foot MSL flight. That's just in my experience.
Yeah. Okay. I yield back the rest of my time. I have no more questions.
Thank you. Sikorsky.
Sikorsky has no questions at this time.
U.S. Army.
Thank you, Madam Chair. Just want to follow up on two questions. In reference to the earlier line of questioning about distance or height estimation while flying, I'd just like to ask both Ms. Lewis and Steve Bradham, based in that same vein, based on your confidence, what would you have a higher confidence level at low altitudes at nighttime using night vision goggles for height estimation or being unaided?
Night vision goggles, sir.
Yeah, sir, it's been a long time since I wore night vision goggles, but I'd say night vision goggles.
And then just to follow up a question for Steve Bradham. If we talked a lot about the inherent errors that are within acceptable range of the static system and the altimeters. Those can compile and still be within standard. Could you describe what the kind of max extent of that acceptable deviation could be, and that could be presented in the cockpit?
Yes, sir. So as I said, the way we do, the way we qualify these systems is we look at each error individually. Instrument errors inside the altimeter, the static position area of the aircraft, based on the flight condition. We have standards for those individually. When we talk about a stack, they can combine, but I'm not aware of a definitive standard for the combination because you have to deal with different flight conditions and whatnot. But there's a couple of different ways to look at that. One way is just to say the maximum instrument error you could see and fly the aircraft would be 70 feet on an altimeter. And then you would add position error to that, which by the spec would be 25 feet. So that's 95 feet of error. That doesn't include a mistake in the Colesman window or not having the right barometric pressure in the altimeter setting. So that's a kind of a rough approximation of a maximum error that you might see, 95, roughly 100 feet. I think if you did that same math on the civil side, you'd see their altimeter check was 75 feet, and 129, or sorry, far part 29 gives you 30 feet of position error, so that'd be 105 feet.
Okay, thanks, Steve. Just to follow up with the FAA, and again, you probably can't answer this, but I'll put it on the record and we can come back to it in a later session. How does the FAA account for the known deviations within instrumentation errors that are acceptable?
Pretty much as already described. Again, the Airman's Information Manual, I think even in the IFR Flying Handbook, talks about setting your barometric altimeter on the ground and verifying with you're within 75 feet of field elevation, and then the periodic checks every 24 months to do the ground tests of the altimeter system.
Army has no more questions. Thanks.
Thank you very much. We're going to turn to the Board of Inquiry, and I'm going to go ahead and start. Ms. Lewis, I have a few questions. First of all, I just want to clarify. If you're on a published MSL route with maximum altitude of 200 feet, I'm going to be even more clear. You're on the Potomac River, maximum altitude 200 feet. Would you be referencing your barometric altimeter or your radio altimeter?
I would reference both, ma'am.
You would reference both. And is that by practice or by policy?
That would be by practice, ma'am.
Okay. Would it surprise you if we interviewed standardization pilots and other pilots at the 12th Battalion who said they relied on the barometric altimeter?
Would that surprise me? I would be surprised. I would think most pilots would be cross-checking both in those conditions, ma'am.
Mm-hmm. Okay. But is there a policy?
No, ma'am. There's no policy of
by training and by
instrument
practice
specifically to look at.
Okay, great. So the formation flight of the 12th Battalion, the tests we did at Davison Airfield, true altitude is 45 feet. So Ms. Lewis, the barometric altimeter on the ground, no rotors turning for one of the helicopters showed 0 feet. Would that concern you at all, and why not?
No, it would not. The field elevation there being 45 feet, that would be within the 70 foot
Within the
tolerance.
plus or minus 70 feet?
Yes.
Okay, and so the expectation once you take off, rotors are turning, you lift, you do a hover check, you take off. Are you thinking about that plus or minus 70 feet, or you've checked it at Davison Airfield and you say, okay, it's within tolerance, I can go? You're not doing math the entire time, correct?
I would not be doing math the entire time in my experience.
Great. So then you have, so for our test, rotors turning 100%, no collective input, again, 45 feet. All of a sudden, the barometric altimeter drops to negative 25 feet. Is that a concern, and why not?
Ma'am, might I speak to that?
Yeah, sure.
Ma'am, when you pick it up to hover, when you have rotors turning, what you're seeing is the rotor wake influence on the pitot tubes, and it's a standard effect, and I think pilots are aware of that effect, but they're not really looking at barometric altitude because we know below 40
You're looking
knots,
at radio altitude.
Well, yes, ma'am, particularly at low speed. When
Right.
you pick up to a hover, you're not picking up to a hover based on barometric altitude.
Plus, it's within tolerance. Okay. So now you're doing a hover check, drops to negative 50 feet. Any concerns there?
No.
Okay. Why not?
Because I would be looking at radar altitude at a hover, ma'am.
Okay, great. And now you are flying over terrain. Your barometric altimeter is negative 50 feet. Radio altimeter is 14 feet. You're at 60 feet. Do you have any concerns about the discrepancy? Off by 110 feet. You're probably not doing math, though, right? You're probably looking at your radio altimeter right then.
Yes, that's correct. I would be looking at my radar altimeter at that point in time.
Okay, now you're over the Potomac River in this area of the crash. Let's say your barometric altimeter says 1,070 feet. Your radio altimeter says 1,200 feet. There's a difference of 130 feet. Do you question it? You're looking at both. Which one do you go with? You're on an MSL route, max 200 feet, altitude, or not, let's just say 2,000 feet. 1,070 feet, 1,200 feet.
I would be referencing my barometric altimeter at that altitude.
Okay, and plus you said 100-foot difference, you said is not cause for concern.
Correct.
So you're looking at your barometric altimeter, which is 1,070 feet. What happens if you're on the Route 4 near the area of this midair collision, max 200 feet, and you're looking at your barometric altimeter, which you said you would be looking at, and you know there is a 75 feet between the glide slope and the east bank of the Potomac River? Would that cause for concern if you had a 100-foot discrepancy between the two? And which one would you go with then?
If I knew those facts ahead of time going into that situation, I would be referencing the barometric altitude very heavily, but I would also still be doing that quick cross-check of radio altitude to determine what altitude I was at that point.
And that's assuming you knew it?
Assuming I knew that ahead of time, yes.
Right, okay. Do you think you should know those things?
Can you clarify exactly which things?
Sorry. Do you think, sorry about that. You think you should know where those, if you're operating at such low altitude, do you think you should know when there's only 75 feet and your max altitude is 200 feet?
Yes, I would very much like to know that.
Okay, thank you very much. And thank you for your responses. For the Army, have you looked anywhere else in the national airspace to see if this sort of, oh, I'm over time. I'm so sorry. I will add 2 minutes to their time. We'll go on to Member Graham, add 2 minutes to theirs.
Not a problem. Okay. Ms. Lewis, you pretty much have said that when an Army pilot begins a hover of their aircraft, that they are looking at the radar altimeter. Is that correct?
That's correct.
Is there an altitude after the hover as you depart the field or where you take off from that you transition to barometric altimeter?
In my experience, it's not a set altitude, but as I'm climbing out of the airfield and once I'm no longer at a hover, generally I'll start referencing my barometric altimeter more heavily than I would have been before.
Okay. Is there a set altitude where a helicopter pilot in the Army should be transitioning to a radar altimeter?
There's no exact set altitude, but anytime I'm conducting, say, terrain flight 200 feet or below, I would generally be referencing my radar altimeter.
200 feet or below would,
yes.
Yeah, okay.
And that's just in my experience.
Your experience, okay. How do Army pilots ensure obstacle and terrain clearance while flying the Washington routes or at a low altitude?
In my experience, I've never personally flown the Washington helicopter routes.
Okay. Mr. Bradham, have you flown the routes?
I have not, sir, but I know on subsequent panels you have an Army witness who's very experienced. He's a standardization instructor pilot for that
I'll
unit.
ask him those. But in your experience, Ms. Lewis, how do you keep obstacle clearance or terrain clearance while flying at low altitude? What altimeters are you using?
My radar altimeter.
Your radar altimeter. Okay. I assume you both have seen the Washington routes and their barometric routes. Have you seen other routes like this that are similar to Washington? Either one of you.
Sir, I'm trying to think. In my experience, I don't think I have seen a I certainly haven't seen one that has such narrow vertical separation with an approach path the way that Route 4 and runway 33 do. There are other helo routes through Class B airspace, but I'm not the.
Okay.
I'd be speculating, sir, if I went further than that.
I flew low altitude at fixed wing in the military, and I thought it was very unusual to see routes 200 feet or less, 300 feet or less that are MSL routes. And I'm looking to see, do you know of any other routes like that that are defined that way, that low to the ground?
Yeah, I do not, sir.
I thought these were very unusual myself. Let me switch here just a bit. Let's, I think we were talking about the Mode C altimeter, what the transponder that sets the altitude, sends the message out on the altitude of the aircraft. And that is sent out, is my understanding, on the Lima model from the right side. Is that correct?
That's correct, sir.
Is that the default, or is that the only one that sends out the
So that's the only one. So the right side altimeter is an encoding altimeter. The left side is not.
The left side is not. So this analog, there's only one.
Yes,
There's
sir.
no Z. Does the mic model have the ability to change which altimeter sends out?
Yes, it does, because it has a different design. Its integrated system has a redundancy capability where if one fails, there is an alternate data path from the other sensor.
Well, let me stay with you on that, Mr. Cooper. So the Lima model, if there's a large altitude split between barometric altimeters, there's going to be no indication to the crew that's alerting them that there's a large split in the altimeter. Is that correct? Other than the crew looking and noticing it and talking about it. Would that be correct?
Correct.
What about the mic model? Is there something in the air data computer that if there's enough altitude split between the two, that they're going to get an indication that something's not right?
The capability exists. It's in the multifunction display system and software. It identifies whether the selected altitude between the pilots is over a limit.
Okay.
Because the design has the capability to select the same sensor. So it's meant to not only catch sensors, but display issues. So it compares displayed altitude.
Most aircraft that I'm aware of, fixed wing and otherwise, that have air data computers have a system like that and have a maximum split where there's going to be an error that will notify the crew that something's off. Would that be a correct statement?
All I can talk to is there are other modern Sikorsky helicopters that also have that miscompare capability. In the analog era of the Black Hawk and even the original 76 when it was analog, that capability couldn't be implemented because the hardware means didn't support it.
Okay. This aircraft, I believe, was delivered in 2000. Am I correct on that?
2001.
2001. Are they still making the Lima model?
It is not in production, no.
When was the last year Lima was made? Lima was.
I don't have that date.
Okay. Does the Army have a plan for phasing out Lima models?
The Limas with the mics because they are much more capable, as you've alluded to.
What's the average life of a Lima model?
Since they came into service 1989 or so, right?
Yeah, the first Lima was delivered in October of 1989.
And do you know what the average life that the Army is getting out of the Lima?
I can provide that data. The specific data is post this investment. I don't have it in front of me now.
Okay, that would be great. Thank you very much. I see my time's up.
Member Inman.
Thank you, Chair. And Mr. Rosengren, I'm going to start with you. And I will start with this. I thought I was going to be much more frustrated by the second panel, but I'm already that way. So I'm going to ask a very simple question. You just said you don't know the divestiture schedule for these models, correct?
No, sir. We know the divestiture schedule. What we don't have, I don't have the data in front of me, is the average life of the llamas. We can get that down to you by tail number.
But earlier you said your only plan right now, based on the work that these experts have done and the research, your plan is that you hope in 2 weeks is to update something in a manual for them to tell them about this discrepancy? That's the only update you plan?
No, sir. We've asked our airworthiness organization to give us a recommendation. Once we get that recommendation, if it is determined to be a risk, we hold a system safety working group, which has user representations, safety representation, PM representation, and that safety body, independent safety body, will make a recommendation to the PM and the program executive office, which will be
Okay, hang on a second. What are you going to do in 2 weeks?
In 2 weeks, we'll get back the analysis from our airworthiness organization, the System Requirements Directorate.
So you don't even know if you're going to make any changes based upon the research we've already done?
So when we get the data back, then we will take that recommendation from our independent airworthiness organization, and then we will take appropriate steps.
Who is your independent airworthiness organization?
The System Requirements Directorate is the independent airworthiness organization that Mr. Bradham works for under the Aviation and Missile Command, which is a separate command, a separate four-star command that ultimately reports up to different change.
So I guess the bigger question is, are you telling me right now then, from what you've seen already, these Lima models are safe to operate in the national airspace?
So based on the specifications of operating the national airspace, we do meet the specifications of operating the national airspace. So with
Okay,
that,
then I'll stop you then. The next question is, are the specifications wrong?
so that's something I cannot speak to because I'm not necessarily an expert of flying in the national airspace. But when we receive the requirements, we make sure we comply with the requirements.
Okay, who can speak to that?
So the FAA provides the requirements for flying in the national airspace.
And then the military describes, or basically sets the parameters for how to design the airplane or the helicopter?
So when for a military aircraft to fly in the national airspace, we have to go through the same qualifications as any commercial aircraft. So we don't own those requirements for flying in the national airspace. We only comply with them.
FAA, would you like to comment on that?
Well, again, the civil aircraft flying in the NAS, if they're under a standard certificate of airworthiness, have met all the design standards at the time that they were certified.
Okay. So I just want to clarify something else because I think it's important because there's a lot of important people that worked on these airplanes. The altimeter differences that they've been discussing recently are not the effect of a maintenance issue, but it's a design issue.
Sir, I think what the discrepancies that have been seen can be explained by a stack of the different errors between instrument and static position error, and, for example, the temperature effects on the in the 15th of May for that particular set of flights. So I think you can explain that deviation as being within the tolerance band for those different errors.
How much tolerance should we have for aviation safety whenever civilian lives are at risk?
Yes, sir. Safety is critically
No,
important.
I ask you, how much tolerance for safety should there be when civilian lives are at risk?
Sir, in terms of airspace separation, for how much separation should there be between aircraft that are using barometric altimeters?
No, you just told me, I believe, all of this equipment in this manufacturing process is within the tolerances for safety. How much is that tolerance? I think it should be zero.
Sir, I think your line of questioning, I had those similar thoughts when I saw some of the data that your team poured up with. And then when Mr. Bradham walked me through, here's the physical limitations. There's nothing anyone can do when we have these machines that provide this data. And so we have to understand there are physical limitations to that, which is offhand plus or minus 100 feet. So from my perspective, when I was flying out here, going to fly in on the exact flight that had the accident. And so my condolences to the families. I can't imagine what you're going through. My thoughts and prayers are with you. But knowing that there's plus or minus 100 feet, any qualified Army pilot or any civil pilot will go. The fact that we have less than 500-foot separation is a concern for me personally.
Okay, so I'll ask you this question. There was a quote someone said, modernization decisions may made this decade will affect the next generation of Army aviators. Do you remember that one?
Yes, sir, I wrote that article.
And that article described how we need to update and outfit with additional technologies?
Yes, sir, Blackhawks are going to fly for another 50 years, and so I think it's very, very pertinent and very vital to upgrade the Black Hawk fleet today so that we can have 60 mics and even more capable aircraft in the future.
So should the Limas be flying today?
If I was king for a day, I would take all the Limas out of the fleet today and replace them with mics and make them better so that our soldiers have the most effective
Well,
lethal
you're not the
fighting
king.
aircraft. No, sir, I'm not.
I'll pass to the next round, Chair.
Thank you, Member Inman. Great questions. Are you a party? Is the Army a party to this investigation?
Yes, ma'am.
So the reason why we have parties to investigations, the entire reason, is so that you can get data and get access to what we're finding in real time so you can make safety change immediately and not wait till the end of our investigation to do that safety change. When did the formation flight occur?
May 15th.
May 15th. So I'm a little bit confused. You have this formation flight, you know the discrepancies. What is the Army doing with the Limas, either at the battalion or the fleet, to address this? Do you plan? Did you test the other helicopters or the other Limas at the battalion?
So when
Yes or no? Did you test the other Limas at the at the 12th Battalion to look at whether there were any discrepancies outside of what you would anticipate?
I'd have to defer the 12th Aviation Brigade for their maintenance schedule.
Okay, how about Army-wide?
So when we discovered the discrepancies on May 15th with some of the altitude, we queried our Sikorsky friends and got the data. We verified that the data wasn't...
Wait. When was that data obtained by you?
The Sikorsky data?
Mm.
So it was obtained in 1983. We have a model-based...
No, that you just asked for.
That was the 50-foot ESSS error, or external source support error.
Ma'am, I can speak to that.
Thank you.
So it came out of the factual report that came from one of the exhibits here that Sikorsky had provided input to, and we then went through the history of that, and we looked at a number of potential contributors. We wanted to make sure that that error existed in 1983. We confirmed that. We wanted to make sure that that error still exists, because there have been some changes to the aircraft over time. Went back through our airspeed calibration records, through some other, investigated some other questions to make sure that in fact that error exists. We have, right before this hearing, have gone through all our models and verified that we believe that that error exists.
Which error specifically?
And I'm speaking to the position error for the external storage support system with one tank on each side. So that position error of about 40 feet at 80 knots and about 50 feet at 100 knots.
Okay, so you mentioned, so you do not actually plan to test the other Limas to see if there are any unanticipated discrepancies in barometric altimeters?
So based on the flight test records we have today, we don't see a need to test the Limas because the configurations are standard across the fleet.
Do you is there other airspace, anywhere in the national airspace where this may be similar? Have you checked?
Ma'am, we did do a search to look to see if there had been any safety incidents on the Black Hawk related to the pitot-static system. We did not find any.
Did you work with FAA to look at the glide slope for any landing aircraft to make sure at any runway at other airports across the nation where you might have this same issue?
No, ma'am.
Okay. So policy-wise, you said you're putting something in a flight manual?
So there's several courses of action that could happen based on the recommendation from our airworthiness organization. We could update the flight manual to include the air table, the air altitude correction table. we could put out an
Okay, I'm running
airworthiness
out of
release.
time. I want you to walk us through when that started, what each of the steps are to get to the end of that, to where you have a policy and a manual, or whatever the recommendations are in the airworthiness group. What are each of the steps, and when will that occur? How many steps? I mean, not just how many. Walk us through that process.
Sure.
Ma'am, so the moment it was identified, the first step was making sure that in fact that error did exist, and that was going through all of our models. That's complete. We've looked at a number of things to try to make sure that that error hasn't been changed over time, and we verified that. So that analysis is complete. Our aeromechanics group inside our airworthiness organization has completed that analysis. They should be providing the recommendation back over to the program office to provide our recommendation for what should be added to an operator's manual, or how the pilot should be made aware of that that altimeter correction for the ESSS configuration, and then that'll go into the PM office for decision.
Then there will be a system safety working group that'll determine if there needs to be a aviation safety action message for immediate notification, or if it will go into a 2028 process to update the technical publications, or if it'll go in an airworthiness release. So that would be the third and fourth final step.
How long will that take?
Once we get the memo back, so the recommendation, we can convene within a week, and then following the SysWig, we can determine, if it's an aviation safety action message, and that's coordinated through our aviation and missile command, and that can happen within days. And if it's updated into a manual, we'd first put it in the AWR. Again, that's within days to weeks. If it goes into the manual, the 2028 process is a little bit longer, but we would put it in the AWR first so it's notified, and then the manual change would come out following that.
Okay. I need, how long do you believe this entire process will be?
So from today, being, let's say, July, the end of July, so by the end of August, the SysWig should have met, and so early September, we should have the direction that'll come out of the System Safety Working Group, and then that'll determine the ASAM, the AWR, and/or the manual path.
Okay.
So September 15th ballpark.
And that's just the recommendation?
No, that's for the final action.
That is for the final action?
With the caveat that if it is determined to update the manual, that would take a longer process. The AWR would go out in lieu in the interim until the operator's manual is updated.
Thank you.
I got a couple questions on the flight data recorder. As part of our investigation up this point, radio keying was supposed to be recorded per the recorder documentation, but that data was not present. Do we know why?
So we witnessed that team. We sent a team down to a unit in Alabama and verified that data is not being downloaded. We're currently investigating that, and we don't know why that data is currently not being downloaded or not being input into the system. So it's an open issue that we're investigating.
Okay, and I assume our investigative team's tied in with that as when you guys know something?
Yes, sir. We would let them know
Okay.
when we find something out.
Yeah, for you, Mr. Rosengren, you indicated the accuracy of the flight data recorders are checked whenever there's a software upgrade. How often are there software upgrades?
So for the for this particular system, there was a substantial software update in 2011, and then there was minor updates in 2013, 2015, and 2017, and we're currently undergoing an effort to make another software upgrade right now.
Okay. And you did mention something about there was some thought behind doing a FOQA program with the flight data recorders, is that correct?
Yes, sir. We had an aviation data exploitation capability program back in the mid 2010s. That didn't come to fruition.
Okay. Do we know why it didn't?
I can't speak to the decision of the acquisition professionals, but I believe it just didn't make it past the certain checkpoints during acquisition programs.
Okay, thank you for that. That's all the questions I have for this panel. I want to thank the witnesses.
Member Inman.
Thank you, Chair. Mr. Rosenberg, I'm going to go back one more time. You're saying middle of September, you're going to inform or hope to inform Army aviators of what?
If there's a change for the altitude with external storage support system on the aircraft, if there's a recommended delta altitude discrepancy.
Yeah, see, I think, Chair, and I can just, let me clarify one thing too, and I want to point this out. The parties that have been involved with us from the Army have been very helpful and I think worked with us very well. I think that was discussed earlier, so we appreciate this. This is the first time we're actually interacting with you all as witnesses, which is, I think, is probably some of our frustration of what we're hearing in this testimony. And the reason I bring that up is, in a personal sense, I used to live at 400 Army-Navy Drive when this crash occurred. I looked out over the Pentagon, DCA. Chair and I stood on runway 33 the night that this accident happened. I moved to McLean specifically so I wouldn't have to face that and my wife wouldn't have to see me wake up in the middle of the night. Whenever I moved to McLean, though, I found out after being there the last 2 weeks, I'm on one of your flight paths over 495. Over the last weekend, 5 of those Limas flew behind my house. And you're telling me it's going to be 2 months before you tell them that there's a discrepancy in their altitude? Could you hurry it up?
Yes, sir. We would do, that's a worst case scenario. We'll do everything to exceed that time frame.
How about telling them now?
We are in public testimony, and so we have put it out there in public testimony.
I hope every Army aviator is not having to watch the NTSB.gov live stream to figure out that there's a discrepancy in their altitudes of the planes that are flying around us. Sorry for my frustration. For Sikorsky, how many of these Lima models are still in operation around the world?
Sorry, I don't have that number. I'd have to. I cannot answer the Army numbers, and we'd have to go back to determine our international operators.
Could you please?
Okay.
How many were manufactured with this variant, I guess, is a good question. How many are still operating with a certificate?
Yeah, we'll find out. We can get the answer to both.
Okay. Has Sikorsky received any reports of conflicting altitude readings elsewhere outside of the military?
No, the answer is no. I requested information from our database and went through it, and I did not see any reports as such.
How much does a Lima model, how much did you sell a Lima model for?
I'm sorry, I'm engineering. I don't know the cost data.
Okay, can someone from the Army say how much you paid for a Lima model?
I don't have that data either, but we'd be happy to provide that for you.
That and how much the Mike model cost?
Yes, sir.
We also noted that I believe it's in the chairman's or the group chairman's report, and I'm going to just cite it a little bit, if I can pull it up here. That this altimeter was actually returned for service and reconfigured. Are you aware of that? The right altimeter?
I was not aware of that, sir.
Okay, it's in the group chairman's report for helicopters. Have you read the group chairman's report for helicopters?
Yes, sir. I've read all the exhibits for this hearing.
Well, I'd refer you to page 39 and 40. So if you don't know that that was done, I think it would be helpful to read it.
Cool.
Both the PITX, the altimeter had been overhauled and recertified in 2018. Have you went back and looked at other recertifications and overhauls of altimeters to see if they're still within specs?
We have not, sir. And the device is a non-condition item, so it's only overhauled once it doesn't get pulled and overhauled in a regular interval. It only comes out when it no longer passes its checks.
So one final question before my time runs out. So the Army determines the mil spec for not only where the pitot tube is, now I apologize if I'm mispronouncing it, the pitot tube, where it goes, but it specifies specifically the altimeter that must be used with it. Is that correct?
the original requirement specified the altimeter to use and actually provide it as government furnished property, but it did not specify where the probes would go.
So was that Sikorsky's decision of where the probe would go?
That was before my time, but I would believe so, yes.
And you earlier said that that was technology, I guess, in the 70s at the time that it was decided, right? Before you had flow test and other type of testing?
That is correct.
Have you not reevaluated that test to determine if a design change should occur now that you have new methods?
No. Again, there's been no further requirements for any different.
No, I'm not asking about a requirement. Has Sikorsky, now that it has additional ways to test, maybe went back and looked at its aircraft and said, we know better things, we should suggest a change in where these pitot tubes go?
No.
Any reason why?
As I stated before, when you consider there's limited real estate on that aircraft where these could be put, and other operational considerations. So again, austere landing conditions, worrying about damage to their probes, debris impacting the pitot or static ports. The other devices on the aircraft which would limit separate static ports like what was shown in the presentation. So again, limited areas and no identified need for different performance.
We'll keep going. All right. While I am asking this question, can Mr. Fuchs, can you pull up, I think we sent it to you, 7 Hilo H Appendix A, Table A1. Before I ask that question, though, for the transponder, I just want to go back to the, well, actually, before I go to the transponder, you said, Mr. Rosengren, you had said possibly a safety alert in September or some sort of alert, correct?
Yes, ma'am. We could send out an aviation safety action message that would go out to the fleet.
Okay. And then when is the first chance for it to go in the manual?
So the manual goes through a 2028 process, so that would begin in lieu of going into the manual, we would put it immediately in the airworthiness release that would go fleet-wide.
Okay, but manual, that update begins in 2028.
So, I'm sorry, 2028 is the form that is submitted to make an operator's manual change, not the calendar year 2028.
Okay. But 2028?
No, ma'am.
Okay, please be very clear.
Yes, ma'am.
Alert, manual.
So manual, there's a process that uses a form 2028. And that form 2028, if it's determined it needs to go into the operator's manual, we would submit that by the September 15th timeline. When it goes into the process of upgrading the operator's manual, that I can't speak to the specifics. I can get you the specific timelines of how when an operator's manual would be updated.
Thank you very much.
I apologize for the confusion.
No, that's okay. Transponder, let's say you're at 260 or 270 feet. What would DCA tower see?
So, ma'am, at 260 feet, the tower should see 300.
Great.
But they get pressure altitude as opposed to what the pilot sees.
And 230 or 240?
It should be 200.
Okay.
But there's a plus or minus 40 around the midpoint.
Right.
Yes, ma'am.
Okay, thank you. Appendix A, Brian, if you can pull that up real quick. So we have a compilation of essentially error allowances. 2 in the static system, 1, 2, 3 barometric altimeter, altimeter encoder. Well, actually 1, 2, 3, 4, 5, 6, 7 different standards for the barometric altimeter. We've got the ESSS. We've got a clean configuration of the Lima. Are any of these additive?
Yes, ma'am. Some are additive, and some are not, the way the table's laid out. So, for example, the encoder is not part of what the pilot sees, so that's not additive. But there are, so there, the instrument errors. The errors inside the instrument tend to be random, and they can combine. But so, for example, if you had a 30-foot scale error and a 25-foot barometric setting scale error, you would combine those through a method called the root sum of squares, and you would get roughly, that's a 39-foot expected error range for those. So some of them are additive. Yes, ma'am.
Thank you. For what the pilot is seeing, are any of these additive?
Yes, ma'am. So the instrument errors, and those are the ones you're verifying on the ground when you do the pre-flight check or when you do the pedostatic check. Then you have to, when you take off in flight at a particular flight condition, you have a position error, a static position error, and those are additive. They can be different, so one can be positive and one can be negative, and they can cancel each other out, or they can add to each other, but they are additive.
Okay, and does it depend, could it be different by helicopter, or is that fleet-wide?
Yeah, ma'am. So the instrument error would be different by altimeter. So the
By
right side and the
altimeter.
left side altimeter could have different instrument errors. It's just a random, it's a mechanical error inside the device. But the position error, so for example, the position error at a particular airspeed for a particular flight condition is the same for all the helicopters.
Okay, thank you very much. I will ask Member Graham next. Member Inman.
Mr. Rosenberg, is your department or your agency, are you responsible for all updates in regard to even maintenance, or is it just flight standards?
So my organization is the Utility Helicopter Project Office, and so we're responsible for acquiring new Black Hawk helicopters, and then we coordinate with our life cycle management program, the AMCOM, Aviation Missile Command, on the sustainment of the aircraft. And so we do not have maintenance standards that we own. We're an acquisition organization, not an operational organization.
So you buy stuff, you don't use it?
So we buy stuff, and then we work with our sister commands to make sure that it's used in accordance with the acquirer's maintenance procedures.
Okay, so you're in charge of acquisitions, is that right?
Yeah, so we're part of the Assistant Secretary of the Army for the Acquisition, Logistics, and Technology. And so we are the acquisition arm of the Army.
So just help me understand this then. Why does the acquisitions department issue airworthiness directives?
So the acquisition, we do not. We get them from our independent airworthiness organization. So AMCOM.
You keep pointing to the gentleman to the
I'm sorry.
right.
So Mr. Bradham is my chief airworthiness engineer. So
But he reports to you, right?
He does not, no, sir. He's
No, sir. Just for clarification, sir, I'm the chief airworthiness engineer, and I work in Futures Command in the Combat Capabilities Development Command Aviation and Missile Center in a group called the Systems Readiness Directorate. So Army Airworthiness Authority is delegated from the commander of Aviation and Missile Command to the director of the Systems Readiness Directorate. So I report through Futures Command, not through the program.
My apologies. I thought earlier in the testimony you said my bosses and you pointed to the left.
Oh,
So often the acquisition, we will task them to give us independent recommendations. That's probably why the gesture might have been that way. So when I tasked Mr. Brown's organization to give me a recommendation, that was probably, if I recall, maybe.
Have you tasked his organization to give you any other recommendations regarding this accident?
Many, yes, sir.
What were they?
I'd have to go through the records. I'd be happy to provide you all the taskings we've done. I believe we've shared.
Are there a lot of tasks, a few tasks, 2 tasks?
There's many tasks. When Mr. Parker would make a recommendation, we would funnel it through our program executive officer, General Phillips, and then we'd make sure we get all the requests from this acts investigation, give it highest priority, and make sure that we get it tasked and recorded per saving the records for this investigation.
Okay. Will you be on another panel, Mr. Rosenberg?
No, sir, but I'll be here all week.
We can recall.
You think? Okay. I'm going to be done for.
Well, okay. I have a few just that I want to make sure I get back to. for Sikorsky, what's the prime item developments? What is a prime item development specification?
That is the document which with the government conveyed its requirements to us.
Okay, and when you're doing testing and you certify your, it goes through design and certification, correct? Your helicopters?
It's designed, and then we provide the reports. Ultimately, the
Okay.
Army has airworthiness ownership.
And so the documents you provided, does it include all these allowable allowances for errors?
The report that we've cited to the investigative team identifies the error curves for altitude, yes.
The report, and that was provided to the Army?
To the best of my knowledge, yes.
Okay, so my question is, was FAA aware of any of this? Or the testing that was done, was that a surprise to the FAA of what was done and what the outcome was?
I do not know.
Oh, I'm not asking
Oh,
you.
sorry.
I'm actually asking the FAA.
Which
You should not answer that question.
which testing are you referring to?
The tests that were done on May 15th on the formation flight.
And
I'm sorry, let me clear. The report I was talking about was from
Yeah,
1983.
I know.
Okay.
I'm not, this is a totally different question. I'm getting a few of my straggler questions here.
Yeah, so I'm familiar with those reports that came out of the May 15th battalion flight tests. I did not have access to any of the, I'll say, the original Sikorsky data to form any opinion on the results.
Okay, thank you. Member Graham. Member Inman.
Yeah, I'd just like to go back to Mrs. Lewis. I think all the board members were offered, and I believe we all took the opportunity to do a simulation in the Lima or the Mike model and to wear night vision goggles. And it was very apparent as we were doing that, the instructor pilots next to us were talking us through what they would see. So we've actually seen the entire route, which is pretty disturbing whenever you look at it that way. My question to you is, if they were talking to us and we're looking through night vision goggles, you have to look out of the night vision goggles, if I'm correct, to be able to check your altitude?
Yes, that would be correct.
And earlier you said that you'd be checking your radar altimeter and your baro altimeter if you're at an MSL of 200?
Yes.
Is it a complicated task to be looking at two separate altimeter readings while at the same time using night vision goggles that prohibit your view by 40 degrees? And an iPad, sorry, that has ForeFlight along with the ADSB receiver that's remote?
Sir, in that situation at that low altitude, I would not be referencing an iPad. I would have that put away, but I mean, it does take some practice, some experience to get used to cross-checking the instruments while flying goggles at a low altitude.
How much practice and experience would you need?
I think it would vary by the individual.
So let me just clarify that again. And the chair brought up a good point regarding the iPad, which has the ForeFlight, which is where their charts are supposed to be, correct?
That's correct.
So let me go back to, you have a night vision goggles on with a 40-degree field. We now need to check the radar altimeter, the baro altimeter, but we don't need to be looking at the iPad?
As I had stated before, I haven't flown this particular route, but at that low of an altitude, in my experience, I would want to know the route that I was on, that close to the ground, and not have to be looking inside the aircraft in an iPad.
So with the instruction as a standardization pilot, would the instruction be to not have aviators look at their iPad, which has the charts on it?
In my experience, at that altitude, I would not want someone inside the aircraft looking at an iPad.
Well, can we hold until panel 3 on
Yeah,
that
that's
one?
fine.
And then if you'd like, we could recall the witness for that panel.
And I realize you may not have flown this route, I apologize. Have you had a chance to read all of the docket material that we've released, Mrs. Lewis?
I've reviewed all of the document material for the air data systems and altimeters.
Did you find anything disturbing in what you read?
In my opinion, the amount of clearance between the helicopter route and potentially the altitude of an aircraft passing over top of it was concerning.
I hope so. Okay. Thank you, Chair.
Thank you so much. Now, I'm going to go back to the technical panel to see if they have other questions. And then my understanding is, because I'm getting texts from the team, that there are some party questions. So I want to make sure we are within schedule, so I want to make sure everybody's questions are answered. So we'll go back to technical team, then we'll come back to the parties.
This question's for Mr. Rosengren. Previously with the flight data recorder, you had mentioned that when the data is downloaded, it's looked for reasonableness. Is there a standard for reasonableness with the FDR data?
So just for clarification, we don't download the FDR data. We download the HUMS data, which is in the data card, but they come from the same remote data concentrator, so we're confident that they're similar, minus a few recording rate differences in hertz. So we download the HUMS data. I'm not aware of any standards. I can get back to you if I find anything different. One thing does come to mind. So the 3 parts that I did mention, there are some vibration standards we looked for to make sure that those 3 parts aren't exceeded. But outside of those three parts that we track, I don't know of any particular standards we use.
Okay, we'd appreciate it if you could get us that information, and particularly if the pressure altitude data is looked for, and if there's a standard for what's considered reasonable for that parameter. Jumping a bit, my next question is for Mrs. Lewis. This is a scenario-based one, based on what the chairwoman asked about flying over the Potomac River route. If you had a route ceiling of about 200 feet, and you were to look at your barometric altimeter and see about 160 feet, but then saw on your radar altimeter about 280 feet, how would you triage that situation in your experience?
In my experience, so if the barometric altimeter is reading 160 feet, you're saying, and the radar altimeter is reading significantly higher than that, I would still, my primary concern on the MSL route would be staying below the 200 feet. And I would definitely, take note of that and maybe write the aircraft up for some, maintenance action. But at that particular time, I would, as long as there was nothing wrong with the aircraft before we took off as far as the field elevation and the barometric altimeter, I would, continue to assume that I was below that 200-foot MSL.
Thank you. And then my last follow-up question is, I think Mr. Bradham would be best suited, but Mr. Rosengren can chime in as well. Based on the discussions today for the answers that we've received today in panel 1, there have been limitations identified with the accuracy of barometric altimeters just as a technology. They're mechanical instruments compared to newer air data computers and more modern technology. So knowing that based on our testing and just based on experience that these older technologies have these limitations that can create larger altitude offsets between indicated altitude to where the helicopter is actually at, what sort of considerations would the Army have for when flying in the national airspace system where pressure altitude accuracy is crucial?
So I think there's a question about the size of expected altimeter error versus aircraft separation when you're talking about a route like this in the national airspace, and I think that's not. I'm certainly not an expert to talk on the route design and the amount of allowable separation, but clearly, when you take into account you know, there's standards for pilots to maintain altitude. There's standards, you know, for the altimeter error. And as you know, thinking about this, I don't think that we envision a situation where, well, prior to this incident, myself personally, in my experience, I wouldn't have envisioned a situation where you'd be operating on barometric altimeter, you know, with less than a 500-foot separation. But I think if you're asking if we're kind of relooking how we operate in the national airspace, I don't, with the exception perhaps of the correction for the ESSS configuration, I don't believe there's any deviance from from what's accepted on the civil side as well. I mean, the military requirements, the 70-foot check is more stringent than the 75-foot check. The mil-spec 25 feet of position error is more stringent than the civil 30 feet of position error. So with that one exception, I think we're still operating inside the requirements.
And would there be any considerations to selecting certain models that have newer technologies or more accurate instrumentation versus older models in flying certain missions based on, again, known limitations with route ceilings or proximity to civil aircraft in the national airspace?
Yeah, I think that's an operational question, and I don't know that I could speak to that.
Is there someone here that can, as a witness?
I think it'd probably be best to wait for more operational, experienced witnesses to give more expert testimony.
Thank you.
Yes, just one follow-up question. Mr. Rosengren or Mr. Bradham, given your knowledge of the various electronic devices on the UH-60L model, are there systems that are currently installed that record the helicopter's position and either radar or geometric altitude over time that could be used for operational data monitoring for safety assurance purposes?
So we do include the radar altitude in our parameter data and the flight data recorder and the HUMS data, so that can be used. We don't record the GPS data.
Okay, and does that, where do those data go?
So that data goes to the same places, the flight data recorder and the health and usage monitoring system. I'll call it a card, PCMCA card. So those are downloaded to that integrated vehicle health monitoring system.
Okay, but who receives those data?
So those are downloaded after mission day, as I mentioned before, by the operational units, and then they're uploaded to the cloud so that we can access it as an Army enterprise.
Okay, so at a higher level, the Army monitors those data?
The Army has access to it at a higher level, yes, as well as operationally.
Could those data be used to determine if battalion helicopters are exceeding the maximum altitudes on the DC helicopter routes?
Yeah, so the information that's recorded, so you have radar altimeter that's recorded, but you don't have terrain being recorded, which you would need. The recorded pressure altitude out of the system, it's very difficult to map the recorded pressure altitude to the pilot's barometric, what the pilot's actually physically seeing. So the recording in the HUMS system is not recording from the pilot's altimeter the way the transponder is. You're recording from a transducer that's on the same static line, but not connected to that instrument. So although they have some of the same errors, the instrument error that's in the pilot's instrument and the error that's in the transducer recorder path, those are different sets of errors.
Yeah,
and so in some cases, when those errors are close to each other, you get good agreement. And in some cases, when those errors are not close to each other, you get significant disagreement. But unless you have a reference measurement, you can't parse that out.
Yeah, I'm not asking about comparing the two types. What I'm asking is, does it contain, it sounds like it does record radar altitude. Does it record position?
It doesn't record latitude and longitude. Is that what you mean by position? No, but it does record the parameters needed to reconstruct the flight. However, you do need a known data point. As our NTSB friends did here, they knew the data point that we took off from on on the flight, and so they were able to reconstruct the May 15th flight from that known data point. But it doesn't
Okay.
include absolute time or absolute position.
So it would require considerable analysis.
It would require considerable analysis and considerable note-taking on at least a known reference point.
All right, thank you.
Yes, sir.
No more from the technical panel, Chairwoman Hamady.
Thank you. We're going to go in the same order. Alpa.
Thank you, Chairman. The first question we have is for Mr. Cooper. If barometric tolerances were tightened, would Sikorsky be able to support modification to these systems used in rotorcraft, even if it required retrofits or redesigns to the pitot-static systems?
For which model?
For any. But specifically in this case, it could be, you know, the Lima or the Micro going forward, whatever it might be.
Tighten to what limits?
If they were just tightened, say, we'll give you a number, say, plus minus 50 feet or something for field elevation barometric altimeter checks.
For the Lima, some, again, because it's a compilation of errors, as has been stated, it would require changing out of the government furnished provided indicator. So with that indicator, there's some limitations as to where you can tighten tolerances. For the others, it is plausible that we could analyze requirements and determine alterations to the probes. So plausible, but again, we would need the exact requirements. It's kind of hard to provide an answer, you know, for just a broad.
Of course. But so you're saying it would be possible, but it would have to be analyzed.
Yes, and the configuration, like I said, the external storage support system configuration has a larger error, and you know, need to understand how that applies also.
Thank you. Next question for Chief Warrant Officer Lewis. In your opinion, should any considerations be given to using different helicopter model types and low altitude routes located in congested areas?
As I stated before, I've flown the different variations that the Army has of the Black Hawk. I have not flown in the DC route structure. I have flown both the Mike and the Lima in low altitude, and based on my experience and not having flown here, I don't want to make a recommendation. I feel that's outside of my experience of which one's best suited to fly here.
Okay, understood. Thank you. That's all from Alpha.
Thank you, FAA.
I don't have any questions, ma'am.
Okay, thank you very much, NACA.
Chairwoman, we have no further questions. Our questions have been answered, and I'd like to thank the panelists today. Thank you.
Thank you. PSA.
Thank you. A couple operational questions real quick here. In your experience, Ms. Lewis, flying along, your co-pilot or instructor pilot voices a different altitude than you have of 100 feet. Is that any area of concern for you?
I would, if an instructor pilot, are you asking if they told me to adjust my altitude by 100 feet, would I do so?
If you call 300 feet and he calls you, I got you at 400 feet, would that be an area of concern for you?
100 foot of difference would not be a large area of concern. The first thing I would do would be to make sure we both had the same altimeter setting, and then address the situation going forward from there.
How much would it take to be a concern?
A couple 100 feet would be a concern in flight.
Okay. And I guess going back to the low levels, if you're on a 200-foot MSL route, would 100 feet be a concern then?
100 feet in what regard? 100-foot difference between the pilot and the co-pilot's altimeters?
Yes.
100 feet would still be, we would still have that 100-foot window, plus or minus 100 feet to maintain altitude.
Okay. Sorry, my next question. An example you were given by the tech panel You said if the bare altimeter was 160, radar altimeter displayed significantly higher, over 200 feet, you would continue to rely on the bare altimeter to conclude you were below 200 feet. Can you explain why you would fall back or use the bare altimeter as primary?
In my experience, if the barometric altimeter checks out good on the ground before I take off, and as we stated before, pilots generally, they're not out flying doing math between the barometric altimeter and radar altimeter, adding up altitude differences and considering that during flight. So as long as it was good on the ground before I took off, I would continue to assume that my barometric altimeter was accurate.
Okay. I have no further questions. Thank you.
Thank you. Sikorsky.
One quick follow-up question. Mr. Cooper, just to clarify, you said that the pitot probe location on the Blackhawk was determined primarily by Army operational and performance requirements for the Blackhawk. Is that correct?
No, I said that those feed into the consideration of its location, right? The available real estate on the aircraft, the required operational envelope of the aircraft, and what other equipment and considerations would normally feed into that selection. I honestly have to say in the late 1970s, I don't know why they picked the exact location, other than various other military products of that time, including those delivered to the Army from Sikorsky, had their probes in an above cabin location.
So I think you're also saying that other military aircraft at that time had probes in that location as well.
Correct. The CH-53, the H-3, and the S-54 crane, X-64 crane had those upper locations also.
Great. Okay. Thanks, Mr. Cooper.
U.S. Army.
Just one follow-up question, Madam Chairman. For Mr. Gant, we've talked a lot about altimeter errors and the deviations that are within the acceptable ranges. Are these unique to the UH-60 Lima, or is this consistent in commercial and general aviation across the national airspace?
It's across all fleet types. The physics doesn't change, although between the FAA and the military, just by way of background, for transport category airplanes, the position air requirement is the same, plus or minus 30 feet per thousand, or per 100 knots, excuse me. And that's been in place since 1958.
No further questions.
Thank you. Can you pull up that chart again, Brian? Okay, so I will ask this question of Mr. Cooper. The model of helicopter that was involved in the collision, understanding that there are different requirements when you're ordering, is this model generally sold to other branches of the military?
There's UH-60 derivatives to the other branches of the military, yes.
How about outside the military?
There are international customers.
They're international. Okay, thank you very much. And is there a difference on where the pitot probes are for the mic?
No, there's not.
Okay, thank you. Can I ask I don't know if it's for Mr. Bradham or for Mr. Rosengren, I just wanted to go back to what you're working on for the flight manual and the safety alert. Did I hear you right that you are focused on the Lima with the ESSS and the outboard fuel tanks?
So, ma'am, it applies to the mic as well. So it applies to the...
with the outboard fuel tanks?
Yes, ma'am. With the ESSS wings and one tank on each side is the configuration that has been tested historically, and that's where we have good data on that particular configuration.
And that's what you're focused on for the policy change?
Yes, ma'am. For the
or for the alert? Yeah.
Yes,
and
ma'am.
any sort of change to the flight manual?
Yes, ma'am.
The reason why I'm asking is if I'm looking back at the formation flight, for the 12th Battalion, I mentioned the numbers, the difference between the barometric altimeter was 1,070 feet and the radio altimeter was 1,200 feet, off by 130 feet. That was for the ESSS. The lead helicopter and the third, I believe, were the clean ones, correct?
Yes, ma'am. Correct.
Okay. So they don't have the outboard fuel tanks.
Correct.
My question is, the barometric altimeter on the lead helicopter showed 1,090 feet, radio altimeter 1,180 feet with a difference of 90 feet. On the third helicopter, it was 1,100 feet and 1,180 feet with 80 feet of difference. Does that concern you at all?
So, ma'am, so first you can explain those discrepancies, and if I could just talk through it just very,
Sure.
very quickly. So that delta that you see in those aircraft, if you take their, how far those aircraft were from field elevation on the ground, and you assume that's a good approximation of its instrument error, and then you add the position error to that, and then you add the temperature effect, because on that day, they were flying they were flying a warmer than standard temperature, which has, when you're trying to compare radar and barometric altitude, you have to correct for the temperature. So there's 36 feet of that roughly is a temperature effect. But so for those aircraft, if you take those standards, and I apologize, I'm flipping through my notes to get the exact numbers on the aircraft, but I have them for all the aircraft on that test. So for example, ma'am, so for aircraft number 1, it was 45 feet low on the ground. The position error adds 7 feet low, and then the temperature adds 36 feet low, which is 88 feet, which is close. So what you have is a case where you have 3 different effects all in the same direction.
Correct.
And then for aircraft, for the second aircraft, the one that was ESSS.
Those are the ones I went through before. A lot of those I went through before.
Yes, ma'am.
And then there are differences, obviously, from this chart in the allowable errors in the instruments, or in different components, correct?
I'm sorry, ma'am, say that again?
The chart. Some of those stack up, too.
Yes, ma'am. So some of those do. So the static system, the first 2 you see there are position error.
Yep.
One is military, one is civil. And then in the barometric, so for example, the scale error is the aneroid capsule error.
Okay, I don't need to go through all these.
Yes, ma'am.
We've already gone through all of these. The question I'm asking is you have a difference of 80, difference of 90. I understand there's temperature fluctuations. I understand there's allowable instrument error. What I'm getting at is, would you be concerned if this midair collision didn't happen and you knew, you had 75 feet of separation between the glide slope and the east bank of the Potomac?
Yes, ma'am. I'd say prior to this incident, that would not, I don't believe, have concerned me significantly. Understanding the vertical separation that existed in this case, yes, that would concern me.
Can I ask one more question? Was there at any, does anyone, and I'm going to ask everyone to answer this question, were there any efforts by the Department of Defense or Army to get helicopter Route 4 back in place after the Secretary did the work, thank you, of taking it off the map?
I'm sorry, ma'am. I don't know. That's not a
Does anyone else
area of my
know?
expertise.
I don't know either, ma'am.
I don't know, ma'am.
FAA, Sikorsky. Okay, thank you. Member Graham? Member Edmund. Does the technical panel have anything? We've got time.
No, ma'am, we're good.
Okay, then we're going to go ahead and break for lunch. We will be back at 2:15. And just a reminder for the staff, lunch is served upstairs for all you all involved with this hearing. Thank you so much. We were going to start at 2:15, but there's a really long line to get into security, so we're going to give it a little bit more time so people can get through. All right, we're going to go ahead and get started. And as we go into panel 2, Mr. Banning is going to provide a summary of the accident just to get us back in, since we've been out for an hour, back into as we go into panel 2. Mr. Banning.
As you saw in the animation, about 2 minutes before the collision, DCA Tower contacted PAT 25 to inform the crew of Flight 5342's location. At this time, the aircraft were about 7.5 miles apart. Flight 5342 was just south of the Wilson Bridge, and PAT 25 was over the tidal basin. PAT 25 stated that they had traffic in sight and requested visual separation, which the tower approved. 15 seconds before the collision, DCA Tower contacted PAT 25 a second time and asked if they had the CRJ in sight. At this time, the aircraft were about 1.25 miles apart. Based on information obtained from the CVR, the crew of PAT 25 did not hear the controller's instructions to pass behind the CRJ. PAT 25 again stated that they had the aircraft in sight and requested visual separation. The controller approved. The collision occurred about 8:47 and 59 seconds p.m. Eastern Standard Time. At the time of the accident, one controller at DCA Tower was managing both airplane and helicopter traffic. During the final 2 minutes of the accident flight, the controller spoke to 6 different aircraft, including PAT 25. As mentioned in the animation, all aircraft could hear the controller, but helicopters could only hear other helicopters on their frequency, and airplanes only other airplanes. Air traffic control procedures will be discussed as part of Panel 3. At the time of the collision, PAT 25 was in a near level attitude at an altitude of 278 feet and a ground speed of 90 knots. Flight 5342 was lined up with runway 33 and descending at a ground speed of 110 knots. At the time of the collision, the airplane was in a slight left roll and the elevators were deflected to near their maximum nose-up travel. The helicopter's air data systems and altimeters were discussed in Panel 1. DCA Class B airspace contains a high volume of helicopter activity that includes local and state law enforcement, all branches of the military, Homeland Security, the Federal Bureau of Investigation, the National Park Service, and medical transport. The volume and complexity of mixed operations required letters of agreement that outline specific procedures. Helicopter Route 4's ceiling was 200 feet. However, helicopter operators were encouraged to fly above 100 feet for noise reduction. Route 4 ran along the eastern shore of the Potomac River, but did not have defined horizontal edges. The runway 33 approach path was located over the Potomac River for a distance of about 4,100 feet. Runway 33 has a 4-light precision approach path indicator, or PAPI, that provides a 3-degree glide slope to the runway. At an altitude of 200 feet over the river's eastern shore, a helicopter would have about a 75 foot of vertical separation from an airplane on approach to runway 33. Panel 2 will discuss the airspace surrounding DCA and the helicopter routes. Flight 5342 was equipped with Traffic Alert and Collision Avoidance System, or TCAS. The flight crew of PAT 25 was equipped with iPads with the ForeFlight application installed, which had the capability of displaying aircraft that were radiating Automatic Dependent Surveillance Broadcast, or ADSB, out. ADSB is a method of aircraft surveillance that can be used by air traffic control and other ADSB-in equipped aircraft. PAT 25 was not transmitting ADSB data at the time of the collision. However, both aircraft were equipped with transponders and tracked by radar. Collision avoidance technologies will be discussed in panel 4. Multiple data sources were used to create the following images that depict the aircraft flight tracks from various views. None of the images depict the nighttime conditions that existed at the time of the accident. This image depicts a flight track of both aircraft. The yellow line is the helicopter track, and the green is the airplane track. The yellow circle is the location of the collision. This view looks south along the helicopter's flight track. This image is looking northwest along the airplane's flight path as it approached runway 33. The yellow line is the helicopter's track, and the green is the airplane's track. The yellow circle is the location of the collision. This image looks southeast from the DCA air traffic control tower. The control tower is located in the bottom middle of the image, highlighted by the red circle. As a result of the accident, the NTSB issued 2 urgent safety recommendations to the FAA to prohibit helicopter operations on Route 4 when runways 15 and 33 were in use, and to designate an alternative to helicopter Route 4. Immediately following the accident, the FAA implemented temporary airspace restrictions around DCA. Shortly thereafter, the FAA removed the section of helicopter Route 4 between Haynes Point and the Woodrow Wilson Bridge. Additionally, the FAA prohibited the use of runways 1533 and 422 at DCA during specific helicopter operations in the vicinity of DCA. The United States Army directed the accomplishment of operational checks of aircraft transponders to include ADSB out functionality. Panel 5 will discuss safety management systems, including midair collision risk in the National Airspace System. NTSB was notified of the accident on the night it occurred, and a GO team launched the next morning. The staff listed on this slide assisted in the initial response and/or are supporting the ongoing investigation. Member Inman acted as the agency spokesperson on scene. Parties to the investigation are Aerosonic, the Airline Pilots Association, the Association of Flight Attendants, BAE Systems, Collins Aerospace, the Federal Aviation Administration, GE Aerospace, International Association of Machinists and Airspace Workers, Metropolitan Washington Airports Authority, National Air Traffic Controllers Association, PSA Airlines, Sikorsky, and the United States Army. In accordance with the provisions of Annex 13 to the Convention on International Civil Aviation, the Transportation Safety Board of Canada participated in the investigation as the representative of the state of design and manufacture of the airplane. The accredited representative was assisted by technical advisors from Mitsubishi Heavy Industries and Transport Canada. Chairwoman Hamady, this concludes my presentation.
Thank you, Mr. Banning. And now we'll go to Dr. Bauer to please provide an overview of the panel topics and introduce the technical panel and witnesses.
Thank you, Chairwoman Hamady. The second panel will provide an overview of the DCA Class B airspace and helicopter routes. The panel will address understanding the airspace surrounding DCA Airport, both the ATC perspective and the operator perspective. FAA standards governing design of Class B airspace separation standards. History of the helicopter routes to include the requests, development, and approval process of the Baltimore-Washington helicopter routes with special focus on Route 4. Description of the Army's mission and tasking in the National Capital Region and their use of helicopter routes. Complexities of fleet mix and history of safety issues involving helicopters, both the ATC perspective and the operator perspective. History and activities of the DCA Helicopter Working Group and ADSB out. The NTSB technical panel, starting on my right, is composed of Mr. Brian Soper, lead aviation accident investigator for air traffic control. Ms. Sarah Lewis, aviation accident investigator for air traffic control. Dr. Catherine Wilson, senior human performance investigator. And Captain Van McKinney, aerospace engineer, helicopters. Witnesses for this panel are composed of the following individuals. From my left, nearest the board members. In the front row, Mr. Nick Fuller, Acting Deputy Chief Operating Officer, ATO, with the Federal Aviation Administration. Ms. Katie Murphy, the Manager of Visual Charting with the Federal Aviation Administration. Mr. John Stowe, the Acting Director for Policy and the Mission Support Services of the ATO with the Federal Aviation Administration. Colonel Andy DeForest, Commander of the Army Aviation Brigade with the U.S. Army. Mr. Clark Allen, Operations Manager of the DCA Airport Traffic Control Tower at the time of the accident with the Federal Aviation Administration. And Dr. Steve Kasner, an aviation human factors researcher and author and retired NASA Ames employee. In the second row, we have Mr. Rick Dressler. He's an aviation site manager with MedStar Transport of Metro Aviation Incorporated. Lieutenant Colonel Paul Flanagan, the product manager of Assured Airspace Access Systems with the U.S. Army. And Command Chief Warrant Officer David Van Vechten, who is a former standardization instructor pilot with the Army Aviation Brigade of the U.S. Army. Chairwoman Hamady, these witnesses have been pre-qualified and their respective experience and qualifications appear in the docket as exhibits. Thank you.
Thank you, Dr. Bauer. I'll now ask the witnesses to please stand. Please raise your right hand and answer by saying, I do. Do you swear or affirm that the testimony you'll give in this hearing will be the truth? Thank you. You may be seated. As a reminder to the witnesses, you will remain under oath until the conclusion of the hearing. We ask that you answer the questions factually and avoid any type of analysis or speculation. Finally, please push the microphone button to talk and push it again when you're finished. I'm now going to turn questioning over to Mr. Soper.
Thank you, Chairwoman. Mr. Allen, could you please provide us with an overview of the DCA Class B airspace, and please include some of the most prominent complexities, challenges, and constraints from an air traffic control perspective?
Good afternoon. The DCA Class Bravo airspace extends out approximately 7 miles. It adjoins to Dulles Airport's airspace as well as Andrews Airspace. We receive helicopter traffic from Andrews, Baltimore, Dulles, Davison Army Airfield, and the local law enforcement and medevac hospitals. Some of the challenges associated with the airspace is the lack of airspace that we have, so to speak. There are multiple prohibited areas that we are unable to fly in. We have very specific procedures for fixed-wing aircraft and helicopters.
Thank you. And for Mr. Dressler and Mr. Van Vechten, I'd like you to respond to the latter part of that question as well, which was if you could share with us your most prominent complexities, challenges, or constraints for Mr. Dressler first from a non-military operator's perspective in the DCA airspace.
Thank you. For my perspective as a medevac operator, we're actually very privileged because in terms of priority, when we use the term medevac, we move everyone out of our way, including Marine HMX. For some of our other members, however, for the ad hoc DC helicopter operators group, that is not the case. So from a law enforcement perspective, we have several operators, whether that's U.S. Park Police, Maryland State Police, Fairfax County Police, Prince George's County Police Aviation, and all of them operate in an unscripted way, in a sense, because they don't fly from point A to point B necessarily. So their challenges are even greater than mine because I have an intended destination for every time my ships or one of my fellow medevac operators goes in. Our complexity is really, as Mr. Allen said, the airspace is very small, has very little room to maneuver, and we have prohibited areas that we have to avoid as well. Add in the final challenge is just the high volume of helicopter traffic in a very confined space.
Thank you. And Mr. Van Vechten, same question for you from the military or Army operator's perspective operating in the DC airspace.
Yes, we have the same challenges as Mr. Dresser addressed. The prohibited areas, and we're on specific routes that we are cleared through by ATC, or if we're in a zone, we're in a specific zone. So we must stick to these routes and zones as directed and cleared by ATC. There is a large volume of rotary wing traffic at low level, which is always a concern, and then the volume of fixed wing traffic in and out of Reagan Airport.
Thank you. Mr. Allen, back to you. When the helicopter control and local control positions are combined at DCA Airport Traffic Control Tower, do helicopters and fixed-wing aircraft share the same frequency, or do they remain on separate frequencies like when they are decombined?
They remain on separate frequencies.
And is that policy, or is that is there a reason for that that you're?
They're charted the helicopter frequency specifically, so the helicopter users are going to naturally contact the facility on that frequency.
Okay, so from an air traffic controller's perspective, are there advantages or disadvantages to having the helicopters and the fixed-wing aircraft on separate frequencies when it's combined?
Combined, it'd be subjective to each individual, but in my opinion, a positive would be it can help you prioritize your sequence of events or what you need to accomplish a little bit easier, having them separated.
Okay, any disadvantages from an air traffic perspective?
Disadvantages, aircraft may step on each other utilizing two separate frequencies. You may miss an initial call or something of that nature.
Okay, thank you. And for Mr. Van Vechten and Mr. Dressler, once again, how about for yourself? For the Army operator's perspective, is there advantages or disadvantages to being on a separate frequency from the fixed wing operators while you're operating there?
Yes, sir, both. First, the advantages. I don't have to continuously hear all the fixed-wing traffic, which would tie up communication between the pilots in the cockpit. The disadvantage was it leads to somewhat of a lack of situational awareness because I'm only hearing half of the conversation. So, for example, when I hear tower transmit and they say Brickyard 1234, clear to land runway 19, I have to anticipate and wait for that fixed-wing traffic to say, Roger, clear to land runway 19, or else I could end up stepping on him. So as you initially enter the airspace, you have to pause for a few seconds to see if there's anybody talking that you may not hear on a separate frequency.
Thank you. And Mr. Dressler, for you.
So we are split among our community. All of the civilian aircraft carry two sets of VHF radios. And in that case, you could be listening to two frequencies at the same time. So many of our members dial up the regular tower frequency on one and monitor it, and on the other, we'll be up on the helicopter frequency. That depends on the pilot choice. The disadvantage to that is we also have a helicopter air-to-air frequency that we can communicate and deconflict amongst ourselves. And if you take that one out of play, you have no way to talk to anyone else. I prefer the simulcast same frequency model because I do like to hear all of the commercial traffic at the same time, so I can formulate my plan around that as well. I think the disadvantage is clear. It's a very, very, very busy airspace, and for all of us to be waiting in order to make a radio call without stepping on someone else is the massive disadvantage that I don't think there's a solution other than a split terminal.
Excellent. So I'm glad both of you mentioned stepping on, and just for context, when we say stepping on, that's I'm assuming, and you can correct me if I'm wrong, but when two people are transmitting at the same time simultaneously, and one essentially steps on the other, and one person or both people's transmission might be partially or wholly blocked out, correct?
That's exactly correct.
Okay. So along those lines, is there any way, and this one is for Clark, I'm sorry, Clark, is there any way for an air traffic controller to know if they were simultaneously broadcasting or had stepped on, or somebody had stepped on a frequency where an aircraft might not be receiving their full transmission? Are you aware of anything? Is there a side tone? Is there something that occurs that lets a controller know that, or is it just potentially lost transmission?
If the controller was given an instruction that would have required a readback and they did not receive the readback, they could assume that it was stepped on or the aircraft didn't hear it. But if it did not require readback, no, there would be no way for them to know.
Okay. And in your experience at DCA, is there a notable difference in the quality of radio transmissions from military versus non-military helicopter operators?
Yes.
Okay, and could you kind of elaborate on that for us? Give us an example.
Yes, among the medevac and law enforcement community, they operate newer aircraft with newer equipment. Like Rick had said earlier, they have dual radios where other operators are using other aircraft that are perhaps more dated and maybe only have a single radio versus dual radios that can impact communication.
Okay, so from along this same vein here, are there any particular operators that operate regularly within the DCA Class B airspace, or even type of helicopters that stand out to you as exceptionally challenging when it comes to communication quality?
We've had trouble in the past with the Air Force and Army.
Okay. And does the helicopter control position at DCA have a UHF frequency available for use if requested by military pilots?
Yes, there is one.
Okay. Have you ever known or have you ever experienced a military pilot to request a UHF frequency since you've been there? Or?
It's maybe occurred less than a handful of times.
Okay. And Mr. Van Vechten, for you, along this same thread here, are you aware of any feedback or have you had flight crews report similar concerns that they've received about the reception quality from their aircraft while flying here or anywhere around the area?
No, sir, I have not.
Okay, thank you. I'm going to shift modes just a little bit here to helicopter route history and the development of those, and with a little bit of a focus on Route 4 as well. So, Mr. Stowe, could you provide us just a brief explanation of what helicopter routes and helicopter zones are, if you can? If this is out of your area, please let me know. What is their primary purpose, and how do they fit into the airspace structure within the DCA Class B airspace specifically?
Absolutely. I would specifically reference Air Traffic Order 7210.3 when describing the helicopter route chart program. Chapter 12-4-1, helicopter route charts are graphic portrayals of discrete and or common use helicopter routes and or operating zones located in high density traffic areas. Their purpose is to facilitate helicopter pilot access into and egress from or operation within charted areas. That's a direct quote, but generally speaking, these charts facilitate reduced or easier controller-pilot communications. There's a level of understanding when a helicopter pilot were to check in with a controller, reporting a route, what the expectation is, where they would be flying, where they would be ingressing and egressing. Overall, it helps with efficiency and streamlining traffic flows as well.
Okay. So along those lines, this for Ms. Murphy or Mr. Stowe, we heard earlier in Mr. Banning's presentation that the helicopter routes had no defined lateral boundaries. Could either of you explain why that is?
I can take a shot at it. So the helicopter routes are non-regulatory. They are merely recommended paths. It is expected that all pilots remain in contact with air traffic control while flying. As for the lateral boundaries, what is currently charted is nothing more than a symbol used to showcase the routes pictorially so that they look good, if you will, cartographically.
Okay, so how would, looking at those lines on a helicopter route chart, how do I know if I'm in compliance with that route from a lateral standpoint, if it has no lateral boundaries and it's just generally the area?
So I guess to build on her response, and I think to lead into the question, the charts are recommended for the purpose of streamlining pilot-controller communication and expectation, so the controller doesn't have to continuously assign a route. Knowing that there's no prescribed lateral boundaries and there's general recommended altitudes unless the controller specifically assigns via clearance or operating instruction to maintain an altitude or comply with the published altitude, it would be incumbent on the controller to ensure that they're monitoring the route of flight and address any conflicts and maintain or ensure a proper separation.
Okay. Mr. Stowe, continuing with you, would your office have been consulted in a request for establishment of helicopter routes that transition the DCA airspace?
So the local air traffic manager is responsible for initiating updates, changes, or initiating new helicopter route chart establishment. They would generally work with the Mission Support Services service centers, who would support establishing a local work group or task force, as it's referred to in the 7210.3, which would be comprised of local operators, and then a lot of local coordination work would be done, and then that would ultimately be passed off to the charting office to actually publish the charts.
Great. Mr. Fuller can thank you later because you just answered his question. Mr. Allen, are you aware of DCA air traffic control tower management and or the bargaining unit if they had any input or involvement in the development of the route structure at DCA Airport Traffic Control Tower? Now, I think it's been in place for quite some time, so you may not have been working there when it was, but do you have any awareness if the facility did have input on that?
Whenever we made helicopter route and zone changes in 2023, I believe it was, it was facility driven between the bargaining unit and management.
Okay. Mr. Fuller, is there a requirement for the Baltimore-Washington helicopter route chart to be reviewed at any specific periodicity by any entity?
Not that I'm aware of.
Okay. Ms. Murphy or Mr. Stowe, are you aware of any periodicity requirement that he might not be aware of for a review of those charts?
I would refer, since I have it in front of me, to the 72.3, again, same paragraph, that would require annual review as a responsibility from the air traffic manager for reviewing helicopter route charts.
Okay, so what would be the expectation of that review? Would that be documented in some form other than we conducted a review and everything remained the same, or would they fill out a report or some sort of correspondence through their hierarchy chain of command?
I don't know I'm not aware of a specific requirement. I would generally only be speculating or assuming that they would document it in some manner.
So, Ms. Murphy, would your office receive confirmation, let's say that facilities have conducted their annual review of their charts, their applicable charts, and then you would monitor that, or not monitor it, but you would see that or not?
No, Aeronautical Information Services only receives communication if and when a change to the chart is requested.
Okay. Mr. Allen, were you ever involved in conducting any of these reviews, assisting the air traffic manager potentially of the Baltimore helicopter route chart?
When I was a member of the helicopter work group, we did routinely review it, and that's how we came up with the changes that were implemented in 2023.
Okay. So I have to ask, I think I had it for later, but we're right at a point where it's probably a good point to ask this. Helicopter Route 4, the helicopter route in question in this event, do you recall either as part of the helicopter working group, as part of annual reviews conducted, or part of local safety council, anything that identified Route 4 as being problematic or conflicting with regard to your traffic flow at DCA Airport Traffic Control Tower?
Yes, we had those discussions.
Can you elaborate on that just a little bit?
When we met with the larger user groups of the airspace and discussed different improvements, ways we can make the system safer, more efficient, it was brought up with several different options, either to eliminate a portion of Route 4, move Route 4 over to 295 in Maryland, and both of those options we were told we were unable to do due to continuity of government operations or security.
Okay, thank you. So for Miss Murphy, do you have a history of the development of the route of the helicopter route structure there, like when they were established, these routes that transit the Class Bravo airspace at DCA?
Well, without records in front of me, I can detail a little bit. Route 4 appeared in totality on the first edition of the Baltimore-Washington helicopter route chart effective February 13th, 1986. It was largely unchanged until 1991 when air traffic added a compulsory reporting point at the Wilson Bridge. After that, there have been no changes until this early spring, post-accident, and we continue to work.
That is helpful information. So along with that, at its inception, Do you know, or are you aware, by looking at that back then, did DCA have a runway 1533 at that time?
I do not know without the chart in front of me.
Can anybody up there answer that question? Mr. Allen, do you know back that far if that runway had always been in existence there?
I wouldn't know that.
Mr. Fuller?
I'll take an IOU to get back with you and answer on that.
No problem. Okay. So my question would be, knowing what we know today with that route structure where it was there, would there have been an expectation that there would be consideration given to its proximity of the approach corridor to 3.3 and the departure corridor to 1.5 in this case?
I can take a shot at it. I think consideration of proximity and local traffic flows, patterns, or what the needs of air traffic are, is going to be highly site-specific and dependent on traffic flow densities within the airspace that may change over time. Not having specific knowledge of DCA, but broadly, the helicopter charts aren't specifically established to maintain separation. That would still rely on air traffic control to actively separate aircraft.
Which brings me directly to my next question. Was Route 4 procedurally separated from the approach path to runway 33 or the departure corridor from runway 15?
To my knowledge, no. I would have to defer to local air traffic as to what the consideration was when the routes were established or amended.
Understand. Mr. Allen, what's your understanding of that?
No, it is not procedurally separated.
Do you believe that the controllers, the control workforce at DC Airport Traffic Control Tower has a similar understanding across the board that that is not a procedurally separated route?
I can't speak for everyone, but I would say a majority do.
Okay. Mr. Dressler, did you or any of the other helicopter operators that you've been working with in the group there have an expectation that Route 4 was procedurally separated from fixed-wing aircraft there?
No, we did not have an expectation it was procedurally separated, but our group rules of the road are pretty explicit in saying that we would never fly underneath an aircraft on final.
Okay. And Mr. Van Vechten, same question for you. Did the involved Army helicopter unit have any belief that Route 4 was procedurally separated, that if they were on that, they would be separated from fixed-wing traffic arriving 3.3, departing 1.5?
Yes, sir, I did.
You had that thing, and was that a similar belief across the unit?
Yes, sir. Following the incident, I contacted many of my fellow co-pilots that were there, and everybody had the same assumption that we were not allowed to cross the departure and approach path of 1533 while on Route 4. We were always told to hold at the golf balls down by the sewage treatment plant just northeast of Wilson Bridge or at Haynes Point, which I'd done 100% of the time when I was on Route 4 and 3315 was active.
Okay, so that may have confused a little bit. So so the belief there would have been that you did not believe it was procedurally separated. Because procedurally separated, just so we have an understanding, when I say procedurally separated, meaning if you fly that route at the altitude you're supposed to and an aircraft flies that approach the way they're supposed to, they will have appropriate standard separation and will miss each other if they are both flying their prescribed route, right? That would be procedurally separated. What you are saying is that you believed there to be a mitigation in place. You were aware they were not procedurally separated and that without a clearance from air traffic control, you would either hold at a particular area or request clearance to proceed across.
That's correct, sir. When I say procedurally separated,
Yes.
I meant that a procedure prevented us from crossing 1533
Very
while
good.
on Route 4.
I should have prefaced that with a definition there of what I was saying. So thank you for that. Mr. Allen, do you know if consideration was ever given or there was ever a request made or a proposal made, I should say, for an alternate north-south routing to either replace Route 4 or alter Route 4 to help alleviate the conflict of where it crosses the Route 33 approach corridor?
There was discussion, like I previously mentioned, to either remove a portion of it or move Route 4 over towards the east, towards 295. But the zones also allow for north-south flow.
Do you know how high that proposal made it in the request chain at all? Did you receive any feedback or disposition of that proposed?
I don't know how high it went.
Okay. Mr. Fuller, do you have any awareness from your office? Did that ever reach your level?
No proposals to remove Route 4 ever reached my level. I looked back through the system service reviews and the corrective action plans developed for the facility, and there were no records of a request to remove Route 4.
Okay, thank you. And Mr. Allen, one last question for you in this area, and then I'm going to pass it along. Who, from your experience working at DC Airport Traffic Control Tower, who is the primary user of the helicopter routes inside the Class Bravo airspace? Is it a real mix? I guess what I'm asking is this a mix of a lot of helicopter operators, or is it primarily the military using the routes? How is it split up there? Or is it just a total mixed bag?
I would say a majority would be the various military branches with some of the other users mixed in at a lower level.
And how about Route 4 that was being used that day? Who is the primary user of that, or users?
It would be the military.
Okay. All right, that's all I have for now. I'll pass it along to Van.
Okay, I'll be asking questions about helicopter operations in and around the national capital region. Colonel DeForest, could you describe the Army's mission in and around the national capital region?
Absolutely, and before I do, Chairwoman Homendy, Member Graham, Member Inman, families in the room and those watching online, on behalf of the Army Aviation Brigade, as a husband and a father, I want to express my deepest condolences. This is something we think about every day, and your memory of the loved ones we lost are forever in my heart. The Army Aviation Brigade, specifically 12th Aviation Battalion, provides continuous, responsive, rotary wing support to senior military and government leaders in the National Capital Region to enable continuity government and continuity of operations missions. On America's worst day, our nation's leaders trust the 12th Aviation Battalion will respond on a very short notice. It's a no-fail mission that requires regular, realistic training within the national airspace system, and that's to maintain unit readiness for when the unit is called upon. Today, right now, 47% of our aircrew members in 12th Aviation Battalion are on mission lines waiting for that call. We're privileged to operate in the national airspace system in the National Capital Region. We have a very unique mission. We attract some of the very best across Army aviation, and we hold ourselves to a very high standard. Our mission involves both the zones and the majority of the helicopter routes in vicinity of DCA. And we see the routes and the zones as a risk reduction tool. They provide known altitudes and locations to deconflict with other aircraft. And I just want to be clear, there's others that perform a similar mission. So we view the helicopter route structure as a risk reduction tool.
So do you consider the use of the routes essential to the mission?
Yes, I believe they are essential to accomplishing our mission safely.
And can you describe any types or categories of operations along those routes that are commonly used?
Now, could you be a little bit more specific on types of operations along the routes?
So you have mission essential operations, training operations, non-mission essential operations. So what would all those be considered essential?
And for the training, so the mission rehearsals that we do conduct, and I think we understand familiarity, aircrew familiarity of the region, so knowing the altitudes, the terrain, the buildings, the hazards, that is absolutely essential. And those routes provide predictability to our aircrews. So for our mission rehearsals, yes.
Thank you. This is questions for Mr. Dressler. Could you describe helicopter operations, non-military helicopter operations in the NCR, National Capital Region?
Certainly. Since 2001, all of the civilian helicopter operations are mission only, and they're comprised of law enforcement with various entities I mentioned, U.S. Park Police, FBI, Metropolitan Police Department, Prince George's, and Fairfax counties, to name the law enforcement I can think of, and then all of the medevac operators. So medevac is easy to explain, that we're transporting critically ill patients, usually from tertiary treatment facilities outside of the city, to some of the world's best trauma centers, including Washington Hospital Center, George Washington Hospital Center, and Georgetown. And the transport of those patients into those critical areas in a very ground traffic laden environment is a lifesaver day in, day out. On the law enforcement side, the law enforcement officers perform both patrol, and then they may, in fact, transition into operational status during an active pursuit of some kind, generally speaking, a priority call of a crime against person, meaning homicide, carjacking, etc. And those operations have no specific destination in mind. They're merely performing those orbits or those pursuits while in flight.
So for those common non-military operations, is it considered the helo routes as essential for completion of those operations?
Yes and no. By and large, non-military operators use zones, and there are a number of reasons for that. And one of those reasons is to deconflict with military operations who are primarily on routes. In the case of medevac, we may not know exactly where our start point is, and there may not be a convenient route to get a critically ill patient where they need to go. In the case of law enforcement, these were originally in the 80s called police zones, and the reason for that is because other traffic would be confined to routes, and police would have the ability to patrol in those zones. So I think it's a mixed bag. Some of the routes, including 2 that were deleted after January 29, I would say are essential to our operations because they provide the safest way to transit east-west in the route structure. They're predictable. Zones, one limitation of the chart is that the altitudes are maximum altitudes. So, for example, a zone altitude might be a maximum of 1,400 feet, and that doesn't afford as much predictability as some of the routes themselves are very altitude specific. Route 4 along the Potomac is one of them at 200 feet, at the 200-foot cap. But if you could imagine then that a zone could be a maximum of 1,400 feet, so you might have a helicopter operating at 1,200 as a police helicopter conducting FLIR operations. You might have us at 1,400 feet. You might have others at different altitudes, and that presents a challenge in the zones.
And that deconfliction, is that done by ATC, the controlling agency you're talking with, or is that all visual or ship to ship?
It is, because it's Class Bravo, it is primarily ATC. All of us provide an initial request, which sounds like our route of flight. So we might ask for Zone 5 to RFK to Washington Hospital Center, for example. And air traffic control will clear us for that route. That's that efficiency portion that is really essential. It cuts down on our radio traffic and gives us predictability. in this airspace, I think I mentioned it earlier, that we have the ability to talk on air-to-air frequencies, but unlike other cities, because the Class Bravo airspace surrounds Washington, D.C., it's very, very challenging to deconflict ship to ship. Instead, you can't focus on more than one primary thing. Otherwise, it wouldn't be a primary thing. So focusing on the tower frequency, on the helicopter tower frequency as a primary focus because it's so busy, doesn't afford you much time to call another ship and deconflict. That is different than other cities, including Baltimore, and where you might very well say, hey, I'm MedStar 2 and I'm lifting off of shock trauma, and then other people in the area will be able to deconflict with you. So greater than 99% air traffic control.
Okay, thank you. And when operating, do the non-military operators have special considerations when deciding to use a route, one of the helo routes? Is there special considerations within the local operating area that helps you determine whether you to use the route or not?
I don't know of any other than individual company policies. So my company's policy after a near miss, unfortunately in 2017 with Black Hawk helicopters, my company restricted our ability to use anything between Key Bridge and the Woodrow Wilson Bridge. So we cannot use Route 1 or Route 4 because of the helicopter volume. We're also altitude limited, so by our operation standards, we cannot fly lower than 300 feet day or 500 feet at night. And so those are limiting factors that might vary company to company or unit to unit.
Thank you. Mr. Van Vechten, as a standardization pilot, what are the training standards for maintaining altitude on a particular route?
Pilots are expected to maintain their altitude plus or minus 100 feet.
If a helo route with a defined ceiling of 200 feet, would those standards apply?
Yes, sir. I mean, I don't think there's any expectation that we can maintain an altitude plus or minus 0. There's too many limiting factors. So again, talking to other pilots, I think the reasonable expectation is that being off on altitude by 50 or 70 feet, one way or the other, would not lead to a catastrophic event.
Okay, so for a ceiling altitude of 200 feet, 250 feet would be acceptable as a training standard?
No, sir. I mean, if a pilot is continuously above the altitude, they're going to try to correct. I'm going to make them correct. It's where they stay above it where it's a problem, but we call it bracketing, so a kind of above and below the altitude while you're trying to maintain a constant altitude.
Okay, thank you.
May I address that as well?
Certainly.
I hate to disagree, but at least on the civilian side, that is a hard altitude for us. We do not accept a plus or minus of 100 feet in the DCA route structure. That's maybe a commercial flight standard, but that is unacceptable and how none of our civilian members are trained in the DC airspace. So a 200-foot altitude or 300-foot altitude is a hard ceiling for us.
Okay, thank you. Mr. Van Vechten, could you describe the purpose of the annual proficiency and readiness test in the Army?
Sure. It's to determine a pilot's ability to perform the unit's mission.
And what could you go into a little more detail on what all that involves?
Yes, it includes the instrument flight evaluation, the standardization flight evaluation, a written exam, and a night vision goggle evaluation.
Okay. And is it common to conduct this evaluation at night on MVGs?
Yes, it is. The standardization flight evaluation does not give a mode of flight. The NVG, night vision goggle evaluation, obviously must be conducted under night vision goggles. The standardization flight evaluation, if conducted under the most demanding mode of flight, which is NVGs, will count for both evaluation, so you don't have to waste the blade time doing a daytime standardization flight evaluation and then going back out at night to do the same task under goggles. You can accomplish both at the same time.
Okay. Since we're talking about NVGs, can you estimate the percentage of night Army operations where NVGs are utilized?
Can you clarify, please? What
Just
you mean?
like, are NVGs normally utilized during almost all Army night operations?
Yes, ideally that would be the case. I would much rather be aided with night vision goggles than unaided, of course.
And is NVG crew proficiency important?
Yes, it's extremely important. Night vision goggles is the most demanding mode of flight, and so that's what we would train to the most rigorous standards.
Can you recall what the requirements are for that?
As far as annual,
yes.
It's 9 hours semi-annual per semi-annual period, 18 hours total, and you must fly 1 hour of NVGs every 60 days to be considered current.
Okay, thank you. And for people to help everybody understand the benefits and limitations of NVGs, could you describe what some of those advantages and disadvantages of using NVGs are as from an operator perspective?
Sure. First, the advantages, the quite obvious ones. Best visual acuity while unaided is 2200. So where 20/20 would be like good vision, your best visual acuity you're going to get while you're night unaided is 2200. So the ability to see is the #1 advantage with night vision goggles. It amplifies light, allows us to see in darker environments, and provides better acuity for the pilots. The negatives, depth perception, obviously is much more difficult to judge because we have monocular vision, whereas right now I'm using binocular vision, so it's much harder to judge depth perception. It was mentioned earlier, the limited field of view, so approximately 40 degrees compared to roughly 180 degrees, what I have right now. But it's also, it's easy to confuse ground lights with aircraft lights. You can see through haze, which is an advantage initially until you're fully engulfed in poor weather, and then it becomes a disadvantage. So those are some of the advantages and disadvantages.
And what about being able to see aircraft silhouettes? Do you just see point lights, or can you actually make out the shape of the aircraft?
Well, it really depends on the distance from the aircraft. Normally, I'm not close enough to make out the silhouette of an aircraft. So they mentioned earlier about looking underneath your goggles. So as you're flying night vision goggles and you see a light that is potentially a hazard, it's common practice to look underneath the goggles to verify what it is, because you could very easily confuse, say, a vehicle passing on Wilson Bridge as an anti-collision light as it goes across, or a vehicle on elevated terrain making a turn. It flashes into your eyes, so you must visually acquire what it is. So you really can't see the silhouette. Our goggles have trouble seeing blue and green lights, so the right side of an aircraft would be much more difficult to see. A red light is much brighter, and then white lights obviously are bright as well.
And how are the crews trained to compensate for the more narrow field of view?
By scanning.
Could you explain that a little bit more, please?
Yes. So we have a saying: we cannot increase our field of view, but we can increase our view of the field. So as I scan my head from left to right, I kind of move my eyeballs from left to right inside the goggles, increasing my view of the field. We try not to get tunnel vision or get fascination fixation on an object. So we're constantly scanning to pick up different reference points to pick out objects in the distance.
And that's a common training technique?
Yes.
Okay. So this question's for Mr. Allen. From what you've heard...
Mr. McKinney,
yes.
Can you hold for a second?
Certainly.
I would ask that witnesses put away their electronic devices. If you are communicating with your party tables, you should not be doing that. Please put them away. If your party wants to ask a question or get information to you, you can ask it during the Q&A period. Thank you.
Okay, this question's for Mr. Allen. From what you've heard regarding the use of night vision goggles by flight crews, would it benefit air traffic controllers to be trained on the advantages and limitations of NVGs?
Currently, air traffic control we don't get notified that they're using MVGs. We wouldn't know, as far as from an air traffic standpoint, operationally, what that would look like. I think we would need more input on their uses.
Would the knowledge of the MVG limitations affect how air traffic controllers handle the traffic?
Potentially.
Okay.
Can I add to that?
Certainly.
So it would generally be the expectation for air traffic that for Class B operations, all aircraft receive traffic advisory, safety alerts, and air traffic provides separation services to all aircraft. We're also heavily dependent on see and avoid and relying on 91.113. I would refer to the 7110.65 Class B separation criteria for helicopter to helicopter would be that IFR or VFR helicopters are not separated from other helicopters. So it would be dependent on pilot see and avoid, independent of the use of night vision goggles.
Okay, thank you. I think I'll pass my time over to Dr. Wilson.
Thank you. I want to go back to something that Mr. Allen said when we asked about moving Route 4, if there had been any discussions about changes to Route 4. You said that the response you got was something to the effect of continuity of government operations and security. And then it piqued my interest, Colonel DeForest, because in the mission statement that you said, you mentioned continuity of government operations. And it made me think, was the Army, you or the Army, aware, or did you see any proposals that you were able to provide feedback on regarding changes to Route 4? It piqued my interest that the wording was very similar to what the response to DCA Tower was, and then the Army's mission. That's for you, Colonel DeForest. I apologize.
Okay. I thought it was for the colleague next to me. So that specific route is an option for our air crews, or it was an option. And when we look at our response times of our air crews in certain locations within the National Capital Region, so Route 4 was heavily used by our air crews on our mission rehearsals.
So my question was, were you aware of any proposals to make changes to that route?
The only proposal for a change that I'm aware of involves noise abatement, not necessarily lateral movement. So noise abatement was the only proposal that I'm aware of.
Thank you. Mr. Allen, you mentioned when we were talking about radio transmissions and some of the difficulty with some of the operators, you mentioned both Muscle and Pat, that you might have more challenges with the radio communications with them. Are there any other concerns or challenges when Muscle and Pat are operating in the DCA airspace that raise concerns for controllers?
I think additional concerns are they do conduct a fair amount of training missions. New folks arrive on base or maybe come up from a National Guard unit or something that aren't as familiar with the airspace. So being unfamiliar in a high volume, high complexity airspace naturally has its own challenges.
Mr. Van Vechten, or perhaps Colonel DeForest, do you have a response to that, or some additional information, insights that you want to share. Does that surprise you that there might be more concerns when particularly Pat is operating in the DCA airspace?
What I would add is our participation in specifically the DC rotary wing working groups. That has not been raised to our, at least the unit level, that there was a concern with the Pat call sign. And I'll hand it over to Mr. Van Vechten.
Yes, I was a member of the DC Helo Route User Working Group. Some of the concerns that were brought up were noise abatement was the main one. And then when inside the aircraft, so we avoided the zones that were active, and anytime Falcon, which is the DC Metro, was active in a zone, we would avoid those zones. But I was not aware of any requested changes.
Mr. Allen, going back to the proposal to make changes to Route 4, do you recall when that proposal was made?
We had attempted it when I was part of the helicopter working group in the 2021-2022 timeframe.
Okay, thank you. And was there a documented proposal that you recall?
Not that I recall.
Okay. Mr. Dressler, we've talked about concerns about certain operators in the DCA airspace. From your perspective, are there any operators that you feel cause concern for your operations?
Unfortunately, yes. And I don't take any pleasure. I'm a former Army aviator, and I'm a retired Air Force officer. And I don't like to say that that the Air Force First Heli is a concern, and I really don't like saying that 12th Aviation is a concern. But it was a widespread concern, and it was noted to the battalion commander previous to the current one in about 2022 or 2021 by a member of our group that there was a significant issue with both training and attitude toward operations within the DC airspace.
And could you expand, so how did that affect your operation?
Well, when you combine that with our 2017 near miss, my company and the other operators in the area either curtail operations or there's not much we can do when we have a medevac patient and we're trying to get a critically ill patient where we need them to go. But our best answer is to maintain extra vigilance. It's an extreme challenge, especially when those aircraft are not usually transmitting on ADSB, and I can't see them on my traffic system, and all kinds of challenge inherent there. I think our best answer is extreme vigilance. I know in our company policy we fly as high as possible, so we'll take the maximum of any of the zone or route altitudes. And the air traffic controllers, we have a fantastic relationship with them and have always had that, where we can ask for something different. So if I need to ask for a deviation, and the same with all of our members, we're not bound by that, and they'll grant those requests whenever possible. The best answer I have for you is see and avoid, which is the basic tenet of every aviator on the planet.
Thank you. I'm going to jump to a different question because that's twice now that I've heard see and avoid being used. So Dr. Kastner, if you could talk about see and avoid, what are some of the benefits of it from a pilot's and an air traffic control perspective, but also what are some of the limitations of see and avoid?
Well, see and avoid is one of our most basic, familiar cognitive perceptual faculties. Is when we use our eyes, ears, and attentive minds to look out for hazards, anything that might get in our way. The advantages is we have a lifetime of experience of using it, so we don't need the user's manual. And then comes the problems associated with it, in that our ability to pay attention is very narrow. Even our focused vision, if you hold your thumb out at arm's length, that's about how much you can see in focus at any one time. You could hold a book or a page behind it, and if you stare right at your thumbnail, you find that you can't read the words even beside them. So that's quite limited right there. So we get good at knowing where to point it, and we also benefit greatly from any kind of clues, hints, tips, where to point our eyes in a complex situation. And the more we know, the more information we get, the better we get at it.
Also for you, Dr. Kasner, one of the questions that Mr. Soper asked of the panel members were some of the complexities of operating within the DCA airspace, and some of the things that were mentioned was a mix of traffic, the nearby airspace of other airports, prohibited areas. It's a small airspace. So we've got this high density airport, mixed traffic with different performance capabilities. We've got nighttime conditions, we've got intersecting runways, we've got cultural lighting. So with all of those things, again, if you can speak sort of from the pilot's perspective, but also a controller's perspective, what do all of those complexities do to human performance and how we operate?
Well, they challenge it, for sure. It makes it harder. But again, the more I know about them in advance and the more information support I get while I'm exercising that vigilance, the better it's going to be, certainly.
What about in terms of, if you can expand a little more, in terms of workload, situation awareness, how do we manage all of those things, and how are we able to do it? We know that controllers are able to operate with these complexities. So what are some of the processes that they go through? How do they manage all of this information in order to make efficient decisions?
It's all very challenging. And we get so many sources of information coming our way. So for example, we talked about hearing other aircraft on the radio. What we call the party line. You gain so much awareness, you can gain so much awareness by listening to what other people are saying. What are they doing? What are they having trouble doing? Spotting another aircraft? I want to know if I'm that aircraft that they're having trouble spotting. You just take whatever clues are out there and of course provide as many as you possibly can with your charts, your ATC directives, your training, anything.
Speaking of charts, you're familiar with both helicopter and airport charts, given your experience. Looking at the DCA and the helicopter charts for this area, is there other information that you think is missing? More information is needed, less information? Is there any insights that you have from a human factors perspective on the charts as they're currently presented?
Yes, I like both charts, and I would like them to be one chart. I would like the information on the helicopter chart to also be shown in some way on the airplane charts and vice versa. If there are helicopters operating in the vicinity of my approach course, my glide path, I at least want to know about that. And we spoke a bit about airport familiarity. That's just the kind of thing that I'd like to know when I'm coming to DC for the first time or the second time. The experienced pilot probably already knows about it, but for me coming in there the first time, it's the first thing I want to hear.
Some might argue that these charts are already full of information, and is there a risk that by putting more information, we're just cluttering the chart and that information is just going to get lost?
Yeah, you really have to weigh the costs and the benefits there. Certainly more symbology on the chart is going to make it more complicated, but then what's the cost of not knowing about it at all? It's a tough needle to thread, but I think this one, there should be something there.
Mr. Banning's opening presentation of the air traffic control audio. The controller was talking to a lot of aircraft at this time. We've got a helicopter that's got visual separation. So the expectation, of course, is that they're going to see and avoid. They said they have the aircraft in sight. What does that do to, from a controller's perspective, how does a controller, from the human factors perspective, so I'm talking to another aircraft, and how do I switch gears from this primary task that I've got aircraft calling me, I need to talk to them, now I need to shift gears and say, wait a minute, this guy who I thought was maintaining visual separation is now on a conflicting path with another aircraft. And so how does that information processing work, and how do we shift gears in order to, from that primary task to another primary task?
Well, I'm certainly no air traffic control expert, so difficult, but it sounds like workload and complexity to me. And another thing we call context switching. It's very difficult. Suppose you're having two conversations. You're talking to someone in the room and someone on the phone. It actually takes a while to go back and forth. You have to reload the details in your mind. It's the same thing we explain why it's dangerous to text and drive or talk on the phone and drive. Switching back and forth takes time.
Thank you. I appreciate everyone's responses. That's all the questions I have for now.
I'd like to shift to the history and activities of the DCA Helicopter Working Group. Mr. Allen, we learned through post-event interviews that there was a DCA Helicopter Working Group founded at the DCA Airport Traffic Control Tower that may have looked at these very concerns, and that you participated in the activities of this group for a period of years. Is that correct?
Yes, I was on the helicopter working group in the early 2020s through 2023.
Okay, perfect. Thank you. Could you please step us through the origin of the group, for what you know, and what was the catalyst of it being formed?
The helicopter working group, prior to me joining it, had always, as long as I had been at DCA since 2013, there was always some version of it. And as time went on, the panel members may have changed over the years, but it would consist of management personnel and NACA bargaining unit employees, and their level of involvement as they saw fit for the group.
Did this group have a mission statement, a statement of work, or anything along those lines?
I don't recall specifically.
That's fine. What organizations or personnel were represented on this group?
The group itself was contained within the facility. Like I said, it consisted of management personnel and air traffic controllers, bargaining unit employees.
Could you tell us a little bit about the activities of this group?
Yeah, the group would, they would meet, discuss any challenges, any operational challenges that they had seen, if there was any safety reports or data that was available, they would discuss that. We would provide, when I was on it, we looked at the mandatory occurrence reporting data as a driver for some of the changes that we were able to implement, and we would provide outreach to all the various user groups.
What were some of the participating user groups?
I can't recall specifically, but there was always multiple law enforcement agencies available, multiple medevac, and multiple branches of the military would be present.
What are some of the advantages to speak with the users and show them your operation? Would they also perhaps speak to their concerns with you guys?
Yeah, so it's a great tool to provide that outreach to the user group that you're servicing, providing services for every day, as our customers, and vice versa, what we can do better for them. Anytime you can take the user out there in the airspace and put them together with the controller and share those stories, share that perspective, and get eyes on what each other's operation is, that's that much more knowledge that you can gain, that much more safety that can be gained by that.
Thank you. I appreciate that. Do you recall if, while serving on the helicopter working group, did the group ever propose changes to the helicopter route structure, which we've kind of already discussed Route 4, so we understand that portion. But did the group ever propose changes or any other operational safety improvement change recommendations that would pertain to operations within the DCA Class Bravo airspace?
Yeah, we proposed several others. We proposed lateral boundary changes to some of the zones, and in addition, altitude changes to certain zones and routes.
Was there any formal, safety risk management process conducted in assessing these change proposals?
Yes, and I forgot we did publish a new transition point further away from the airport for the helicopter users. Yes, with the changes, we conducted a formal safety risk management panel.
Do you recall the response provided or the disposition of any of the group's recommendations? And if so, how or from whom were you informed or advised?
We conducted the safety risk management panel after multiple rounds of meetings with the user groups and making adjustments as needed, and settled on a final product. We conducted the safety risk management panel, and I believe the final document, there was no hazards identified with the changes that we were going to make. With that, since there was no changes left to make, we had environmental study done. That was completed, and the last part was charting the changes that we had proposed.
I'd like to get back to that Government Accountability Office proposal about the noise abatement in just a minute. But Mr. Fuller, having heard this information, do you recall ever being made aware of these proposals or having advised management at the district or facility level in responding to these proposals?
I believe the specific proposal he's discussing was in 2022, 2023, sometime around that frame. And those helicopter chart changes were made and weren't effectuated.
Okay, in 2019, this is what we were talking about just a minute ago, the Government Accountability Office was tasked with conducting a study into the problem of helicopter noise over the Washington, D.C. area after a spike in community noise complaints. It is our understanding that the DCA Helicopter Work Group reviewed these findings from the study and developed a series of recommended changes to the Baltimore-Washington helicopter route chart, which were presented at a helicopter symposium held in November of 2022. What are some of the changes that were presented at that specific symposium, Mr. Allen?
After the completion of the GAO study of helicopter noise impacts to, I believe it was out to a 30 nautical mile range from DCA, the regional administrator had come to DCA and shared the study with us and asked us to take a look at it. And see, hey, is there anything better the FAA could do with noise? The local helicopter work group took that information, reviewed it, and then looked at our own internal safety reporting that we had and saw some areas where, hey, we could make this better. So we can improve noise and improve safety all in the same scope. So with that, we came up with the proposed changes that were implemented in June of 2023.
Upon reviewing your proposal during the helicopter symposium, I noticed that you had, Mr. Allen, your facility had hoped to chart hotspots on the Baltimore-Washington helicopter chart. Can you speak a little bit about what are the hotspots? What are hotspots, first of all? And what were you trying to do by requesting them to be put onto the helicopter chart?
So hotspots are an airport diagram depiction to show areas of concern on an airfield map. We were attempting to, since we were not able to change Route 4 and the proximity of some of the other routes or heliports or hospitals, we if we weren't able to change them, or we can't move a hospital, then let's at least draw attention to it for the users. So our attempt was to take something similar on an airport diagram, apply it to the VFR helicopter chart, and draw attention to it, since we weren't able to change the location of helipads or, in this instance, also a route.
Mr. Allen, what was the feedback received by from some of the attending helicopter users about the proposal to add hotspots to the Baltimore-Washington helicopter route chart?
From my recollection, everybody was satisfied with, adding an additional layer of safety to the helicopter map.
Mr. Allen, as we spoke before, you mentioned that there was a safety risk management panel convened in approximately April 2023 to assess the potential risk of these proposed helicopter route chart changes to include the hotspots. You already kind of summarized. Well, could you please clarify, what was the findings? What were the findings of this panel? And did the panel agree with the proposal to chart these hotspots?
The safety risk management panel concurred with all the proposals and identified no hazard.
Thank you. Ms. Murphy, this is for you. FAA order, Joint Order 7210.3 outlines the procedures for requesting changes to aeronautical charting. What steps did your office take to address the request to chart the hotspots on the Baltimore-Washington helicopter route chart? And was there a formal response to the request?
Yeah, thank you. So Aeronautical Information Services did receive a request for multiple chart changes to the Baltimore-Washington helicopter route chart in June of 2023. We implemented all of the changes, as Mr. Fuller mentioned, with the exception of the addition of hotspots. Hotspots are associated with ground or surface movement and are not within the VFR aeronautical chart specification.
Is your group able to give suggestions as how to implement the intent of a hotspot without making it called a hotspot?
Could you clarify the question?
So I understand that hotspots are normally used for surface areas of confliction maybe, and that they want to bring attention to it. So it seems to us that this is something that maybe is this a new idea to try to highlight an area that is airborne, that is a potential for a conflict? Is there a way or a process that it could be put on the chart without calling it a hotspot?
Absolutely. Aeronautical Information Services hosts a biannual aeronautical charting meeting. Anyone, public, industry, is welcome to come and submit a recommendation document. It's discussed amongst our aviation peers, stakeholders, the military, the FAA, and ultimately it's decided whether or not to implement the recommended change. So that would be one way of having a new charting symbol or something, some new feature charted.
Do you know if that information was passed back to the facility?
I don't have evidence to confirm it. However, it is the standard operating procedure to always suggest that as a conduit to have a chart change.
Okay, thank you. I think I'll pass it to Van. Thank you.
Okay, before I get into ADSB policies and procedures in the airspace, I have a couple of follow-up questions I'd like to ask. Mr. Allen or Mr. Fuller, the FAA said that earlier that the altitudes on helicopter routes were recommended altitudes. So does that mean those operating on those altitudes can vary on the route unless otherwise instructed by ATC?
Yes, those are recommended altitudes on the charts. They are not regulatory in nature. These are VFR charts. Those aircraft do have a requirement to maintain clear of clouds, avoid other aircraft, maneuver as necessary. If air traffic needs a specific hard altitude in Class B airspace, they will assign it. There are some helicopter charted areas that only mention an altitude at or above or at or below and don't have a finite altitude for helicopters to maintain. And I'll pause here and see if Mr. Stowe would like to provide additional information based on his technical knowledge.
Yes, that would be accurate, especially considering there are specific pilot requirements for Title 14 CFR 91-119. There may be other pilot limitations, such as Part 135 operators, for example, have a minimum safe altitude of 300 feet, so they would be unable to comply. It would be the expectation of air traffic that if, in the event, a pilot would require a different altitude than one that's specifically assigned, that they're cleared on, or assigned, that they would advise air traffic.
So if a pilot's not assigned an altitude but cleared for the route, should they consider that hard altitude symbology on the chart as their assigned altitude?
I think it would, I would have to review the specific phraseology and the details. To refer back to the helicopter route charting program, I think it's the subparagraph B, or in the initial part of the paragraph. It may also be dependent on any specific language in a letter of agreement with certain operators. So I think I'd have to have some context or a specific example.
Okay, thank you. And Mr. Van Vechten, you mentioned that you did not believe that the clearance between Route 4 and visual approach to runway 33 were vertically separated. Is that correct in your earlier statement?
I thought the procedure was we were not allowed to utilize Route 4 and cross the departure path of 1533 or the approach path if there was landing traffic.
Okay, so then you think that there wasn't vertical separation between the route and the approach to 33?
I will say I assume that there's insufficient vertical separation, and that's why I was never allowed to cross the approach path.
Okay, we did talk to some other pilots, and they thought that there was some vertical separation, other pilots in the battalion. Can you maybe give an explanation of why some pilots thought there was vertical separation and some pilots didn't think there was vertical separation on that part of the route?
No, I can't explain that, sir.
All right, thank you. I'm going to go into some ADSB policies, this line of questioning. So, Colonel DeForest, what was the ADSB use policy for the 12th Aviation Battalion at the time of the accident?
So at the time of the accident, this is always the case, we, our battalion's entrusted with the lives of some of our most senior leaders, so both safety and security. So applying risk management procedures at the time of the accident, we perceived the risk of security as paramount. Knowing ADSB out, what that the signals it sends out, we assessed that was a risk that could be mitigated. So the policy, the day of the accident, was to have ADSB out, off, anytime you are conducting anything related to the mission, i.e. flying near a mission route or location.
And what guidance did you have to develop this policy?
At the time of the accident, it was Army policy, and which we were in compliance with, in addition to the MOU between the DoD and the FAA.
Okay, thank you. And when the aircraft are operating ADSB out off, are they required to broadcast mode C, mode 3A and C?
Yes, they are.
And one part of the SOP states that the air crews are not to change transponder modes in flight. Could you explain the rationale for that?
I believe the rationale, because in the Lima model helicopter, it's several steps that you would not perform in flight.
So that's a system limitation and not necessarily a policy type of guidance?
To my understanding, yes. It's approximately 20 things you must do as an aircrew member with your heads down to make that configuration change.
Obviously, and you didn't want your air crews doing that in flight. Understood. From your knowledge on the on PAC 25's route of flight, were they utilizing mission routes or mission sites that would authorize them to use the ADSB out-off policy of the SOP?
Yes, they were.
Thank you. This question is for Mr. Dressler. How does the prevalence of non-ADSB out flights impact the operation in the DCA Class B airspace?
It adds an unacceptable layer of complexity and risk to this system. So when you look at the flight profiles, and if we talk specific to night NVG operations, and we've heard how stressful and how demanding those flight regimes are, then when you are being given traffic information from ATC, which you may or may not, most likely, be unable to see, it's remarkably difficult to see an aircraft at distance, and it becomes obviously quite easy within 2 miles or a mile. So in the way that all of the civilian helicopter operators are configured, including law enforcement, is we have a traffic avoidance system. It's not TCAS, but it's TCAD, and it is ADSB dependent. So when you are scanning, goggles or no goggles, looking around your goggles, and you can or cannot identify an aircraft, your next step in your situation analysis is to scan your traffic system. Well, that's completely useless if aircraft don't show up because they're not broadcasting. So it adds an enormous risk that, in fact, having talked with other DoD units, I do believe there is a specific use case, limited specific use case, and I think that the other units that we've spoken with, which I don't think I should name publicly, but the other DoD units, with their national security mission in very specific circumstances. I think your question, I hope your question is more about the general application or lack of use of ADSB, and the user group finds that to be an enormous risk.
Thank you. How often do you observe helicopters within the DCA Class B airspace operating with ADSB out off?
Every day.
Every day.
Including to this day.
And for those situations, what is your primary technique for avoiding that traffic?
We rely upon air traffic control for Class B separation. Primary, to repeat myself from earlier, would be see and avoid, and take whatever steps necessary to change our route, our altitude, our airspeed to avoid, and further try and emphasize on frequency, make a call that might restate that we're operational. So a law enforcement member might have notified air traffic control that they're on an orbit, on a mission orbit, and perhaps the air crew of the other aircraft, specifically DoD aircraft, may not have heard that. Maybe they were coming off of another frequency, transitioning, say, from Andrews into DCA. So my third answer to your question is we'll restate our mission profile in hopes that that other aircraft is now alerted to the fact that there's an operational aircraft in the way.
Thank you. This question is for Mr. Allen. How does the prevalence of non-ADSB out flights impact air traffic operation within the DCA Class B airspace?
With our STARS radar that we use with fusion mode, the ADSB out off has no impact.
Would an air traffic controller know if an aircraft was or was not transmitting ADSB then?
No, we're not required to have that capability turned on the radar screen.
Does having aircraft with with ADSB out off, does that impact any of the ATC services that you can provide?
No.
From an ATC perspective, is there any safety or operational benefit to aircraft that are operating with ADSB out on?
Not that I'm aware of.
All right, that concludes my questions.
I actually have one follow-up question here that we were discussing. I hate to go back to this one same area again. We're talking about the routes, the altitudes of the helicopter routes, and it's been stated that those are recommended altitudes. And we heard Mr. Fuller explain how, I don't remember if it was Mr. Fuller, but explain how, they have a whole lot of other things they got to do, remaining clear clouds and remaining clear of obstructions. They're flying VFR, CNBC, and all that stuff. So you can expect some variance on that route. The question would be, though, what's the purpose of an altitude cap if it's recommended? And what would air traffic control do anything? So I'll make this question for you, Mr. Allen. If air traffic control observed a helicopter on Route 4 in an area that had a 200-foot recommended altitude restriction, would you say anything seeing that aircraft over that, coming up above that altitude? Would that prompt a control instruction from you?
Yes.
Okay. Why?
The way the helicopter chart is trained within the facility, that the altitudes and the zone boundaries and such are need to be followed by the air crews.
Okay, so how much of an altitude variance would prompt you to have them check altitude or to give them a restriction, or how long would it have to be there before it prompted you to do something? Is it something that is, as soon as you've seen it, you would do it, or you would watch it? How does that work for an air traffic controller?
I think it would be controller specific.
Okay.
And situationally specific.
Okay. All right, thank you.
One follow-up with that same line of questioning from Mr. Soper. So you just said it was controller specific. So is there any FAA guidance in terms of altitude deviation when you should start talking to a flight?
Well, this is a VFR chart with suggested altitudes. The facility within itself trains that the helicopters need to be at those altitudes. So a controller, if they notice them leaving it, maybe they'll wait a second and see that it comes back down, or maybe they take action immediately. It's situational and controller dependent.
Okay, so no set FAA policies, just up to the controllers to take care of it. Mr. Fuller, did you have a comment?
Yes, sir, Dr. Bauer. If I may add in, ultimately the controller is responsible for ensuring positive control and preventing a collision. And so if that altitude was needed to ensure separation, our expectation would be that controller would assign that altitude specifically to maintain, if that was the only barrier they had for separation. If they were going to allow that aircraft to go up or down, they have other tools they could use, like radar vectors, to do a 1.5 mile separation in lieu of the 500-foot vertical separation requirement. If they're solely just relying on altitude, our expectation is the controller would maintain positive separation as required in Class B airspace.
Thank you very much. That completes the technical panel's questions for the moment.
Thank you very much, Dr. Bauer. Normally, I'd say we could take a break, but I actually don't know if the restrooms are working. So if you have to go to the restroom, I'd say go ahead, but we're not going to take a break. We're going to go right to parties. So we are going to go ahead and start with the U.S. Army in reverse alphabetical order.
Thanks, Madam Chairwoman. Just clarification for the FAA. We talked about within the Army conducting, on the night of the 29th, conducting what we would call an annual proficiency evaluation test. Do commercial carriers and other activities conduct similar tests within Class B airspace?
So there are training flights, much like the military conducts training flights. Air traffic would have no way of knowing that unless a pilot disclosed that. We provide a service if it's a practice approach, ILS approach, things of that nature, but we don't specifically ask that of pilots.
But specifically for commercial traffic, there are operational check flights that occur in the national airspace in places like DCA. Is that a correct statement?
I believe so. I know there's a special pilot certification that you need to land and operate within DCA. I would defer the question to some of our airline colleagues here to answer that specific point.
Okay, thanks. No further questions.
Thank you very much. Sikorsky.
Sikorsky has no questions this time, ma'am.
Thank you very much. PSA.
Thank you. Mr. Allen, you were discussing the moving of Route 4 out to 295, and in that working group, you were talking through that for continuity of government or security, it wasn't moved. Who told you all that you couldn't move it?
Those discussions occurred with the user groups and management within the facility.
So you don't know who did it? Was it documented in the SRM? I mean, obviously a risk or a hazard was identified. Was that not documented?
The SRM was for the proposed changes to go into effect. We never got to that stage with Route 4. So it wasn't part of the panel.
Okay. I don't understand if there was a risk or a hazard that was identified. It wasn't documented, is what you're saying of Route 4. Somebody wanted it moved, right?
Correct.
And they wanted it moved for a reason, that there was a risk or a hazard.
Correct.
But there's no documentation of that in the SRM?
Mr. Poole?
Sir, if I may just clarify. So SRMs are primarily used for changes to the NAS. I think what what Mr. Allen is discussing is they were ideating on potential hazards, never got to the point of formally proposing that as a change. They went forward with additional changes that were effectuated to the system, and then for those changes, we did have to do an SRM panel on. And so I think the point that he's talking about was just in discussion phase.
Gotcha. So whenever you guys do a management of change, is what you're doing for any charts or anything like that, you don't risk assess?
Ideally, that would have been captured in their local safety council documentation, but it wouldn't have made it to the formal SRM documentation. And I don't know if they captured that. I would have to, again, discuss with Mr. Allen and see what documentation they kept back then. I was not a member of that particular work group, and as an external member, I wouldn't see what they locally documented.
And this is back in 21 to 23? You saying back then?
Mr. Allen, is that in your 21 work group?
Yes.
Okay, thank you. Okay, sorry, I'm trying to. During this working group, Mr. Allen, was there any consideration to establishing lateral boundaries for the routes, particularly Route 4?
No, there was not.
Not at all. Thank you. I guess getting back, was there any written SOPs between ATC and the Army battalions on that prohibited traffic from proceeding down Route 4 when there's landing traffic in 3-3?
No.
That you're aware of?
No.
Mr. Van Vinkton? I know you mentioned that you've never went down Route 4 when there was landing traffic. Was there a written policy there or anything between the two where you didn't do that?
No, sir. I was not aware of a written policy by ATC. I just assumed that it was prohibited or not allowed.
Okay. Sir? Colonel DeForest, you said your mission required regular realistic training in the event of continuity of government situations which require the evacuation of government senior leaders. Do you anticipate during that commercial air traffic wouldn't be stopped?
Tough, realistic training has to, if you think of the different scenarios, our response times are very quick. And I'll use 9/11 as an example, the amount of time it took for commercial traffic to land. It probably was minutes, less than an hour across the entire country. So we have to factor in there will be commercial traffic in this airspace.
So there wouldn't be time to clear the traffic is what you're saying? Sorry.
That is correct.
Yeah, okay. Just curious. All right, Mr. Allen, Mr. Murphy, if the helicopter routes have no lateral boundary, is there some limits to how far off the line the helicopter can go?
I would. It's an air traffic control decision.
There's no charted limits.
So, as you know, in this accident, they were not on the left bank. Obviously, they were coming towards the center of the Potomac there. How far over do you let them go? There's no lateral boundary.
As Mr. Fuller stated earlier, it is a VFR chart. The altitudes are recommended. There is a key that describes the route of flight for the helicopters, but it is incumbent upon the helicopter to report locations and air traffic control to provide the Class Bravo services.
And sir, we are working, our current helicopter working group that is active at this time is working with our users to establish lateral widths to those helicopter charts, and along with compulsory GPS reporting points. So yes, we didn't in the time have those in effect, and we currently don't at this time, but the long-term goal is to have defined widths and reporting points.
Thank you. I see I'm out of time. Thank you, Chair.
Thank you very much. And we will go to NADCA.
Thank you, Chairwoman. First question is for the U.S. Army. Mr. Van Vetjen, could you let us know, or could you advise if the pilots or the flight crews are able to monitor multiple frequencies while operating the helicopter?
Yes, you can. Most of the UH-60 Limas in 12th Aviation Battalion are outfitted with ARC 231 multiband radios, so I can have 2 VHF radios and 2 FM radios. But there are some legacy aircraft where it's 1 VH, 1 UH, and 2 FM radios, so we could monitor multiple radios at the same time.
Thank you. Was it common practice or recommended for the air crews to monitor both local frequencies when operating on any of the helicopter routes?
No, it was not.
Okay, thank you. And then just going back to your time operating, and you spoke of operating on Route 4 with, but not with aircraft landing runway 33, thought that was prohibited. Were you ever operating on Route 4 with aircraft arriving or departing National Airport?
The airport in general, yes, sir.
Thank you. Just over Mr. Stowe or Ms. Murphy, just regarding the charted helicopter routes, are they considered ATC instructions?
No, they are not. They are recommended paths.
Okay. And then if the paths are only recommended, how does one know when to use the recommendation or not? What is the expectation?
To follow air traffic control guidance.
So they would be cleared on the recommended route?
That is my understanding.
Okay, thank you. And then just with the design of the route, is the intent of the route to be separated from other routes or other obstacles, aircraft, anything along those lines?
I don't know the answer to that.
I can add that it's probably very situationally dependent locally on what I guess the needs are of the facility. It probably depends, or I would suggest it depends heavily on complexity, need to standardize, or, I guess standardize the traffic flow for the purpose of ensuring separation. And would defer to DCA locally as to whether or not that's something they desired or had built in.
Thank you. Mr. Allen, did you believe Route 4 was separated from the runway 33 arrivals?
No.
Thank you. And then Route 4, the helicopter Route 4, do you believe it provided a benefit to the operation?
It provided a benefit to expedite the movement of helicopters.
Thank you. And then Mr. Fuller, just a follow-on question from earlier. Air traffic, I think you stated something along the lines of air traffic is required to separate the aircraft operating on Route 4 from other aircraft. Could you explain the tools or the methods that air traffic control can use to separate helicopters, for example, from aircraft?
Absolutely. They can assign altitudes. They have a certified tower radar display, and they're trained on providing suggested headings, altitudes, courses to deconflict those aircraft. In addition to visual holding is another tool. They can instruct the helicopter to hold at a prominent obstruction like Haynes Point, like was previously mentioned. There's a myriad of options for controllers in Class B to provide positive control there.
And thank you. And I should have mentioned pre-accident in the rules. Is there any rules in place that can transfer the separation responsibility from air traffic?
Yes. Prior to the accident in the DCA class Bravo airspace, if the pilot reports traffic in sight and advise they will maintain separation from it, the controller only need to approve it, the operation, or they could issue the traffic and then instruct the pilot to maintain visual separation from that aircraft. They are still required to maintain Class B separation before and after the application of visual separation. And in that particular case, in this operation, they would normally advise the other aircraft that traffic hazard inside is maintaining visual separation.
Thank you. No further questions.
Thank you very much. FAA.
Thank you, ma'am. Chief Warrant Officer Van Vechten, can NVG be qualified in a simulator?
No, you cannot.
Okay. Mr. Stowe, if routes are not procedurally separated, what's required to maintain legal separation in Class B airspace?
In Class B airspace, it would be dependent on a number of the tools previously mentioned by Mr. Fuller. The radar separation requirement would be 1.5 miles and 500 feet for a VFR target from a IFR, VFR, or fixed-wing aircraft weighing 19,000 pounds or more, or target resolution or 500 feet for aircraft if it involves aircraft weighing less than 19,000 pounds. There's also tower-provided visual separation, that's an option, as well as visual, as was previously described.
Thank you. Mr. Allen, for visual separation, once approved, who's responsible for maintaining that visual separation?
Are you referring to pilot or tower applied?
Pilot.
Pilot applied, it is incumbent on the pilot.
Thank you. That's all I have. Thank you, ma'am.
Thank you very much. ALPA.
Thank you, Chair. First question is from Command Chief Officer Van Vechten. How often are routes 1 and 4 used for night vision goggle check rides?
I would say more often than not. It was one of our primary routes, and in my opinion, I saw it as one of the safest routes because 96% of traffic utilizes runway 119, so 96% of the time you're parallel with traffic and it's not a factor.
So that would be the why then for this case is why it was used?
Correct, yes, sir.
Just to follow up, so you say that it's 96% is mainly going to runway 1, but even so, this is a complex airspace. Do you think it is an airspace where potentially we could limit NVG check rides and do those someplace else, where it would be potentially more beneficial to get away from the congestion?
Because of the unit's mission, I do not think it would be more beneficial to move the annual check ride from there. You must be familiar with your airspace that you're expected to operate in when conditions are not ideal. So on a check ride is when we would train those pilots to fly there.
Is it possible to do something more in lines of a familiar, like a FAM flight versus an actual check ride in that space? Because check rides, at least in my experience and understanding of it, it's a bit more of a high pressure situation for a pilot being evaluated.
Sure. Local area orientations are always conducted prior to the check ride. You would never take your initial flight in the DC Healer routes as your check ride. The DC Healer routes, Route 1, 3, 5, and 1, 3, 4, 5, and 7 are part of the local area orientation checklist. So you must have seen those routes prior to taking a check ride.
Okay. Was there any Army guidance to maintain a minimum lateral distance from the shoreline?
No.
Okay, so there was no internal of, hey, we fly right over the shore or hug the shore, maybe not written anywhere, but sort of procedural or technique only?
Yes, sir. We'll call that tribal knowledge is hug the shoreline while traveling south or northbound, unless you have opposing traffic and you have to utilize rules of the road.
Of course. Is there a safety or risk assessment that is accomplished prior to each helicopter training or operational flight?
Yes.
Are air carriers and proximity to runway environments included in that assessment?
No, they're not currently on our assessment.
Okay. This is going to be, we'll pivot to Colonel DeForest. From an Army organizational perspective, was a risk analysis ever done on operations in DC airspace?
It would have been included in the previously referenced risk assessment. So we have, part of the risk approval process, you're going to receive your mission, you'll do detailed planning, rehearsals, map rehearsals, TTXs, talk to your briefing officers, things of that nature. So yes, we do conduct rigorous risk assessments prior to each flight.
So it is specific then to the individual pilot risk assessment that pilot does and then brings that to specific other personnel within your structure?
Absolutely, and there's a lot of different considerations. You're going to look at the crew, the composition of the crew, the environment, the tasks to be trained. So all those items that introduce, or those aviation risk factors are discussed.
And And once again, just to clarify, was runway 33 approach traffic included specifically in this risk analysis?
Not on the 29 January risk analysis, or RCOP.
Was it in general, and is it now, like in general, was it ever included?
It is now, after the accident.
And were also the limitations of seeing traffic with cultural lighting under NVGs in that specific area also considered?
On the day of the accident, or the night of the accident, yes, that's
Or
included.
any previous with cultural lighting in that specific area? Is it just a general practice to consider cultural lighting in that area?
Absolutely. Time of day, cultural lighting, illumination, weather, things of that nature. So yes.
Thank you, sir. Back to you, Mr. Van Vechten. Just to clarify once again, I'm sorry we've asked you this point so many times, but you were under the impression that procedurally helos were required to hold if aircraft were landing on runway 33. Is that correct?
Yes, sir, that's correct.
So if you were cleared to transit onto Route 4 and then were told there was traffic circling to land at runway 33, would you have assumed there was procedurally something incorrect and that you were potentially in conflicting airspace?
Hypothetically, if that had happened, I would either query Tower, or I would probably at Haynes Point have made a left turn to go northbound on Route 1 towards Greenbelt.
Or possibly just hold at Haynes Point as well?
Correct.
Okay. Another one for you, sir. What is your normal crew composition for night training missions?
What do you mean night composition, sir?
Specifically, is there a minimum requirement for your crew to crew the aircraft? I'm assuming left seat, right seat, and then one crew chief in the back?
Yes, sir, that's the minimum. Pilot, co-pilot, and crew chief.
Was there ever consideration given to doing 2 crew chiefs in the back to increase see and avoid potential or just visibility outside the aircraft?
There are certain mission sets that require a second additional crew chief. External load operations, medevac operations will have a second one, but an additional set of eyes doesn't necessarily increase safety. In this case, the crew chief was sitting on the left side, so in the best position to see the aircraft. So an additional crew chief would not have increased the safety.
Thank you, sir. That's my time.
Thank you very much. Before the second round by the parties, we're going to go ahead and take I'd prefer a 10-minute break so we can get back into it. I'm going to ask if there is a line that people let the board members go first in the restroom so we can come back and convene everyone. Sorry to pull rank there. Thank you so much. All right, if everyone could take their seats. All right, we're going to start with the second round, starting with the U.S. Army.
Thank you, Madam Chair. Just want to come back to 2 points that were made in the previous session. So I guess it could be addressed either to both Mr. Dressler or Mr. Allen. Both of you discussed reputational or issues that you identify with either PAT or what you call muscle, which I guess is Helo Squadron 1 in the Air Force. Did any of those impressions that you had or issues you have result in mandatory observance reports or pilot deviations? I just want to understand if there was any formal documentation of those.
Internal to the air traffic control tower, there were mandatory occurrence reports that had those, as well as it was documented in one of our helicopter workgroup meetings where we played a radar playback of what had occurred in one instance.
I just ask if able, could we get those submitted into evidence just so we can review those? And I'll ask the same question over to Mr. Dressler.
Sure. So yes, in 2017, the pilot filed an aviation safety report particular to the near miss with 2 Black Hawks around Haines Point. And then subsequent to that, one of our members who has 38 years of flying in this airspace and 7,000 hours had specific conversations with FAA and the former battalion commander in about 2021 about incidents involving 12th Aviation.
Okay, I just again ask if we could get those, if they're not part of the record, if those could be added to the record.
I'll confer with Dan as we continue to go through questions and circle back.
Okay, thank you. Second question, just want to go back to in the previous panel, in the morning session, we talked about, this has to do with the design of route structures and procedures. We talked about the inherent deviations associated with instrumentation in aircraft in general. And the question I had asked earlier was, how are those taken into account when developing route structures? And if you know specifically for places like DCA where it's crowded. That'd be for someone in the FAA.
I think it's part of that local interaction with the users and operators in understanding unique needs and our concerns, as well as the process for safety risk management and review of whatever changes are made or implemented. That's certainly something that we would be interested in.
But specifically, how is that taken into account in the development of the route structures? I mean, it's obviously very paramount here, so it's a high traffic area, it's very limited in space, but in general, does the FAA consider all those deviations when they're developing procedures?
So I think what we do is we consider the potential conflictions when we make those recommended altitudes. But again, if that's the reliance for separation, then our training through our controllers is to make sure you assign it. There are some facilities where there are helicopter routes at 2,000 feet and they have departures climbing to 1,500. They ensure that they instruct those helicopters on that particular route to maintain 2,000 feet because they're dependent on that as their form of separation.
Okay. I think I got that you take that into account. That is a standard practice that the FAA uses that there are deviations in instrumentation that allow us that are in use when you develop charts.
Correct.
Thanks. The Army has no further questions.
And Dan and I Dr. Bauer and I conferred, and we'll include that. Thank you very much. And next is Sikorsky.
No questions, ma'am.
All right, moving on to PSA.
Thank you, ma'am. Ms. Murphy, when the suggestions to add hotspots on the charts was made, you said the proposal was not adopted because hotspots are related to ground operation. You later said anyone can propose changes to the chart. Is the case that the facility suggested the change, but the change was rejected because concerns about terminology?
No, the change was rejected because it's not within the standard or specification to show on a VFR aeronautical chart. In order to do so, that governing body would need to adjust. And to do that, we would have to implement a requirements document.
For a hotspot that's,
Or, I think as Ms. Lewis mentioned, I mean, it could be called anything. Hotspot, whoever the proponent is would suggest the name.
is there any action on that now? Is there any talk of that now to do that since this event?
No, there's not.
So we have not specifically added the term hotspot on there, but Mr. Stowe, I believe, can provide some information on what we have placed on the charts in those particular areas around caution areas.
So what we did since January 29th, was added a graphic to the back of the chart supplement. We added several caution notes and labeled what would have been the hotspot areas as high traffic density areas. And so again, this is a supplement. It's a supplement to the VFR aeronautical chart. Moving forward, I imagine there will be other caution notes and pilot callouts for the actual aeronautical chart.
And post-accident, we've put procedures in place where the aircraft and fixed-wing aircraft and helicopters are not allowed to interact in that area. And so if we do have a priority medevac helicopter that needs to transit that area, we don't allow arrivals and departures, particularly to runway 15 or 33 at all. They're not allowed to interact.
Is that on IFR charts too, the cautions? And you mentioned on VFR charts.
Caution notes are shown on both IFR and VFR charts. However, the ones that are associated with helicopter activity are solely shown on the VFR charts and, as I mentioned earlier, within the chart supplement.
So not on IFR charts then?
Correct.
Mr. Binkin, is there any written policy about procedures not to cross the approach paths of landing aircraft?
No, sir.
Nothing there from Route 4 or anything like that
No,
whatsoever?
sir, not that I'm aware of, no.
Thanks, sir. And then back to Ms. Murphy. You say the routes are suggestions, but if ATC clears a helicopter to follow a route, isn't ATC actually instructing the helicopter to comply with the chartered route, which makes the following the route mandatory? I guess this can be for anyone up there in the FAA, too.
I think in the cited example where there's an actual ATC clearance or operating instruction, so that would fall under compliance with 91-123 and Title 14 CFR. So that's why I think earlier I suggested that it may be very situationally dependent on the phraseology and specific instruction or what may otherwise be contained in an LOA.
So if you're cleared down Route 4, cleared, that's not a suggestion, that's a required route.
Yes, in the case of VFR operations down a VFR helicopter route, it would still be or should be expected that they are going to deviate as necessary to maintain clear of clouds, maintain obstruction clearance, and minimum safe altitude requirements.
Okay, and that's without any request to ATC? They can deviate as necessary?
If they're assigned a specific altitude and would be unable to comply, the expectation would be that they notify air traffic.
Well, they're assigned a specific route. So I guess we get back to the same thing. You've been cleared for a specific route. How do you know if you're on that route if there's no lateral boundaries?
Correct. So, and again, this goes back, I think, to the general intent of a chartered helicopter route. I guess to go in a little bit more description, there's only 8 chartered or published helicopter route charts. There's plenty of facilities that don't have helicopter route charts, and a helicopter may check in requesting ingress or egress or transition along any route of flight, and it would require air traffic to provide an instruction if it's necessary for separation of aircraft. So if that's that's part of that local interaction and engagement with industry would be to understand where the standard traffic flows are. So these could be charted so that a helicopter checking in on a route, there's an expectation for air traffic as a general expectation as to where they're going to operate that air traffic could use for general flow. And if it's needed or necessary for specific separation criteria, air traffic would still be responsible for applying either lateral radar, tower visual, or visual separation.
I think you said it. They're expected to be on the route.
Generally, yes.
Thank you.
I think we're going to have to go to the next. Okay, great. Thank you very much. And it's NADCA next.
Thank you. For Mr. Stowe, going back to the 75-foot discussion regarding the top of Route 4 and the bottom of the glide path, the runway 33, that is not is it correct that that is not intended to be a form of separation?
Correct. There is not a required vertical or lateral separation between those routes, no.
Okay, so then is it correct to say that some form of separation must be provided by either air traffic or the pilot?
Correct.
Thank you. No further.
Thank you very much. Moving to FAA.
No further questions, ma'am.
Alba.
Thank you, Chairwoman. First question for Mr. Allen. How often does the conflict alert go off in the tower at DCA?
Within the parameters that it's set for, I can't compare it to another
a standard
facility.
shift, say?
Whenever the parameters dictated to alert.
Would you say it's often, though?
I'm sure at times it's more frequent than other. If there's more volume and more complexity in intersection routes, yes, it's going to go off more. If there isn't any volume or complexity, it's not going to go off as much.
In DCA's complex environment, then it would go off often?
Potentially.
Okay. Do you think that that's possibly enough to desensitize the controllers?
I can't speak to human performance.
Okay. Another one for you, sir. Would ADSB out have resulted in an earlier conflict alert?
Not that I'm aware of.
Does it give adequate time to at least resolve the conflict? Specifically the conflict alert?
Yes, typically when it goes off, yes.
Does ATC have the tools to protect aircraft in these low altitude environments, specifically where some of their equipment has also become inhibited?
Yes.
Okay. This is more of a general question for the FAA, so please, if anyone else has input. Has the FAA mandated the publication of helicopter routes on charts used by air carriers in the vicinity of Class Bravo airspace?
Not that I'm aware of. If you're specifically talking about IFR charts,
yes.
No, we have not mandated that.
In lieu of this, can we just simply ask why not?
In lieu of this, what we are doing is looking at modernizing our airspace along with our equipment. And so we're looking at modernizing our procedures, our rules, our requirements. And what we've done is put out training and guidance to our controllers to provide positive control. And so don't rely on the helicopter routes. If you need to ensure separation, provide an altitude or a heading to make sure that the aircraft stay apart. Particularly DCA airspace, we don't allow them to mix at all. And if there's a helicopter that needs to transmit or transit the airspace because of a priority route, we stop arrivals and departures.
As Dr. Kastner did say earlier, simply knowing where a threat is the first step to being able to avoid it. So would that not make sense to allow at least an awareness between both parties?
We're certainly willing to consider anything that will enhance safety, and so we'll definitely take that idea back as something to consider.
Awesome. How is local airspace safety information shared with the industry to ensure it is included in airlines' special airports training? Specifically, airlines have their training specific to each airport. How are you guys getting that information to them to make sure that it's included? So that way, once again, there is awareness.
So we have a robust voluntary safety reporting system. We share information back and forth with some of our airliners that that have also voluntary safety reporting systems and have agreements to share information, de-identified, of course. We also participate in the U.S. Aviation Safety Team, the Commercial Aviation Safety Team, and SIS information sharing portals with industry. In addition, our COO holds monthly COO meetings where they discuss safety issues, things that concern them. I know they've all have his phone number, and we communicate regularly.
Thank you.
Can I remind folks that we have a list of some of these issues for tomorrow, which is why we're not, many of the other ones, other panelists are not asking these questions. We can always recall a witness if needed, if you would like that individual's response.
Thank you, ma'am. One more question for Dr. Kastner. From the human performance perspective, should visual separation be used in congested Class Bravo airspace at low altitude, high workload operations, and also at night? Could you hit your mic, sir?
It sounds very challenging to do reliably. And when you get a traffic volume up that high, it's a lot of small numbers to multiply together and achieve a high level of safety.
Thank you, sir. That concludes Alva's questioning.
Thank you very much. We're now going to turn to the Board of Inquiry, starting with Member Graham.
Thank you, Chair. I think it's important with everybody watching and many in the audience to really understand what equipment is required to operate in a Class Bravo airspace. So this is these questions are for the FAA. What is required for an aircraft to operate in Class Bravo terminal airspace?
So I would refer specifically to Title 14 CFR 91-131. There's some equipment listed, such as an operable, I think, VOR, attack and receiver, and or a appropriate RNAV system, as well as a requirement to comply with 91-215 transponder and altitude reporting equipment, as well as ADSB out requirements contained in 91-225.
You forgot one other. Two-way radio.
Yes.
Capable of communicating with ATC on the appropriate frequency, right?
Yes, 100%.
So you did say ADSB out. That came out in Bravo airspace. Was it 2020 when it was required? I can't remember the year.
I'd have to refer to the original final rule.
Yeah. PAT 25 obviously did not have ADSB out. What allowed them to operate in this airspace?
So I would refer to the 2019 publication of the interim final rule amending 91-225 to allow for certain exceptions of operations within airspace where it would otherwise be required.
So they had a waiver to operate without, so to speak.
So to speak, there's some technical differences between what would constitute an exemption, waiver, or other type of deviation that could be provided.
Okay. So they did meet the requirement then?
Correct.
Okay. So obviously, VFR, visual flight rule aircraft, can operate inside Class Bravo airspace. What is required for them to operate in that Class Bravo airspace? And I don't know, maybe Mr. Allen knows that too.
I can jump in as well.
Okay.
It would be the same as for any other aircraft, minus the pilot training requirements in 91-131 that might not be appropriate for that
for Army pilot,
that type of flight. But generally, it would be a Class Bravo clearance.
A clearance, right?
Correct.
Obviously, a clearance. Okay.
And yep, two-way radio communication.
And they obviously had clearance listening to our presentation at the beginning. They had received clearance in. So we talked about the ADSB was required, but they didn't. They had a exemption or whatever you want to call it to do that. Mr. Allen, was PAT 25 being tracked by the radar at DCA on the night of the accident?
Yes.
Okay. Is sequencing and separation for visual flight rules aircraft inside the Class B airspace dependent upon radar?
You can utilize radar or scanning out the windows.
Okay. Thank you for that. I think I'll move on to the Army, either Colonel DeForest or Mr. Van Vechten. How familiar are Army flight crews with DCA approach and departure procedures for commercial aircraft at any of the DCA 6 runways?
I'll speak to that. We are aware of the departure paths, but we're not aware of the departure procedures for the fixed-wing aircraft.
And how is this information covered in the special flight rules area and flight restricted zone training for new Army pilots and the DCA airspace?
Are you talking about the FAA CIFRA training that must be completed prior to flight into the CIFRA?
Yes.
It's covered in the CIFRA training.
And how often are Army pilots refreshed with that training?
There's no refresher requirement required. It's just the initial qualification, obtaining your certificate, and then you're qualified.
Okay. Does this training include reviews of the Jeppesen Airport qualification charts for DCA, including the runway by runway charts?
No, it does not.
It does not. Okay. So are all the Army pilots operating out of Davison Army Airfield, they should be familiar with the landing pattern at runway 33?
I mean, we're aware of the 1533 runway. I don't know what their traffic pattern is when they're cleared for a visual, but I would assume an ILS is a straight in, but we're not familiar with the traffic pattern for 1533.
Okay. You did say that there was no refresher training, yet I see that the pilot of PAT 25 received that training in August of 2021 and again in August of 2022. And then the instructor pilot only received it in 2019. Can you explain that?
Yes. So the instructor pilot in command received the training when they arrived to Davison Army Airfield, to Fort Belvoir, and they signed in. They did the initial training. The pilot did the training when they arrived in 2021, I believe. And then the only time the training would be required again is if there was a violation or if the person just wanted to refresh on their own, but there was no requirement to redo the training.
Okay. Do the crew chiefs receive any training in that since they're visually looking out, helping the crew?
No, not on the FAA DC CIFRA Special Flight Rules Area training. The training they receive is just in the aircraft or in their local air orientation, and the CIFRA training is more geared towards how to operate as a pilot and some of the stuff that's not applicable to military pilots.
Great, thank you. I see I'm past my time.
Thank you. Member Inman.
Thank you. Mr. Fuller, I was intrigued by your answer earlier about the collaboration on safety information and sharing with stakeholders and industry partners. Can you kind of repeat or rephrase that for me again?
Yes, sir, happy to. The FAA participates in the U.S. Aviation Safety Team, Commercial Aviation Safety Team. I believe we have a representative of the GAJSC, which is the General Aviation Joint Safety Council. We have voluntary safety reporting programs, and we have confidential information sharing programs with some of our airline partners.
Okay. I guess my question is a little bit more framed. Why did it take 5 months for us to get the PDARS data, and we still don't have the actual underlying data regarding the PDARS evaluation on this airspace?
I believe much of the confusion involved the request that was specifically made. I believe you asked for a PDARS report. We didn't particularly pull a PDARS report. We used ARIA data, MOR data, some of the voluntary safety reporting data to create a helicopter assessment. And there was no discussion about requesting that specific helicopter assessment. All it kept asking for in the emails that I received was for a PDARS report, and there was confusion about what particular report you were looking for.
Okay, I'll go back to this collaborative environment, I guess. At any point, did anyone at the ATO organization or ATC organization say that we were going beyond our scope and what the NTSB was looking at in regard to helicopter operations?
I'm not aware of anybody saying you went beyond your scope in regard to helicopter operations. No, sir.
Let me go a little bit further. In regard to, we were discussing ADSB data. Are you aware that the NTSB needs to spend $50,000 a year just to evaluate ADSB out data because the FAA does not consider the NTSB a trusted government partner?
I'm not aware of the NTSB.
Are you aware now?
I am aware now that you told me, yes, sir.
I think it's distributed throughout some of the reports, so I hope you would check into it a little bit. Can you define and tell us what a ADSB is?
ADSB is an air traffic safety action report. It's a voluntary safety report that a controller or supervisor, quite honestly, anyone that observes an operation in the air traffic field can report voluntarily.
Okay, and what happens to that report?
It goes into a system. We have analysts that de-identify it. We have an event review committee that looks at those reports. They bucketize them into different categories. If they require corrective action or information requests, the ERC can submit those and demand, and they go to the various lines of business within the air traffic organization for adjudication or risk acceptance.
What about an ASRS? What is that?
It's a NASA aviation safety reporting system. Those also, controllers can submit those as well, and they can also submit an ADSB report and click a box if they would like to share it with the NASA aviation safety reporting system as well.
Okay. Are either one of those report databases available to the public or to, say, members of the aviation community that are not employed by either one of those organizations?
ADSB data is not readily available to the public. NASA ASRS data, I am not certain if it's de-identified and available to the public. To be quite honest, I'm not sure about.
What do you define as readily available?
I know NASA shares data with industry, but I don't know.
No, I'm talking about the ADSB report, sorry. You said it's not readily available to the public.
Yes, it's not available to the public, but we do share with other groups like ASIAS, things of that nature. Is de-identified information.
Have you ever shared any ADSB reports with the NTSB?
Are you talking about me personally or?
Your organization, you're the deputy director.
I'm the deputy COO, sir. And
Okay.
yes, we share information with ASIAS. And
I said with the NTSB, sir.
I believe the NTSB has access to ASIAS data.
Do we have access to the ADSB reports?
Not the reports that have not been de-identified.
Whenever they're de-identified, do we get access to those?
I believe you get aggregate safety data.
Aggregate, right? I'm curious because in each one of the interviews with every one of the controllers, they mentioned that they filed an ADSB report before they even spoke to us. Are you going to aggregate that data before we see it? Or what they filed?
A controller's ADSB report, I would not even see.
I'm out of time.
Mike went over 2 minutes, so go ahead.
You think you're saying I'm on a roll there, Chair? I understand.
I just want my 7 minutes.
I understand. Let me move into just a little bit of a different line, and I'm going to actually go to Colonel DeForest. Can you break down your mission critical versus training mission versus moving people from one position to another as far as operations prior to this accident? I'm just trying to get an idea of how much volume you do in each one of those different buckets.
Absolutely, board member. So for, I'll break it down. From all the flights that we do, 60% are during the day, 40% are at night. Of those, 43% are what we called mission practice. So anything involving a mission-related task.
Is that out of the full 100%?
Yes, sir.
Okay.
29% are proficiency requirements. So these are Army aviation regulatory.
What percentage, I'm sorry?
29%.
29%? Okay.
So those are your instrument check rides, your A parts, things of that nature. 10% are mission validation, so that includes full dress rehearsals, envision a multi-ship into one of the areas that we operate into. 9% are going to be your senior leader movement missions. And then the other 9% of our maintenance test flights of a 6,000-hour annual flying hour program for 12th Aviation Battalion.
And how many flights a year would that be? roughly? Or if you don't have the numbers, somewhere in the general area?
Prior to 29 January, we have a monthly average of 226 launches per month.
So close to over 2,500 per year?
And it's dependent on time of year. So, historically in the winter, weather conditions, drive down the number of flights, and then in the spring, summertime, you'll see an increase in those mission rehearsals.
Okay, I'm to my 7 minutes now.
Great, thank you very much. Mr. Fuller, you're Deputy COO of ATO, the Air Traffic Office at FAA. We have FAA's commitment that all FAA employees participating in NTSB's investigation of this midair collision, and that all FAA employees that are participating in this hearing will not be retaliated against?
Yeah, the FAA has a zero tolerance policy for whistleblower protection.
Great, thank you very much. Mr. Allen, Mr. Soper had asked earlier about the discussion to move or eliminate helicopter Route 4. And Dr. Wilson had asked you when that was, and you said 2021, 2022 timeframe. Is that correct?
Correct. I'm not 100% sure of the time
around that
frame,
time,
but around that area.
And then Mr. Soper had asked you, Mr. Fuller, were you ever made aware of those proposals, or were you advised by management about those proposals? And you said you were not aware of any. Is that correct?
That's correct, ma'am.
Where were you in 2021 and 2022?
In 2021, I was a deputy director of the Central Service Area. And in June of 2022, I transitioned here to Washington, D.C. as a deputy vice president of safety technical training.
And you're the deputy director for Central Service Area, which is, and I'm just looking at your bio here, where is that located? Where were you located?
I was located in Fort Worth, Texas. There are 128 facilities that fall under my purview. They stretch from New York down to Arizona and through generally the Midwest and Southwest.
Would you be made aware of such a proposal?
No, I would not.
Okay. So I just want to remind everyone that you were sworn to provide truthful testimony, and that while that is the truth, I give you that, it's half-truth. You did not provide that you weren't there when asked about whether you had received those proposals, because you would not normally receive those proposals at that time in 2021 and 2022 when they were considered.
Well, Madam Chairwoman, all I can do is answer the question that I was
Or
asked.
you could add that you wouldn't have been in that position at that time to receive that information. So, Mr. Allen, well, actually, Ms. Murphy or Mr. Stowe, were you made aware?
I would not have been made aware at that time.
Okay, so Mr. Allen, I am guessing by your responses to Mr. Hall with PSA that it never made it to the SRMP. Do you know why?
From my recollection, the removal or the potential of moving Route 4 never even made it into the full proposal document or PowerPoint further discussions we had with the users, because it never left the verbal conversations.
Okay, but verbal conversations were done with who?
It was done with the user groups and the management within the facility.
Okay, so management within the facility, did it ever, how high?
It would have been the operations manager and air traffic manager at that time.
Okay, an air traffic manager is responsible for reviewing the routes according to Ms. Murphy. Is that correct?
Correct.
Okay, so would you normally expect, and just to go back to Mr. Fuller, you had talked about when an SRMP is pulled together. What did you say on what were the standards for, you said change, right?
Normally, it's typically evaluate change to something within the NAS, either a piece of equipment or a procedure that can be done for existing hazards, but typically the normal fashions when there's something changed.
Okay, I'm just going to read FAA's own safety risk management policy, which says that SRM is, and I apologize because I am reading this and apparently need glasses to do it. If you need, if hazards are identified, it's not just if a change, but if any hazards are identified to control a safety risk. Is that a safety risk if the tower says, hey, with the DC helicopter working group that we have some safety concerns here with helicopter Route 4 and think it should be eliminated or moved? Do you think it should have gone to an SRM? That's safety risk management panel for those who in the audience to be evaluated.
I think they should have put it through your SMS principles, and if it needed to be paneled, then yes, it should have gone to an SRM panel. But having not been a part of that work group and party to the discussion, I don't know where they left it.
Understand. Yeah, thank you very much. Okay. I'm going to switch. Actually, I'm going to stay here for a second. Mr. Allen, how many air traffic managers have been moved through DCA Tower in the past 2 years?
Air traffic managers in the past 2 years, there have been 3.
3. How about 5 years?
In the past 5 years.
To the best of your knowledge.
There would have been 5.
5. And how long have you worked, how long did you work in the tower?
I have been at DCA since February of 2013.
So 2013. So in your time since February 2013, how many air traffic managers did you see?
Approximately 10.
10 air traffic. Yep, that's fine. I mean, if you don't have to be totally exact. If it's 9, it's 9.
Yeah.
So 10 since 2013. Ms. Murphy, you said the air traffic managers, and I know I'm out of time. If you wouldn't mind me finishing. Air traffic managers are responsible for considering any sort of changes to routes, any sort of changes, amendments, evaluation of routes annually. You've had 10 air traffic managers in a pretty small amount of time. You've had 5 in the past 5 years, 3 in the past 2 years. How are they supposed to know to do that if you keep switching air traffic managers?
My only response to that is that it is defined in the FAA Order 7210.3.
Oh, hold on. Oh, here it is. Is this where it would be defined?
I believe so.
Uh-huh. So somewhere in these massive amounts of pages, it would be defined that that's where they know that they're supposed to do that after they come in and out. How long was the last one here, Mr. Allen?
The last air traffic manager was there maybe 10 months.
10 months. Okay, thank you. Member Graham.
Thank you, Chair. In 2021, the Government Accountability Office, the GAO, issued a report on aircraft noise in the DC area The GAO report details, among other things, how FAA has established maximum altitude limits for helicopters to ensure the safety of helicopters and commercial passenger aircraft. It also found that military helicopters make up the plurality of helicopter traffic in the DCA airspace. For the FAA, the report also notes that FAA officials said existing minimum and maximum altitudes for helicopters were set to maintain safe separation for helicopters between commercial passenger airplanes and ground structures. And any change to minimum or maximum helicopter altitudes would require higher altitudes and steeper approaches and descents of commercial passenger aircraft coming into DCA, reducing safety for all aircraft operating in the airspace. For the FAA, would you continue to agree with this statement that any changes to the min or maximum helicopter altitudes reduces safety for all aircraft operating in the DCA airspace? Mr. Fuller, or?
If you're specifically discussing the helicopter chart altitudes, then no, I don't think I agree that it would decrease safety for all aircraft going in. Again, particularly in DCA, the expectation and the rule and the policy now is they will maintain Class B IFR, or correction, IFR versus VFR separation. And so it'd be 1.5 miles or 500 feet. I don't think if you change the altitude on the helicopter charts, that inherently reduces safety for commercial aircraft in the DCA.
But wouldn't it be less because you got an IFR to VFR aircraft? Because they're on the VFR. Isn't the helicopter route a VFR route?
The helicopter is a VFR route, but you could still, in the expectations, you could still hold that helicopter until that IFR aircraft completes its approach, or you could vector that aircraft to go behind it.
Okay. For the Army was also with the work with the GAO on this report and noted that changing helicopter altitudes could affect mission safety, particularly in challenging situations like poor weather conditions. Does the Army still believe that to be the case, that changes to minimum or maximum helicopter altitudes reduces mission safety?
Now, that'd be a consideration for each and every mission. So the Army, specifically Aviation Brigade, 12th Aviation Battalion, is committed to supporting the fly-friendly program. So each mission, you'd have to make those considerations. Specifically, if it was a low ceiling, reduced visibility, the crews would talk about that in their during their risk discussion, not only with the commanders but also their mission briefers.
Given these safety realities, the GAO did not recommend any changes to the helicopter routes or altitudes in the region, instead recommending better information sharing with operators in the region. However, the subsequent helicopter symposium hosted by the FAA and sponsored by the DCA Helicopter Working Group expanded the scope of the proposed changes and recommendations from what GAO had presented to include significant changes to the helicopter route chart. So this is for the FAA. Why was the decision made to expand the scope of the symposium and subsequent changes beyond information sharing?
So I can speak to the changes that were made. The increase in altitude, we did those in locations that were further away from fixed wing traffic. They were not along the final of either runway or the departure corridor of either runway. In fact, the departure corridor for runway 1 or the arrival corridor for runway 19, we reduced the zone footprint and pulled the boundary of the zone further away from the final to increase safety.
Okay. Despite the FAA's own assertion in the 2021 GAO report, which we reiterated here, changes to minimum and maximum helicopter altitudes would reduce safety for all operating in the DCA airspace. In 2023, the FAA finalized revisions to the Baltimore-Washington helicopter route chart, including raising maximum altitudes on routes 2, 3, 5, 6, and 7, and in zones 2, 3, and 5. What changed from the FAA's own analysis presented in the GAO report in 2021 to these finalized altitude revisions in 2023 that showed FAA changes to maximum helicopter altitude would not reduce safety for all aircraft in the area.
Again, speaking as someone that was not a part of the helicopter work group, I can tell you that just from my limited knowledge, Zone 5 runs parallel. It's away from DCA Airport. Zone 2, I believe, is also well away from the final approach course for DCA Airport. Zone 6, we've eliminated that section in the vicinity of DCA Airport. And I think he said Zone 7, if I'm correct?
Correct.
Again, Zone 7, there's no particular confliction point immediately within the vicinity of DCA Airport for arrivals and departures.
Okay, I noticed that the FAA final safety risk management document revising the helicopter routes, the FAA noted that the safety benefits of increasing altitude separation between helicopters and DCA fixed-wing aircraft as part of the justification for establishing the new chain bridge transition. Was increasing altitude separation between helicopters and fixed-wing aircraft discussed for any other routes or zones or locations in the DCA Class B airspace?
So the helicopter revisions we still have are ongoing. We have not completed that work. We have additional charting changes that are going to be posted August 12th to routes within the DCA and the National Capital Region. This is not a one-time fix, and the FAA is committed to maintaining our standards and modifying helicopter routes around the country. So I don't have a deadline of when that work will be completed, but there are continuous changes.
Thank you. My time's up.
Thank you. I'm going to turn to Member Inman, but I know he asked on the last. Do you intend to ask, or you want me to clarify it now?
I think you should clarify it. It'd be
Okay,
helpful.
just to clarify on ASIAS, Mr. Fuller, you mentioned that we have access to ASIAS data. We only have access to ASIAS data if we ask you for it. Member Inman.
I'll go back on that question, I guess. Is having to ask for it, having it available, or does it mean coming to you and asking for it? Because I would go back to, we asked for the overtime records of the DCA Tower Group. They were run on January 30th, and they were not given to us until Friday.
So
Friday of last week.
I think part of the fog of war, and particularly in the DCA accident, is there were a lot of requests being made outside of our normal processes and procedures. In the ATO, we alone processed over 300 data requests for the NTSB. For the particular overtime request, I don't recall seeing that on the list. Even on the emails I received from Madam Chairman Hamandi last week, I don't recall overtime being one of the data requests that was still outstanding.
Sir, were you prepped on the materials that were in the docket for today's hearing?
Yes, I was.
It's in the group chairman report from Air Traffic Control.
As far as the
Not having the overtime request, it's in the group chairman report, which was agreed to and coordinated by all the parties.
Again, the data request in the group chairman report is not saying that it came through our normal channels. I don't know who made that request and to who that request was made. It did not come through our normal EIM that exchanges data information back and forth with the NTSB.
Just to clarify it, because I know we have some limited time, but Chair, is it okay if I ask somebody, Mr. Soper? Could you
Yes.
clarify that for us?
We're trying to catch up right now where we made the request.
Sorry,
We know
we're-
we made the request verbally with the EIM for sure. We
I think-
absolutely did that.
Yeah, that's fine. I think what Member Inman is asking is, did you follow the channels prescribed to you to ask for information?
Yes, because when we're on site or conducting an investigation, we can put it into KSN or we can go directly to the EIM and make the request, and then we back that up in KSN afterwards.
Correct.
In most cases, yes.
And then when we didn't get the information, I had to come in with an email 3 different times. Yet you were requesting that information since April.
Around there. We're trying to find the exact date where we requested the overtime.
Yeah, I agree. Mr. Fuller, let me ask you this. Do you think the FAA has been totally forthcoming in providing all of the information that we have asked in this investigation to date?
The FAA has been totally transparent in
No,
this investigation.
forthcoming.
Absolutely. We've been totally transparent and forthcoming with everything we've had in this investigation.
Did you read the group chairman's reports?
Yes, I did read the group chairman's report.
Did you indicate where there were multiple data points that we had not received the information, and these were written over a month and a half ago?
The group's chairman report does not indicate who made the request or to whom they made the request, and so it's difficult for us to follow up. All the group chairman's report said is an overtime request was made.
No, I'm talking about data in general. There were other group chairman report data requests that still had not been received.
And again, I don't think that that was totally accurate in what was in the group chairman's report.
It was agreed to by the FAA as a party for the group chairman report.
Again, some of that information in that group chairman's report was misrepresented a little bit as far as who the request was made to and to when.
What was misrepresented?
So one of the things was about a PDAR study on TCAS data that we only provided versions 1 and 7 and not the versions in between. And the versions in between were just format changes. And so when it was saying that the FAA was not being forthcoming with data, we gave you the final version with all the PDAR's information rather than go back and give you all the data with the typos and misspellings. It made it appear as if the FAA was hiding some information, and in fact, we just gave you the latest and greatest.
Can I chime in just for a second? I'm sorry, can you yield for 1 minute? Is the latest and the greatest taking 6 months to give us who was finally on duty on January 29th of 2025? Because over 6 months, the numbers kept changing on who was on duty January 29th, 2025. 6 months. And this is outlined actually in the group chair's report where you actually, and we have quotes on the group chair's report. You sign off on the group chair's report. I'd ask Brian to chime in on.
Yes, so we did. We received multiple revisions on the staffing numbers on the day of the event.
Oh, I mean on member admins. We already know that.
And member admins, I think I got mixed up there. There was a lot that came out, and I was looking up the one thing. For instance, the PDARS debacle that we ran into with requesting the PDARS data. So I'll step through exactly how this was done. We were making a request from PDARS with ATAC. We met with ATAC and with the FAA, AJI, Karen Seals, who I believe was the deputy director at the time of AJI, of Safety and Technical Training or whatever. Anyway, she sat in that meeting with us while we requested our PDAR study. A few days after we left that, they had told us it would take them a week or two to do the study and they would get it to us. But the following week, they came to us and said, we are going to be delayed because we have had a priority PDARS request made by AJI for the helicopter routes in more of a NAS-wide format. So we said, great. We would also like a copy of that PDAR study that they were requesting. That went through the chain. We never received it. We asked for it again. That repeat went around and around a few different times. And then finally they got to a point where they produced a PDAR study, which was not a NAS-wide study. It was only on DCA, and it was a updated version of the initial PDAR study that was provided to us on site. Just the most recent response was, we don't know what you're talking about basically with the PDAR, with the third PDAR study. However, we did produce a helicopter assessment. If that's what you're talking about, we'd be happy to provide it. I said, okay, sure, we will take it. It was just mentioned that ASIAS data and ARIA data was used to perform that, and PDARS was not used. However, on the 6th page of the document, it says that AJI used PDARS for routes available in counters to conduct this assessment. That's the PDAR study we were talking about. That's the one that Karen Seals had mentioned. When we were going through the EIM, they were aware of this study because they work closely with Karen Seals, and they're like, yeah, we know the one you're talking about. We'll make sure you get it, until it all came to all those things. So that was the study we were trying to get the data from, and that's so that we could utilize that data for the very same purpose, to understand the risk in more of a NAS-wide and make comparative assessments to other like-type situations or potentially like-type situations. So that's right there in the document they provided us.
If I may respond, I have been on multiple NTSB investigations as an SME and as a party status. Even in this particular investigation, when there was confusion about data, I called Brian on his phone, asked him what he needed. He gave me the answer. I provided the data. On any particular time, I've told the NTSB members if they need anything and they're not getting it from the EIM to reach out directly to me, call me, and I will make sure that they get the information. So the PDAR study, the data, all those different things, I can't say who prioritized our study over the NTSB study. I can't say. It's not a decision I made for ATAC. I will just tell you that we have been fully transparent and we've shared over 10,000 pages of information, over 320 documents, and countless hours of voice and radar, including making our tech center available and the DCA tower for any studies that the NTSB has needed to perform.
Do better.
The fact that I had to get involved on July 2nd, no response to my email. July 14th, barely a response to email. And then the administrator's office and the secretary's office had to get involved so we could get the data. And then what you guys did is dump it on us, thousands of pages, on a Friday, right before this hearing. That's not acceptable. They were asking for it for 6 months. I expect, as part of an investigation, that we're going to get the information. Member Inman, you get another 5 minutes.
Thank you. Let me just change the tone, I guess, a little bit. Dr. Cesar, you mentioned earlier that you would think that maybe initially people that were coming into this airspace the first or second time that a commercial airline pilot was flying it would not know about helicopter routes. But after that, they probably would. Is that a correct assumption of what you said?
Could you repeat? I'm sorry. Could you repeat that? I didn't catch my name at the beginning there.
Okay. Certainly didn't expect your name, did you? It's all right. Earlier in the day, you talked about helicopter routes and that having commercial pilots know about helicopter routes might be a little bit confusing, but you think when they first flew into DCA, they might not know about it, but after a few times they would.
If it's not on the chart or part of the airport qualification training, yeah, I can't imagine why they would unless they're a helicopter pilot themselves. As far as subsequent visits to the area, I'm not sure. Did anything call their attention to them? Maybe it would, maybe it wouldn't.
Is that, I'll go back on that, I apologize. I may try to ask you another question in a later panel on it. Let me go back to something in regard, and I think this is important that we talk about these helicopter routes and national security, and fortunately, unfortunately, in a prior role, I kind of understand what was going to happen. But General DeForest, in the event that you are executing your mission for continuity of government, are you going to be worried about commercial air traffic and running a helicopter route?
In that scenario, we would be preparing for both local, federal, rotary wing, DOD, commercial air traffic in that airspace.
You would expect commercial air traffic?
Yes.
Okay. Mr. Allen, if there was a continuity of government issue, would you expect for commercial airspace to still be operating in the DCA area?
It would be dependent on notification. They may be notified to evacuate, and we may not be aware of it as far as air traffic is concerned. So we would continue to operate as normally.
Okay. And I've looked back through a lot, Mr. Allen. You've been around at DCA Tower for how many years now?
12 years.
12 years. We've asked a lot of questions. I'm just asking you for your opinion. Are there things that we're not asking you that you would like to tell us that are important for the safety of the people that operate in and out of DCA?
I'm going to think that over tonight and provide you an answer tomorrow.
Okay. I think there's maybe some more things. I know that there's other testimony that you gave us in exhibits where you talked about where you were not allowed to make certain changes due to political pressure, other things. So I hope you would feel that you could come to us in this open forum and be able to describe any of those. And so we'll be glad to take you up on that tomorrow, if that's okay. Thank you. Mr. Fuller, you mentioned earlier that the long-term goal was to have widths and GPS points for helicopter routes. Is that correct?
Yes, sir.
What's a long-term goal in your mind?
Well, we're working with industry and any kind
No,
of...
sir. What's a long-term goal in your mind?
If it were solely at my will, it would be done immediately. But these things take time. And if we're working with industry and we want everybody invested and have a say-so, these things take months.
Does industry get to decide what the GPS points and widths would be when regards to aviation safety?
No, but they certainly have some input, and their compliance and things that maybe we hadn't considered, or some equipment capabilities that we're unaware of. We need industry partners with us to share that information.
What group is working on this GPS widths or GPS points and widths? Who is leading that effort?
We have a national helicopter work group.
Okay, who's leading the national helicopter work group?
It's a gentleman by the name of Steve Zucala.
Okay. And how long has he been with the organization?
I don't know certainly offhand, but he's at least 20, 25 years.
Okay, and who does he report to in the hierarchy of the FAA?
Ultimately, he reports to the COO and the administrator.
Okay. I see I'm out of time again.
Mr. Allen, the DCA helicopter group was something that the tower put together, right? Because you wanted to have some communication with the users of the airspace, the helicopter users.
Correct.
Operators.
Correct. There are significant volume of traffic.
How long did you participate in the working group?
I was in the working group approximately 2 to 3 years before I moved into another role.
Okay, so you moved into a different role. That's why you're not on, didn't continue on that.
Correct. I had become operations manager.
Okay, great. Thank you for that clarification. Colonel DeForest, on the map of the helicopter routes prior to the accident, once helicopters got to the Memorial Bridge, they should be at a maximum of 200 feet. Are you aware of an Army policy allowing pilots to go as low as 100 feet?
I'm not aware of a policy, procedure within the battalion allowing to go below 100 feet.
It's procedure. Okay, thank you very much. Is there a policy, Colonel DeForest, outlined anywhere, either Army or maybe it's FAA, prohibiting helicopters from going underneath aircraft, landing at, or departing from DCA on any runway?
To my knowledge, there's no written procedure policy within the battalion prohibiting flight underneath a commercial aircraft at those distances.
How would you be made aware of that occurring?
If that were to occur, we would expect at the unit to receive a report from the United States Army Aeronautical Services Agency, specifically the Department of the Army Regional Representative, or the DAR, informing of a alleged pilot deviation based on a loss of separation. So that would be the way the unit would be notified. But real time, in this area, since we're operating on different frequencies, I guess the for example is if there was a traffic resolution advisory based on a TCAS occurrence, we would not know unless it was reported after the fact through our regional representative with the FAA.
FAA would have to report it to you.
Either through the DAR or through ATC.
What's the DAR?
The Department of the Army Regional Representative.
So is this, maybe not by policy, but procedure, is it prohibited to go underneath aircraft landing or departing from any runway at DCA? Do you discourage it?
back to Mr. Van Vechten's comment, it would be very unusual, and that's not what we're used to. We'd be holding at Haynes Point or the golf balls. So this was a very unusual that this occurred, that we were allowed to go underneath an aircraft.
Mr. Dressler, are you aware of any such instances?
Could you say that one more time, please?
If any helicopters going underneath aircraft landing or departing, do you have a policy?
We do not have a policy. We have, I've heard the phrase used several times here of tribal knowledge. So all of the civilian and law enforcement operators in the area do not do that.
Yeah, Prince George's County Police actually have a policy, a standard operating procedure to prohibit going underneath aircraft landing or departing from DCA. And the reason I raise this is the chief warrant officer at the 12th Battalion in interviews responded to the same question as follows. And the question was, have you ever flown underneath aircraft landing or departing from a runway at DCA? I have, yes. I have flown directly under landing aircraft that were landing 19. In order to do that, ATC apparently points out the traffic landing to them, and they tell ATC they see it and request visual separation. One of your standardization, and that was, are you aware? One of your standardization officers, while he had not done it himself, was aware of pilots descending to go underneath aircraft. A PSA pilot, in an interview commenting on when he got a traffic alert, said, well, in that instance, at least one of them I can remember, it was called out to us. Traffic was called out to us by Tower. Tower said the helicopters had us in sight, and we had them in sight at one point. But then we lost them because they went underneath us. And that was a TA off of that, and you just keep monitoring. They're supposed to have us in sight. You know, I can remember one for sure, that an RA, where we had to level off and actually just punched it out of there and went around. Do you think maybe, because of the interviews and what's being said, that it does happen, you should consider a policy to prohibit going underneath aircraft, civilian aircraft, landing or departing from DCA?
For me, the answer is
no,
yes.
No, it's yes for, thank you, Mr. Dressler. I wasn't even asking you, but did you say yes? I love it. Colonel DeForest.
Chairwoman Hamidi, yes, I would agree with that statement.
Okay, wonderful. Thank you very much. I'm going to now call on Member Graham. Thank you for allowing me a little bit more time.
You bet. Just a couple questions. You talked about procedure along the routes. The minimum altitude for Army helicopter is 100 feet. Is that correct?
That is correct.
That's correct. So for the chief warrant officer, if you've got a pilot where you're supposed to be 200 feet or below, would you expect that pilot to be somewhere between 100 and 200 feet in that section?
Yes, that's correct.
Even though I know we've kind of determined that these routes are advisory in nature only, it seems like?
Yes, we strive to fly the altitude as charted, as close to the height as possible.
Okay. And then you said that you would expect, if there was traffic landing on 3-3, that either if you were coming from the south to be held at the golf balls or coming from the north to be held at Haynes Point. And that would be air traffic control directed?
Yes, that's correct.
Mr. Allen, is that a normal procedure for the tower?
It's not a written procedure, but it is technique that has been taught.
To keep separation of aircraft?
Yeah, to allow them to pass behind.
Okay. So what are the normal, from Davidson Army Airfield, what are the normal departure and arrival routes for helicopters?
Yes, sir. Depending on where my destination is, I will depart to the north, Springfield, Route 5. I can take Route 3, north or south, clockwise, counterclockwise, depending on my destination. If I'm going to the south, I can depart direct to Fort Washington, pick up Route 4 northbound, and then again pick up Route 3, depending on which direction I want it to go.
So why would somebody be using Route 4 on the evening of the 29th to go to Davidson?
Route 4 is typically the most utilized route because, in my opinion, it was the safest because it's parallel with 96% of the traffic. It keeps you as low as possible, so it keeps you below the approach and departure paths of runway 1 and 19. And it's quicker. One of the hotspots that were identified back in the working group was the Pentagon transition because it's such a narrow margin between the Pentagon itself and Arlington National Cemetery. So we would not utilize that much. Route 1 to 4, 4 to 1 was the primarily used route.
Okay. Are there more restrictions on 3 and 5? Like noise restrictions or anything?
Yes. So in June of 2023 is when they raised Route 5 from Springfield to Glebe Road. They raised it from 13 to 1400 because near Route 7 on Four Corners near Falls Church, we had some particular persistent noise complainers, and so they raised the altitude, and we tried to avoid that route as well. So if when you're flying down Route 5 and then you pick up Glebe intersection and you descend down to 400, there's a lot of buildings. You got the Army-Navy golf course. So we try to avoid that, especially at night. It's preferred to take the river southbound for noise abatement purposes because it's clear sailing all the way to Fort Washington, and then you turn right and you're on an extended right base for 3-2 into Davidson Army Airfield.
Great. Thank you for that. And Chair, I don't have any more questions in this panel, but I want to thank all our witnesses.
Thank you, Member Inman.
Thank you, Chair. I'm going to go back a little bit on the noise issue. In regard to on Route 4, is there a problem with hovering due to noise mitigation or noise concerns?
There's not a problem, sir, but that's not something typically you would do, especially under goggles over water. It would be very difficult to determine drift and position. So we would slow our airspeed, but I can't really think of a situation where I would come to a hover for traffic.
But if you're asked to hold, is that a hover?
No, sir. It'd be an orbit. I may slow back to 40 or 50 knots and pick up an orbit. If I was at golf balls proceeding northbound, it's typically a right orbit to stay over.
I apologize, sir.
Sure.
I'm not an aviator.
Okay.
What is golf balls?
Golf balls is the sewage treatment plant just north of Wilson Bridge on the right side of the river or the east side. It's 6 to 8 giant white domes that look like golf balls.
Thank you, sir.
Yes.
Just trying to be familiar for those who may not. Mr. Dressler, you mentioned earlier, you said that attitude was an issue with the military operating in the DCA. Can you expand a little bit on that?
I can. Unfortunately, around 2021, one of our members, the chief pilot of PG County, reported
Prince
George's reported that there were frequent issues with the pad aircraft. And then, of course, I've talked to you about the near miss that we had with MedStar Metro-operated aircraft in 2017. And I can tell you that First Heli of the Air Force, when I first got here and took this role, would land at MedStar helicopters, at heliports without any radio calls, any notification, any prior coordination, including one time last year when we couldn't land with a critically ill patient at our own hospital because they were blocking the pad.
Let me go back, Mr. Dressel. You just said because they were blocking the path. As I understood it earlier, if you're on a mission-critical air ambulance, they clear the path for you, correct?
Only if you have a way to contact them, sir.
Does air traffic control not clear the path for you?
Not when no, this is when they've landed at a MedStar hospital.
Okay.
And they won't be in radio communications. They're not talking to our dispatch. So there's a general misconception of who has priority within the airspace, within the Class B and the DCA route structure. And that priority system starts at the top with the medevac in medevac status. Next would be law enforcement in a mission status, followed by VIP movements. I would probably equate that one with air response movements that occur from our Coast Guard partners who are based at DCA. And then at the bottom of the chain would be the continuity of government missions. So I realize that's not going to be a popular answer while I'm sitting at this table, but that is the perception within the community that is the case. I'd like to also mention just one other thing. There is a general aversion to Class Bravo airspace in Army aircraft. I learned this when I went through flight school, and it's a persistent culture that I think is proper, that military aircraft are not suited to participate in certain segments of the national airspace system. Military aircraft, of course, operate primarily on government facilities, government ranges, and in deployed environments. So it's really challenging to take a military aircraft and a military pilot and operate in not just a Class Delta airspace, which is a controlled tower, but a Class Bravo, meaning the busiest airports in the country. And then when you add on top a layer of massive complexity, there's no airspace in the country that's like DCA. And that takes a long time. We have one member with 7,000 flight hours just in this airspace, 38 years. We have another with 28 years and 5,000 hours. I have two pilots who've been here 28 years in medevac. And that level of experience takes a long time to build. And unfortunately, I understand the complexities of permanent change of station and all of that. But what we've lost in this environment, and speaking for my group in this case, is we've lost that cohesive tissue with our military partners, where they understand the depths of why the airspace was constructed the way it was constructed, why the routes work the way they work, who has priorities, who doesn't have priorities, and so forth. So it's all of those concepts that unfortunately lead me to make my comments about the units that just don't seem to have the full knowledge of how the airspace is constructed. And I say them regretfully.
Thank you. And I just want to clarify something since we were on the data request, that I do want to thank the Secretary's office, the acting administrator at the time, Chris Rochelot, and the general counsel at FAA for responding and providing us the information that we asked for. So some of this might be redundant, but I think the question will be asked a little bit different, and so I'm interested in your answer. FAA regulations allow DoD aircraft to turn ADSB off when performing sensitive or classified operations in the national airspace for national defense, homeland security, intelligence, or law enforcement purposes, and when transmitting ADSB out would compromise the mission or pose a safety risk to the aircraft, crew, or people and property in the air and on the ground. A memo from the Department of Army dated August 9th, 2024 outlines when ADSB out should be turned off within the national airspace. It states that air crews conducting sensitive or classified operations shall consider during pre-mission planning operating their transponder, collision avoidance, situational awareness, and other onboard systems to emit the least flight information required to meet airspace access and safety requirements. Before I continue on that, what is a local area orientation flight, Colonel DeForest?
Yes, Chairman Hamidi. The local area orientation would include several of the DC helo routes. And I would characterize both north, west, and south of DCA predominantly is where we would focus on our orientation flights, to include Davidson Army Airfield, of course. So all-inclusive of most of the helo routes in DC.
And does it contain sensitive sites? You would, let me rephrase this. The local area orientation flight would be for a new pilot or a pilot that's going to fly this route.
That is correct.
Okay. And I do want to say if there's something you can't answer here, you should just tell me. For the local orientation flight, well, actually, let me go to how do you define training flight? So training flights are referenced.
So there could be many different types of flights. One could be a proficiency flight, those base tasks. Can you, maintain heading, airspeed, altitude, traffic pattern? The next would be a mission training flight, which would include locations that are, mission specific. So many different types of flights. So if it got near an actual location, that would be characterized as a mission training flight.
Okay, so this was basically a check ride and an NVG annual check, correct?
That is correct.
On this evening. So, and that's considered a training flight?
Yes, that would be considered a training flight.
Okay, under the Army's policy, are all local area orientation and training flights defined as sensitive or classified operations?
For this specific training flight, it included, because it was an annual proficiency readiness examination, so we would want to include some aspect of the mission in that evaluation, and that's what the instructor pilot did.
Which is why you said, I don't know if you said it or someone else said it, and I apologize, that this flight was determined to have to be high risk, so you would have to have ADSB off.
Not necessarily a high-risk flight, but would include
the mission.
The mission, yes, Chairwoman.
Okay, so are all standardization flights or all check rides considered training flights?
So
and therefore don't have ADSB that's supposed to out on?
Not so. For example, if a instrument evaluation did not go near one of those locations, then that would be a training flight, not necessarily a mission training flight.
So for this flight, ADSB out should have been off according to your policy?
On 29 January, yes. It met all the criteria for the policy.
Okay, I'm going to hold on that and come back. Member Graham. Member Inman.
I'm going to follow up on it. On that exact line, on those missions that the MOU didn't require the ADSB out to be off, how many do you think prior to January 29th you flew where ADSB was turned on?
The exact number, I am not sure.
It's okay. It's a general 112, 2,000?
I'll work with percentages, probably less than 20%.
Less than 20%. So on those 20%, and I know you probably can't break it down, but based on what we had found in the evaluation working with your team, on those Lima models, in the Mike models, even if you had it turned on, would it be broadcasting ADSB out?
And what we have found through the investigation is there was an incorrect setting. Essentially, when the Lima model helicopters were upgraded with ADSB, call it a maintenance task. So during installation, those maintenance procedures, there was conflicting maintenance procedures. We have found that during this investigation, the ADSB out was not functional. But once it was identified during this investigation, we swiftly made that corrective action and distributed it to the entire Army.
Do you know how many beyond just your aircraft? I think there were 7 out of 8 that were not broadcasting correctly. Is that right?
I'm not familiar with the exact amount, but it was the majority of this 16 that we currently have at Davidson Army Airfield.
Do you have any idea how many other models were affected throughout the national airspace?
I'm not aware.
Could you take that as an IOU to check or to let us know? I know it's not you don't have the entire national airspace, but I'm going to ask who I have right now. That's okay.
But what I would add is the Army did, issue a safety action message that was widely distributed, and we received it almost immediately once we determined, at Davidson Army Airfield there was a potential fault.
And we appreciate that. I think we were made aware of it, so thank you. Have either one of the representatives of the Army, have either one of you been in the DCA tower cab?
I have not.
Check. Yes, sir. I've been up there a few times, and I've taken pilots up there for tours.
Okay. Did you actually kind of look a little closer at what the helicopter operator, what they do and how they operate just to get familiarized?
Yes, sir. And while I was there was actually helicopters on the DC Healer routes. So we were actually able to see the calls and see the communication between the aircraft and the tower.
Great. Did anything surprise you whenever you were in there doing that tour?
No, sir.
Mr. Allen, I guess for familiarization with the DCA, this I found to be very interesting as we read the interviews. We've been talking a lot about routes, and we've talked about the river. We've talked about how it was constructed. Whenever a controller is controlling from that helicopter position, do they actually see the routes on their terminal? Are they able to know if an aircraft is within the route or not? Or the zone?
They can visually observe out the window. On the radar display, they can pull up the route map or the zone map or both maps. And a hard copy of the map is also available in the tower.
Do they ever pull them up on the radar scope itself?
Yes.
Okay.
Yep.
I'll go back on that one then. I apologize. It seemed like in reading a number of the interviews with the controlling staff that they spoke or talked to us about that they did not usually see or have the river indicated, nor the route overlaid on top of it. Does that seem correct, or is that just a misperception in reading the documents?
It would be controller preference to overlay the entire helicopter map if you wanted to do the routes and the zones with the items that are already depicted on there. And then in addition to that, all the data tags and stuff, it can become very cluttering. You can turn it on, turn it off, you can dim it, you can make it brighter. Mm-hmm. You can really customize it to what each controller would like to see and how they want to see it. So it would be a controller's prerogative.
What if the controller was operating in a combined environment when they were doing not only local control but helicopter control? Would they have both up at that time?
They could if they chose to.
Okay. See, I'm over. We're close.
You weren't over. Okay. I'm going to go back to ADSB. Colonel DeForest, so the accident helicopter was capable of transmitting ADSB out. And what it was not transmitting ADSB out on the accident flight, you just talked about why. And we found, though, that the accident helicopter's transponder began to respond to Mode S interrogations near Cabin John and continued until the midair collision occurred. However, the actual data wasn't transmitting. In fact, the accident helicopter had not been transmitting ADSB data for 730 days. Under your policy, are aircrew permitted to switch between transponder mode or to turn on ADSB out during operations while in flight?
No, they're not.
Have you ever heard of a situation where the transponder would just start spontaneously responding to Mode S interrogations? I'm going to stop right there.
I'm not aware of any.
So I'm not asking you to speculate. Have you ever been aware of a crew member to turn it on in flight, of a crew member turning on ADSB out during flight in violation of your policy?
I'm not aware of that in flight per the policy.
Would the only way that would be come on be that somebody would have turned it on? Or is there some other way?
I believe it would probably take human interaction to turn ADSB out on in a Lima model, because it's several steps.
That's what I'm going to ask you. What's the process for turning it on?
Having never flown a Lima model, I'll defer to Mr. Van Vechten behind me of what that procedure is.
Yes, turning on the ADSB out. In a Lima model, you have to go through several different pages. Mode S is 2 button pushes, though.
So you would have to you would have to go through several menus.
Yes, ma'am, that's
to do
correct.
That. Okay. What would have occurred in this flight had the time setting been correct and had the ADSB out been on, because it was on, just not transmitting? Colonel DeForest or Mr. Van Vechten, whoever wants to answer.
For ADSB, I'm not aware of a crew member cockpit indication that ADSB.
No, I mean, what information would have been provided? In this case, if it was transmitting ADSB out, what would have been provided? What would have occurred in this situation if, in fact, it was operational and didn't have this setting error?
Sir, I can take that.
Yep.
In your blind spot. Hello. So if ADSB out was working, you would have had, in addition to the mode S identification, you would have had the position, the barometric altitude, the geo altitude. You would have had a velocity vector. Is that what you're asking for, ma'am?
Yes. So in this situation, had the setting been correct, because it was on, that's what it would have been provided.
Yes, ma'am.
Thank you. Who was responsible for installing the transponders? What organization or entity, not person? If you don't know, you can get back to me.
Yeah, we'll get back to you, but it was a fielding team, just like we do all of our modification work orders for new equipment to aircraft, ma'am. And it's various groups of contractors or civilians who go to units to do this activity.
I see. So the Army contracts it out, and then a contractor would do it.
Or a civilian group could do it as well.
Okay, great. And so we found that the accident helicopter and, in fact, 7 other Limas from the 12th Battalion were not transmitting ADSB data because the helicopters had the incorrect time source setting programmed during installation. The setting should have been 059, but it was 153. The work order for installation that I looked at of the APX-123 transponder contained instructions to set the time source on the RCU to the 153 setting. The work order for the installation of APX-123A, same thing, APX-123, but this one was A, transponder included instructions to set the time source to the 059 setting. Is that correct? No, I'm over.
I don't have the instructions memorized, ma'am. We can get back to you.
Okay. Those instructions included steps for the 059, so that's the APX-123A alpha. Those instructions included steps to use a transponder test set to confirm proper functionality of ADSB, specifically that the test set received the flight ID, aircraft address, and the GPS position and altitude information. Prior to the accident, did you do any sort of checks on the ADSB to confirm that they were in fact installed correctly?
To my knowledge, we did not conduct those checks based on conflicting maintenance manuals.
And were there, prior to the accident, were there any sort of checks prior to takeoff to ensure that ADSB worked if, in fact, you weren't going to a mission site?
There was no procedure in place. However, every flight out of Davidson, they do that check today.
And that's what I'm about to ask you. So talked about the safety alert for a second, because you did take action with that information.
Yes, ma'am, we did immediate action.
What did you do?
Well, our maintenance OIC, and working with the officer in charge,
okay.
In working alongside AMCOM and the NTSB, worked to package up essentially the the language in the ASAM, safety action message. And almost immediately, once that message or that procedure was established on the airfield, within a day or so, we reconfigured all aircraft at Davidson Army Airfield and had successful ADSB out checks.
So essentially, a safety alert went out, to paraphrase.
That is correct.
And this is my last question on this. Will you include those checks during regular maintenance intervals in the future, or what are you doing now?
Right now, every flight is checked.
And is that 12th Battalion or Army-wide?
I can only speak for 12th Battalion.
Can anyone else speak for the rest of the Army?
Ma'am, I'd offer for the Army, it's assessed as a high risk if they don't have ADSB out. So it's incumbent on the unit to probably check that. Otherwise, they're going to have to say it's a high risk. But by that, I mean that if it's automatically high risk if they have ADSB installed and they don't know that it operates. If they know that it operates, then that de-escalates the risk. I mean that an 06 like Colonel DeForest doesn't have to approve every single mission that happens. So it pushes the unit to want to be in compliance.
So do you know for sure this is not?
So we're tracking the field's compliance with ADSB out. We know it's over 95% now. The numbers probably changed since I looked at it.
The checking ADSB out.
Yes, sir.
Okay.
Or yes, ma'am.
Thank you very much. Member Graham? Member Inman?
How do you test that in the field, in the wild? I'm sorry. Just how would you know?
So there are test kits which you can use that are fielded to the units that were fielded along with the transponder you can use on the ground. But another method that we've promulgated is to actually take a flight with ADSB out indicating that it's operating, and then after the flight you can query an FAA database and see all of your fields and see if they were operating when they were supposed to do, and those instructions have been sent out.
Is that a new procedure?
The test kit is not a new procedure, but the extra details on actually querying the FAA website has been clarified recently.
So on these test kits, is that something that's done routine? Is it sent around? Do you have to request it? The Army has procedures for everything.
So test kits did not have a definitive test interval, but now that we have this policy for ADSB out compliance, it is being checked on a regular basis. I would guess anytime the transponder is serviced, which can be, 12 months, 24 months, it's going to be checked.
Okay. Mr. Fuchs, do you have the transcript, the page? Okay, well, I apologize. I've been trying to get a document pulled up, so I'll just try to read it a little bit if that's okay. And this goes back to Mr. Allen. We talked about earlier having the actual, if you will, for lack of a better term, helicopter route displayed, and that's on the STARS display, is that right?
Yeah, on the tower radar display.
And that's something that's normally done, is that correct?
If the controller chooses to display it, yes.
Okay, they choose to display, or do they normally have that up?
It's controller dependent. If somebody's new in training, they're going to have all the maps up and have them displayed so they can continue to learn and orient themselves with the arrivals and departures and the other items that are associated on the radar map. Somebody that maybe has more time at the facility may not choose to view it.
I'm just going to go to page 64, the transcript of the local controller on the night of the accident. The question was, do you have an overlay of helo routes on your tower display? Answer, yes. Answer, you can put the helo map on the STARS. Question, okay, was it up that day, or do you normally not have it on? Answer, normally we don't have it up. Question, is the Potomac River dictated or I think we now have it up, sorry. Cool. Yeah. Yeah, it starts at line 13. Is the Potomac River identified or depicted on the radar maps that you use? No. Isn't the Potomac River the actual map itself? Is that not the guidelines or the parameters?
You can depict the map, or depict the river, I'm sorry.
So why would this controller not believe or say that you could?
I can't speak for his answer.
Okay. Colonel DeForest, for the Army, I guess, we've had a good opportunity to hear. There's been a lot of lessons learned, and I want to commend a lot of quick action, it seems like, to try to correct things across the entire NAS. What other areas that are safety items that have been identified so far that have not been corrected?
When we look at our risk management within the organization, you always looking to ID those hazards, come up with a corrective plan, and then assess them. To date, throughout this investigation today, I am not aware of anything, but I asked anybody in the room if they know something, please inform us. We know what we know, and we will rapidly and swiftly address them. And that's where we need help, in my opinion. But to date, throughout this investigation, our crews that are ready to go today, right now, they're as safe as we understand them to be. And I have full confidence in that.
Okay, I wasn't trying to draw you into something. I'm just trying to get an understanding. Out of the entire operating unit for PAT, what's the balance between Lima and Mike? The numbers.
So within 12th Aviation, we have 16 organic Limas, 8 organic Mikes, and then a National Guard company minus with 10 Mike models. So on the airfield, there's 34 Black Hawk helicopters.
And how many of them are Mikes versus Lima?
So within 12th Aviation, 16 are Limas, 8 are Mikes, and that's organic to 12th Aviation. And then we have an additional 10 on the airfield to supplement our mission requirements in a rotational National Guard unit. And they have 8 Mikes. So in total, there's 34 Black Hawks.
So I guess, and tell us again, which one's a better model, which one has a better avionics, more safety features built in?
This would be, in my opinion, both the Lima and Mike are adequate for our mission.
No, sir, that wasn't the question. Which one's a better aircraft?
I've got to ask for a clarification on objection. We're talking about other airplanes not assigned to this accident, why we're discussing Mike models used for having to discuss it in another forum, but relevance to the accident of 29, the relevance to
Okay, that's fair, Brigadier General. That's fair. I'll tell you what, I'll reframe the question. PAT 25, who determined or decided it would be a Lima model or a Mike model?
That would be based on the approval level of the weekly flight schedule, and that's the battalion commander, so Army Lieutenant Colonel.
So is there any deliberation of whether or not it's a mission critical flight to determine whether it's a Lima or a Mike model flying?
Yep, and I'll defer to Mr. Van Vechten on that one.
The flights chosen for the aircraft chosen for the flights is based on the crew currency and qualification. So if you're assigned to one of the 2 Lima companies, you maintain currency in a UH-60 Lima, and your evaluation will be done in a Lima, and vice versa with the Mike. There was only a few of us who maintained dual currency because we didn't want the interference going back and forth between the 2 aircrafts because they are significantly different.
Okay. See, I'm out of time, Chair.
Don't worry, we have several more rounds. 7 o'clock is not going to happen. Okay, Section 1046 of the 2019 National Defense Authorization Act prohibits the Secretary of Transportation from requiring the installation of ADSB on fighter aircraft, bomber aircraft, or other special mission aircraft owned or operated by the DoD. 2, denying or reducing air traffic control services in U.S. or international airspace to such aircraft on the basis that they are not equipped with ADSB, or 3, restricting or limiting airspace access for such aircraft on the basis of the aircraft are not equipped with ADSB. This is outlined in a memorandum of agreement between DoD and the FAA. That MOA goes through the roles and responsibilities of both parties to ensure safety in the DC airspace. The MOA is dated April 16th, 2024, which was prior to this particular accident. How often is that MOA reviewed?
I don't know the normal periodic, I'm having a fumble here.
Yes.
Need a little more water, but we are currently, have a work group reviewing that MOA as we speak.
Okay. Okay. Do you guys need more water? You're good. Okay. So is that codified or written anywhere on the how often that MOA is evaluated or other MOA?
I don't know at this time. I would have to check back with the administrator's office to find out how often that's changed.
Understood. So you said the MOA is being updated now, is that right?
That's correct. They have a working group going to modify that MOA. In the meantime, the administrator has put out strict guidance on the National Capital Region.
Yes, thank you, and thank you for that. Excellent work. So generally, how do, and I'm going to ask you maybe Mr. Van Vechten, maybe, I'm not sure, I might get that wrong, and Mr. Fuller, could you talk about how DoD and FAA coordinate to ensure operational safety in the DCA region and more broadly in the national airspace?
So we have military liaisons in all of our field offices. In addition, we have what they call liaisons for certain areas. And so I know that we have a lieutenant colonel based here in headquarters that I meet periodically with to discuss changes. We have a CIS operations security team that meets with the military to discuss potential missions or changes to the letter of agreements, things of that nature. At our command center, we have DoD assets embedded within our command center out in, and they coordinate mission-specific requirements or airspace challenges to alleviate weather concerns, but we are in continuous and constant contact with our DoD partners.
Okay. So I'm going to switch gears a little bit. The volume and complexity of mixed traffic requires so that's an MOA. So letters of agreement that outline specific procedures for conducting operations within the DCA Class Bravo airspace. By my count, it's 15 different sets of letters of agreement. So 15 different letters of agreement that provide different procedures for DCA Tower. There's Andrews, there's Virginia State Police, DC Metro, FBI, MedStar, Air Force, Army, 12th Aviation Battalion, DC Army, National Guard, Air Force, aerial events, Potomac Tracon and DCA Tower, National Capital Region Air Defense Facility. I could go on. How often are any of those letters of agreement revisited?
I would have to specifically reference the letter of agreement requirements within the 7210.3. I believe it's either an annual or every 2-year requirement, but I'll have to get back to you.
And what's the process for that?
It would be a local facility review. Any updates, changes would be required to be reviewed by the Mission Support Service Center and also coordinated for environmental.
So DCA Tower would do it?
Yes, correct.
And do they bump it up or they just decide?
Can you clarify?
Do they make recommendations and someone higher up decides?
No.
Makes the final decision?
The air traffic manager would be signatory to the LOA.
Okay. How does having 15 LOAs, and I'm just going to, you've got 15 LOAs. We've got, I'm just going to take a current. Air traffic control procedures. I mean, it's pretty lengthy. How does this affect workload? I mean, that's a lot. Well, different procedures.
So do you mean locally or in general?
I'm going to ask how it affects DCA Tower.
Okay. That's fair.
So the having 15 LOAs is not, I would say, uncommon.
Sure.
Pre-accident, the majority of the LOAs with the helicopter users were just in reference to special VFR operations. There is several of them that do include additional items, mission requirements that they may have, but the majority of them had the same language for the special VFR requirements.
There were some differences.
Yeah,
So
there are some differences for specific units or missions.
And how do controllers, and I'm asking, and you know what, I'll ask during training tomorrow. I'll ask that during training tomorrow. Okay, Member Inman.
Thank you, Chair.
I'm assuming you okay.
Colonel Force, in regard to the PAT-25, the mission on that night, I'm going to get a little bit into your tasking in the National Capital Region. Had the crash not have occurred, what would have been the continuation of this flight? Can you walk me through to the end whenever it's finished and over?
Yeah, based on the RCOP and what we know is they were continuing Route 14 to return to Davidson Army Airfield.
And they would have been finished at that time?
To my knowledge, yes.
Okay, during the initial week of I believe in our response, the initial week, and I don't know if this is entirely factual, so please, I'm just curious. There was a discussion that you had to do evasive maneuvers as part of this checklist or check ride. Is that correct?
Evasive maneuvers that's not a mission task.
Okay, that's not part of the proficiency or the check ride?
In other Army aviation units, they can be considered, but that is not a mission task. There's no reason why we would practice, navigating a radar environment, like when we look at threat radars or surface-to-air threats, things of that nature, like a deploying unit overseas would do. But for evasive maneuvers, that's not a mission task within 12th Aviation.
Okay. I'm going to go back to the PAT-25 flight again. Was there anything that prohibited or required this flight to occur while commercial operations were occurring at DCA?
There was nothing commercial related that would prohibit this flight along their planned flight route.
My question, I guess, could they have done it at 2 a.m.?
Yes, I think I know where you're going on this.
Okay, I'm trying to draw you to somewhere. I'm just saying, in these check rides and in other flights, do they have to be done while there's a push going on at DCA or while commercial activity is going on?
The broader context is our mission crews, they have to look at their duty cycle. So if the instructor pilot is on a duty line the next day, he has to be on the ground by a certain time. I don't know if he was, scheduled against a duty line the following day, but there's a very finite window where we can, based on our duty schedule, conduct training both day and night.
Is that a complicated task for your battalion?
It's a challenge, but it's sustainable. We are resourced to sustain that type of level of scheduling.
Had that flight not have occurred, let's say a weather caused that flight to delay, does it automatically get moved to the 2 days later, 1 day later? Does it fall into another cycle?
It would be based on instructor, the person being evaluated, and then aircraft availability. So I wouldn't anticipate more than a 7-day delay.
And at the time of that flight, were all your pilots still staying current, I guess is the best way to describe it?
So for the entire battalion, certainly.
I'm not going to ask you to do the entire battalion. I'm sorry.
There's certainly, maybe a handful that would be medically grounded, or when we look at, this is a risk conversation, non-medically grounded too. So those do occur in our unit. So nothing was out of the ordinary to me, in my opinion, based on the crew mix composition that evening.
I guess I'm going back to, was there anything leading up to this that was complicating your group to conduct their mission? Lack of parts, lack of people, transferring of positions. I'm going for a very broad concept here, and I know you've been interviewed a couple of times, so I'm just trying to get your opinion in that.
Yeah, my honest opinion, right? month of January was significant, as in our greater mission, when we look at what we support with not only Joint Task National Capital Region, which is our contingency missions, COG and COOP, but also United States Army Military District of Washington. So we support national special security events. The month of January had 3, and that's a busy time for the organization to include all the weather. So the lead up, when we look, my assessment across the formation was we had essentially executed 3 large events for the organization. That's not just specific to 12th Aviation Battalion. So I don't have that assessment that we were a fatigued organization. We were probably the most proficient as an organization. Now, when it looks, you look at your duty lines, that's our primary focus. When I look at 12th Aviation Battalion, their primary mission is COG and COOP, and everything else follows after that for mission priority. So we were, at that time, on the 29th, a very ready formation. Certainly with the loss of 3 crew members, there's a readiness impact, and we're still recovering from that.
Do you feel comfortable telling a pilot or telling a crew not to fly? Do you feel that you've got the power to say, don't go?
Absolutely, 100%.
Does your entire organization, do they carry that? And I'm looking behind you, actually.
I believe so.
Sir, that's a true statement.
Is there any pressure from above you to say you need to be able to execute certain missions that you feel like you don't have either the equipment or the resources for?
I can't think of any specific instances where I felt pressure to execute a mission.
I'll use an example today. We requested, so Bravo Company, 12th Aviation Battalion, we have a lot of people watching right now, and we gave them the opportunity to do that. So there's others maintaining our line right now, and we know that's important. So that would be an example of knowing your people and reducing risk to the greatest extent possible.
Great, thank you. I'm going to go back to Ms. Murphy and Mr. Stowe. The helicopter routes we know have no lateral dimensions, no lines per se. Mr. Stowe, I just want to make sure I have this right. Did you say that controllers are responsible for monitoring flights to ensure they stay on the route? I just want to make sure I have it right.
I think the context would have been they would be responsible for monitoring the flight to ensure they have the appropriate separation. So whether they
appropriate
deviate,
separation, but not deviating outside of that. Because there's no lines,
correct.
They're not responsible for figuring out, oh, they're a little bit over in the Potomac River than where they should be.
If it impacted separation, I would expect that they would absolutely inquire as to why they may be further east or west than would be expected.
Well, what would be expected if you don't have any clear lines there?
I think it would be traffic workload situation dependent on if there's an expectation from the controller that the helicopter is at least along a general route, but if they are a half mile west, for example, that the controller would need to take action if it impacts separation.
Mr. Allen, on the Falcon replay, where in the Potomac was Pat 25? Was it on the east bank of the river? Maybe first start with what is the Falcon replay, because not everybody knows that.
The Falcon replay is the replay software program that the FAA uses to replay radar data.
Okay. So do you know where Pat 25 was on the Potomac there, on the Falcon replay?
From my recollection, Pat 25 appeared more center of the river.
More center.
Yep.
And if you are a controller who is working in the tower, you're handling 6 different flights, Actually, within 10 minutes, I counted, he was dealing with 21 different flights, helicopter and civilian aircraft. At night, can you see that there may be over a little bit more?
It's difficult due to the altitude there. They can blend in with the cityscape behind them, as well as the helicopters do not operate all of their lighting systems that are available.
So if it was a little bit over, you might not know the difference if you were looking out.
You may not.
It's nighttime.
Right.
So I'm going to ask again, whose responsibility is it to ensure you're on the east bank of the Potomac River? Controller or the pilots on board, the crew?
If you're using that as a separation standard, the controller needs to be the one to assign a heading that would put that helicopter on the east bank. In this particular instance, the controller approved visual separation for PAT 2.5, and I would, again, be purely speculating.
Don't speculate.
Then there's no way for me to know how he would assume he was navigating along that bank.
And okay, I'm going to stop that one, and I'll ask more tomorrow. I want to go back to Ms. Murphy. How do you do an evaluation if somebody requests a change on the route? Do you know? You're in the visual charting for FAA.
Exactly. So Aeronautical Information Services, my visual charting team, is not responsible for evaluating what air traffic control submits. We do work alongside them, and if we see something completely out of the ordinary, say an altitude that would just be impossible to fly at, we'll question. Aside from that, we really are, the Aeronautical Information Services visual charting team receives the information, we receive the data, and we chart it as requested.
Okay, so these 3 hotspots that were identified in an FAA November 2022 symposium, hotspot 1, JPN Memorial Bridge transition. I think the request was to include something on the chart that said pilots use caution for runway 33 departures when DCA is in a north configuration, which this one was. Runway 1519 arrivals when a south configuration. Hotspot 2 was Haynes Point. Hotspot 3 was Joint Base Anacostia, Bowling, Route 4, power plant region, and the request was to have something on the chart that says pilots use caution for fixed wing arrivals to runway 1 and to runway 33 when DCA is in a north configuration, runway 1519 departures in a south configuration. You're not aware of these recommendations?
I am aware of those recommendations. As I mentioned earlier, in 2023, Aeronautical Information Services received the requests from the DCA Helicopter Working Group, and I believe that's where those recommendations were made. Again, we implemented all of them with the exception of the addition of hotspots due to the fact that they are not within the VFR aeronautical charting standard.
Did you offer an alternative?
I have no evidence of offering the alternative at the time. However, it is our standard operating procedure to work with air traffic whenever possible to solve problems and make the NAS safer through charting.
Okay, because I know you said they had some other route they could bring this up.
Yeah, it was the aeronautical charting meeting that Aeronautical Information Services hosts twice a year. It's our outward-facing outreach so that stakeholders and aviation industry can make recommendations for the aeronautical charts.
It just sounds very bureaucratic to me. You can just go seek it somewhere else rather than perhaps you might come back and say, well, we can't do this, but we can do that.
Oh, we do, absolutely. So what we do is we'll work with them, and I think as a result of the working back and forth, we added a caution note. I don't want to misspeak and say something that I don't know about for sure, but we work with the air traffic control offices to solve and address any issues that they might have.
Can I just ask, the request for, and I'm sorry, I'll be done. the request for language that said, pilots use caution for fixed wing arrivals to runway 1 and to runway 33, you did that? When in a north configuration?
I cannot confirm without it in front of me. Can I take an IOU?
Yeah, I don't think you did that.
Okay. I know that we added several caution notes at that time and also modified others. I just don't recall exactly which ones they were.
I'm just going to say that this is the very event that would have been the cautionary note for north configuration, fixed wing aircraft landing on runway 33. Member Inman. Member Graham. Member Inman.
I'll follow up on that. For charting, do you handle the entire United States?
My team does, yes.
Your team does. Mm-hmm. Are you aware of the special notices for LAX? I may be showing you something you haven't seen, but the LAX, have you, it's not up there, don't worry.
Okay, I don't know exactly what you're talking about, so I can't comment, yeah.
The reason I bring it up is we found this as an exemplar of, I know we put some, you said you put some cautions in the notice section, right? LAX currently has a special notice, a caution, says intense helicopter operations. That seems a little bit more than a caution. It actually specifically describes when operating a line parallel and 1 mile north, the 91 extension gives all of those. They need to make regular position reports when not in contact with ATC. They give additional specifics. I guess I'm curious, how does LAX already have intense helicopter operations, and it's been there for some period, and DCA, which is being described by everyone here as being one of the most complex helicopter systems in the United States, did not have one before this accident?
They did not ask for it.
But they did. Did they not?
They asked for hotspots.
Can I?
Yeah, please.
Can I? On March 15th, 2023, the working group formed for a safety risk management panel focused on exactly that. Let me just quote what it said. These routes and zones, referring to the Baltimore-Washington helicopter route chart in the Ronald Reagan Washington National Airport ATC Tower airspace, that's what it said. These routes and zones are heavily traveled by medevac, military, law enforcement, photo missions, VIP movements, and support other special operations. In conjunction with the helicopter routes and zones, there is a high volume of fixed-wing aircraft that operate in the immediate vicinity of the published routes and zones. The current helicopter routes and zones have changed very little since 1999, while airlines, aircraft types, approaches, volume, complexity, crews, and many other factors have evolved. The Baltimore-Washington helicopter route structure has not. With the current route zone structure, helicopter operations are occurring in a proximity that has triggered safety events. These events have been trending in the wrong direction and increasing year over year. And then they recommended action. But are we really going to say, well, they didn't do enough? I'm not looking for an answer right now because honestly, I don't get it. Every sign was there that there was a safety risk, and the tower was telling you that. Yet you know what FAA did? After the accident occurred, you transferred out the air traffic manager, 2 assistant general managers, and the support, staff support manager or support person. I'm sorry, I don't know the exact title, but what you did is you transferred people out instead of taking ownership over the fact that everybody in FAA in the tower was saying there was a problem. But you guys are pointing out, welp, our bureaucratic process, somebody should have brought it up at some other symposium. Are you kidding me? 67 people are dead. How do you explain that? Our bureaucratic process? Do you know we actually added up how many steps it takes to get from the tower to headquarters to figure out, and we ran all sorts of scenarios, how many steps it takes to get a policy change. 21 steps. Fix it. Do better. Member Inman.
I don't know if that was my time or yours, but I don't think it doesn't matter. We're here for a different reason. I'm going to go back to, actually, I'm going to read something. As part of this process from the FAA, did you go back and look at the ASRS reports around DCA?
We did do an evaluation of the ADSB safety reports and the ASRS reports around DCA, correct?
For the ASRS, was anything troubling for you in looking through those reviews?
We noticed there were a few indications of helicopter conflicts with fixed-wing aircraft. They weren't in the vicinity of helicopter Route 4 and runway 33 primarily.
This one was an oldie but a goodie, but it just tells you, I think it came from 2013. It's number 1127815. This is where an actual controller agreed and said he was describing a conflict event involving a helicopter awaiting a photo mission and an air carrier arrival. The reporter suggesting improved and standardized procedures for handling helicopter photo operations. But in the narrative, one of your own air traffic controllers says, our helicopter operation is an abomination of the picture of safe aircraft movement. Do those trouble you?
Any report that mentions an aberration of safety is going to trouble me.
So what action gets taken after something like that?
I can't speak to what happened in 2013, but
I'm saying anytime. I'm just using this one as probably the best example because it's not like this problem just popped up.
so if it's an internal report to the facility, they have a local safety council that can take immediate action within their facility. It's a management and union representation. If they need additional support from external, you have district resources, QC managers, support specialists. If it's something that requires more, we've got director level support and service centers for it. DCA would be Atlanta. For the other areas, it'd be in Fort Worth or Seattle. But we do have support to make sure that any immediate concerns we adjudicate and address.
What was, you said you looked at the ATSAP in regard to this incident. Since we have not seen that, what trends did you find in the ATSAP data? Because that's held internally and hasn't been shared with us on this. Again, what did you see in that you can disclose?
We didn't find any additional trends that will report in the specific operations around helicopter Route 4 and runway 33. There was just no data, no reports that suggested this was something we missed. Again, I think some of our military counterparts have indicated we don't utilize runway 33 very much for our operations. And so we just did not have enough safety data that indicated that was an outlier.
You don't use, so if I understand it correctly, you don't use runway 33 very often, is that right?
That's correct. It's about 5% of the operations at DCA and North Flow.
And why is runway 33 then used?
It is an available runway, and sometimes the controllers may use it to resolve an overtake situation on runway 11 just to offload some traffic.
So as traffic increases, they need an exhaust way to clear traffic out, is that right?
It may not be an increase in traffic, it may just be a slower aircraft in front.
Okay, I'm gonna pause on that. I think I may go back to it tomorrow. Go ahead.
Well, well, before I go on to the totally different topic, Colonel DeForest, and we're going to go into this in the panel 5, but I don't even know if you're in panel 5. Today's Wednesday. This 2 days from now.
I am.
You are? Okay. Well, I'm just going to ask while we're here. Do you, in order for you to get this information of ATC has raised concerns, apparently several times, you'd have to ask FAA, correct? or FAA would have to notify you?
That is correct. And we have an agency, the United States Army Aeronautical Services Agency, that would provide that to us. And
Were you, go ahead, I'm
and
sorry.
we do receive what we call updates to the field. So within our brigade, we have an airfield division that does regular and routine interaction with the FAA. These types of reports that we're discussing right now, they're not pushed to us. Let's just call it that.
And I know I saw you in some of the minutes, and not you, the battalion in 2019, 2020. The hotspots and the like that were put forward by Tower. Was this investigation the first time you learned of that?
For me, since being in this unit since August, yes, this is the first time.
How about anybody else in your unit? Were they aware?
I would hope
that you know of.
Without asking Mr. Van Vechten behind me, who was here 2 years prior to me at least.
Mr. Van Vechten, how about you?
No, ma'am, I was not aware.
Yeah. Okay, I'm going to switch gears for a second. I'd apologize, but I'm not going to. There are 10,000s of pages in the docket, so I have more questions. But I'm going to switch gears, Colonel DeForest and Mr. Van Vechten. For pilots coming into the Army Aviation Brigade, what experience or background in aviation are you seeing compared to maybe years ago?
So this is when we look at flight hours.
Flight hours, sorry.
It's less than it was years ago, and this is something Army Aviation is tackling.
Yeah, I was a little bit concerned, a little bit surprised, sorry. When I was reading the transcripts, it seemed that some of the, I would have expected the people we interviewed would have had more hours than they currently have. It seemed kind of low. In fact, Colonel DeForest, you mentioned in your interview that you asked Mr. Van Vechten, sorry, talking about you, what the greatest challenge is. And you said, I think, my opinion, consistent across a lot of Army aviation units is what we're seeing is that composite cockpit time steadily going down and down and down. So he used, and he, meaning Mr. Van Vechten, used the example about 5 years ago, we would have had thousands and thousands of hours cockpit. Now we have hundreds and hundreds of hours cockpit, and that is usually, I've heard that before in other organizations. I experienced it when I was in USA PAT as a battalion commander, same, very similar challenge. It's the aggregate flight hour experience across aviation formations is steadily decreasing. Is that your biggest one of your biggest challenges, I would think?
Absolutely.
Just like the airlines are probably experiencing now. So I want to talk about currency. Numerous 12th Battalion personnel said that we interviewed, that they are pushing to get flight hours every year. Is it 60 hours every year? I'm sorry.
It's 48 hours
48.
every semi-annual, so 96 annually, ma'am.
96 annually. And is that something you're seeing? Numerous personnel said that they were pushing to get the minimum hours. Are you aware of that?
I will comment on that, ma'am. It depends on the individual. The more qualifications you have, the more opportunity you have to fly. So if you're an instructor pilot, you're probably going to fly more than your typical basic co-pilot because you can do evaluations, you can do proficiency flight evaluations, and you can also do missions.
How about staff officers?
So staff officers has historically been challenging to try to find time to get the experience. Sometimes they'll get their currency, but currency doesn't always equal proficiency. So that is a challenge to maintain proficiency in the aircraft and not just currency.
And why is that? For people who are not familiar with what a staff officer's responsibilities are, compared to them getting flight time?
So the way that I'd explain that, ma'am, I explained to someone earlier, between a commissioned officer, a captain, lieutenant, major, colonel versus a warrant officer. A commissioned officer is a officer who happens to be a pilot. I'm a pilot who happens to be an officer. So my primary focus is aviation. I focus in one specific area, which is aviation. Commissioned officers, they must be have more skill and knowledge across a wider band of topics, because they will typically do those staff positions where warrant officers will stay in the flight company longer and perform and be the continuity for the unit.
Thank you so much. Member Graham? Member Inman? Sure. Continuing on, what kind of training did pilots who were joining the 12th Aviation Battalion receive from the Army for operating within the DCA airspace?
So once they arrive, ma'am, prior to their first flight, they must complete the FAA DC Special Flight Rules Area training online, and then the academic, including the reading card file, and then a local area orientation covering all the local area.
Thank you. And in flight school, what model of aircraft are they trained on?
They now begin on the UH-72 Lakota for primary contact and then move on to the instrument phase. They fly the basic warrior skills, BWS, in a UH-72 Lakota, where they learn basic land navigation from an aircraft. And then they move on to their advanced airframe, either the AH-64, the CH-47 Chinook, or the UH-60 Mike Blackhawk.
And those are more advanced than the Lima?
Yes, that's correct.
Okay, so you go through flight school on these more advanced aircraft. You don't have a lot of experience in aviation. Let's say you're new. And you go through school in these advanced aircraft, you learn to fly, and then you come to the 12th Battalion and you fly the Lima, so you basically fly steam gauges.
Yes, that's correct, and that challenge is not unique to 12th Aviation Battalion and TAB. Most units, most combat aviation brigades across the fleet have at least one UH-60 Lima company, so that we conduct a training support package to qualify that new pilot in that aircraft that they've never flown before.
And does that present challenges that where, and just to ask, do you have pilots that only fly Mike or only fly Lima?
Yes, we do.
Okay.
In TAB specifically, there were only a few people that would go back and forth because of the significant differences.
Okay, and so if you were trained on the Mike, you go to the Lima, maybe talk about some of the challenges that presents.
Well, the UH-60 Mike has a fully coupled flight director, also known as autopilot, so it maintains an altitude, a heading, and an airspeed. It'll do a fully coupled ILS. It can track to a VOR while maintaining altitude and airspeed. The UH-60 Lima has a force trim system, which is kind of like a force gradient that holds the cyclic, the stick in place, and then the collective has a friction that you can turn on or off, which will hold the collective in position.
On the Mike model?
On the Lima.
Oh, on the Lima model.
The Mike model has a full autopilot.
Full autopilot. Okay. And you're kind of getting to where I'm going. Some of personnel from the 12th Battalion that we interviewed said there were some differences in managing power and pitch.
I would say the power management aspect is negligible between the UH-60 Lima and the UH-60 Mike. Pitch, I would say, is more significant. If I input an altitude and an airspeed to hold in the UH-60 Mike, it's going to hold it as best as it can. There are external factors like winds and turbulence and stuff like that, but the UH-60 Lima is 100% pilot controlled, so much more of the focus is dedicated to maintaining altitude, airspeed, and heading.
So if I'm just going to read you this quote. This was a quote from one of the personnel interviewed. To maintain exactly 200 feet in a Lima is quite different, where in a Mike model, I can roll in, rad out, hold to the water at 200 feet or 199, and the Mike model will do that, where a Lima, maintaining at exactly 200 feet over the water is challenging. Would you agree with that?
Yes, I would agree.
Why?
Well, first, I wouldn't, personally in a mic, I wouldn't couple to radar altitude over the water.
Yeah.
There's just too many variances with the signal bouncing off of different structures, and you're going over bridges and stuff like that. So I would couple to typically 180 feet on the UH-60 mic, which is right near the max for the 200. Where in a UH-60 Lima, you have to kind of set the collective and use the friction lock, which is on the right seat only, on the right side of the collective, and kind of friction it down to maintain the altitude, which requires the pilot to come in the cockpit more often to look at their altitude.
Thank you very much. Member Graham? Member Inman? Okay. So we talked about the challenge to maintain proficiency. We talked about the officers. How about the availability for getting more hours? How about the availability of aircraft resources? We did interview quite a bit of personnel saying it's an aging fleet. A lot of times they're in maintenance. Is that, do you know if, do you agree that that presents some difficulty?
The difference between Lima and Mike is at 12th Aviation, the Limas are more maintenance intensive. Yes.
Yeah. Do you want all mics? Do you want to get rid of the Limas? Oh, come on. This is your easy. This is like a softball.
Standardization. I seek standardization and safety. And
well, you want standardization of all Limas?
From a cost, blade time, a mic model, as I understand, in the unit that I command, yes, a mic model is less expensive. And having a pure fleet would save time and money.
Thank you. I think that was echoed by everyone that was interviewed, is they would rather have a one model and being the mic model. I'll do what I can to help you out in appropriations, only if we're fully funded. Okay. How are crew trained on the approaches to DCA runways? How are they trained, for example, on a circling to 3-3 approach?
There's no training that takes place for that, ma'am, for rotary wing aircraft. We don't train fixed wing procedures.
Oh, I'm sorry. I don't mean, how are they trained in knowing that a fixed wing aircraft would do that?
That would have to be through personal knowledge when you're given a circle to land, but that's not something typically we would discuss as helicopter pilots about fixed wing procedures. For instance, I've heard pilots be cleared for the Mount Vernon visual. I'm not familiar with that, but I assume they come in from Mount Vernon and fly a visual approach. But we don't specifically train helicopter procedures or airplane procedures, excuse me.
I guess what I'm wondering is, if you're flying a helicopter, you're on the Potomac, how are you trained to know that a fixed-wing aircraft would circle to runway 33 and what that flight path would be?
You'd have to kind of interpolate based on when you initially saw the aircraft, which in this case was at Wilson Bridge. If I heard tower say you're cleared circle to land runway 33, you'd have to kind of visually find the aircraft when it's circling to land, which would be very difficult under goggles.
So that's not part of their
No, ma'am, that's not.
training?
No.
Okay. Did you have any knowledge, was it a surprise to you that there was a max of 75 feet vertical separation at the east bank of the Potomac, where the glide slope for 33?
Yes, ma'am, that was shocking. Based on the hundreds and hundreds of hours I flew in this area, like I said, I did not think that was allowed for a helicopter to be on that route while landing runway 3315.
And this might not be a fair question, and you're welcome to get back to me, but if you did know that before, how would that have changed your operations?
If I knew that there was the vertical separation,
75 feet.
I would have told pilots not to cross the center line of the approach path until you saw the aircraft either take off or land.
Thank you very much. Member Inman. Well, first, Member Graham. Member Inman.
I just want to make sure we've got the ability, go as long as we need to, but that we can recall a couple of these witnesses on Friday or whenever we want to?
Yes.
Thank you.
Okay. We only went 10 minutes over. Do you all have additional questions that you'd like to follow up on? Feel free. We are here.
Yes, ma'am.
This is your time to get all your questions, so go for it.
There are a couple questions.
We figured that out. Okay, I just have a few clarifying questions because I want to make sure we are able to all leave on the same page and that we document things correctly and have a full understanding. So I know we've danced around these things a good bit, so I apologize for rehashing. But to understand the VFR helicopter routes, if I understand what I've gleaned here today, helicopter routes they have no lateral boundaries, they are suggestive in nature, or they are suggestive, and the altitudes that are published with them are suggestive, not mandatory. And helicopter routes are requested normally by air traffic managers at facilities that feel they need or desire helicopter routes to move traffic. Can I ask you, Mr. Allen, you had said earlier when you responded to a question about the helicopter flying in altitude, you expected them to be at the published altitude that was listed on the helicopter route chart. Is that correct?
Correct.
And do you feel that that is the controllers, the control workforce at DCA, ATC, that's how they would understand it as well?
Correct.
Did it surprise you to hear that these altitudes are suggestive in nature, barring an actual additional instruction from air traffic control?
It didn't surprise me because it's a VFR chart, but having the facility knowledge, knowing that the operators, I feel, they believe that they're a hard in altitude as well as the controllers do. I see both sides of it.
Okay. So in reality, at the end of the day, the whole route is suggestive in nature, meaning if the air traffic control issued no additional instruction or restriction when they approved them to fly the route, if they flew above the route, below the route, above or below the published altitude, or outside, left or right of what the drawn line is, there's no violation, correct? FAA?
It would depend on the specific instruction, whether there was a violation in 91-123 or any individual clearance. And I think that's why earlier I was specifying it may be very situationally dependent.
Wow, I was hoping for clarification. So
I think
I don't want to misquote something later is really the deal. I want to make sure that I'm have a very clear understanding. If a helicopter checks in and says, I want to fly from A to B via that helicopter route, and the controller says approved, the helicopter, of course, has to follow any other normal rules within the airspace they're flying and all of that. But from the standpoint of the helicopter route itself, if he drifts left or right of the route, or if he goes above or below that altitude, he's in no violation of not flying that route. And unless air traffic control gave him a restriction along with it, like approved, maintain at or below 200. Now he has a restriction from air traffic control that is a positive control, right?
In that scenario, yes, I believe that is accurate.
Okay. All right.
Mr. Soper, can I say one quick thing on that?
Yes, absolutely.
That is not the helicopter operator's understanding.
Can you express what it is from your group or from yourself?
Absolutely. When you check in Class Bravo airspace and you ask for, what the first call would be, say request, and then I provide that request, and I say what my routes or my zones or both, and prior to about 2 months ago, we were not using altitudes in our initial requests. However, as you said, when you receive approved, that's approved as requested. And those limits, the chart is as depicted. The lines are as depicted, and the altitudes are as noted. That is all of our understanding. So I can't speak to where the misunderstanding comes from. I understand the vague term of it's not regulatory, but we don't fly like that. The tower controllers approved our request, or they might deny our request and give us something else. But if it's approved as requested, we follow exactly what the chart says.
Well, that's helpful and confusing. So I just I'm in that same struggle bus right now, because I feel like if these routes are requested by air traffic managers to move traffic through their airspace under a certain criteria, they assign these altitudes. They're not arbitrary. There's a reason they want them at or below 200. There's a reason they want them at or below 1,000. Various reasons, obviously. But as an air traffic controller, I'll be honest with you, I'm learning something new here today I didn't understand, because I did assume if I was working in a control facility and they check in and I put them on that route, I'm expecting them to maintain that altitude. I do understand not having a lateral boundary, but I was unclear on the altitude. I don't think we need to go any further down it today. I think I've got a good grasp on probably what needs to be discussed on this one. So I'd like to move to a second one. Mr. Van Vechten, this one's for you. You have mentioned a couple of times now the perception that it was a rule, essentially, that you would not cross the final approach course of runway 33 if there was traffic inbound to that runway. Do you know where you got that perception, or where that came from? Did somebody tell you that? Was it part of a group you went to? Did somebody instruct you with that on air, or how did that work?
Based on my experience every single time that I saw traffic landing 1533, that I was told to hold at the two locations. And it was, just like to clarify a little bit what you said earlier, so is it under your assumption, sir, that if I'm at 201 feet, it's a violation then?
Well, I'm not saying air traffic's in the world of violating. I mean, from that standpoint, no. I just meant there's an expectation, as Mr. Allen mentioned, that you're going to maintain the published altitude on there. If you pop up above for a second, like he said, you're going to watch that for a second, because you're a helicopter. You're maintaining clear of other stuff and everything else too, and that's a very low altitude. If you come up a little bit and then you come back down, they're probably not going to say anything. If you're up at 400 though, and they see you clicking along at 400 for a few miles, they're probably going to say something, right?
Yes, that's
or there's an assumption they might. So, not what you said, right? So this how long would you say that has occurred a lot? Have you had a lot of instances where you were actually flying that route with aircraft landing runway 33, or has that only been a handful of times, or what's the frequency for you?
Again, it's only a handful of times because of the large percentage that lands 119. So it wasn't that often, but 100% of the time I was not allowed to cross.
Okay. And Clark, you mentioned earlier that's more of a technique that was taught at one time by some people at DCA. Is that correct, at the airport?
Correct.
And it has, to the best of my knowledge, I think we discussed it while we were on site, that was never an actual procedure that they were required to hold aircraft short when they had an aircraft on Route 4 and an aircraft landing 33. Is that correct?
It was technique only.
Yeah, it was technique always, and then some people taught that, some people didn't, and I know there was discussion that somebody always did it that way. So I was just kind of curious, because when people started, when we started talking about that as a rule, it was confusing. So I wanted to be sure where you got that. So just to be clear, if you were trucking along on Route 4 going southbound and you've passed Haynes Point and all that, and then you look out and you realize, oh, there is an aircraft turning inbound. It looks like he's turning inbound to 33. Would you turn around and go to the golf balls, or what would you do? Or would you just query air traffic?
I would make an immediate left turn if I was south of Haynes Point, because I know that's going to keep me clear of the approach path.
So from an air traffic control standpoint, would that bother you if you've cleared this guy, or you've approved this guy to fly Route 4, and you're working your traffic, and all of a sudden you see him turn off of Route 4 somewhere else? Would that be alarming to you at all?
Yes, but he's seen and avoiding, so.
No, I understand that. I just meant, though, that
I would want him to do that.
You'd probably query him, I would assume,
Yes.
at that point. Okay.
Yeah.
All right. I think I understand that part now. And the last one was earlier we were talking about the prevalence of use of runway 33 and how it was only 5% of the use when they're in a north configuration. I feel like that might be a deceiving metric, and I would like this is for Mr. Fuller and for Mr. Allen to respond to. But if I understand, that metric seems to be based on traffic count. So we're in a north configuration, only 5% of the operations actually land 3-3 when we're in that north configuration. That's a low number, or less than 5, whatever that number was. But I think the metric that's concerning for us is it's the amount of times when they're in a north configuration that runway 33 is used to offload traffic is going to be a bigger number. And what I mean by that is, I feel like it is based on the stuff we've looked at, and Mr. Allen, you can correct me if I'm wrong on this. When I say that, I'm saying if you had 100 days that you were in a north operation, how many times when you're in a north operation do you guys utilize runway 33 at some point to be able to offload aircraft for spacing, to get departures out or whatever?
It's a controller's prerogative, but I would be, if you took 100 days, a majority of the time.
And that's the metric that's probably, I would hate to just glean over that as not a problem because it's only 5% of the operations. I would think that if we're doing that, let's just say 70% of the time we're in a north operation, we're having to utilize 3-3 to offload traffic. In order to do that, you're injecting risk 70% of the time you're in a north operation whenever you have to do that. I mean, type of thing. I may have got that a little mixed around, but essentially I just felt like that metric was there. And just to be clear, Mr. Fuller, the number that you did give, that was traffic count, right? Maybe you already, because I don't want to misquote that metric either.
Well, no, that's correct, but that is the only metric that would really apply. I don't really understand the differentiation of if it's every day. If we're only using it 5% every day, it's still 5%. And I think that would apply to every airport in the NAS. We offload to parallel runways or intersecting runways to resolve conflicts or traffic situations or to increase capacity. It's not an uncommon thing to utilize your additional runway for traffic management.
Okay, I think it's more than just a numbers thing to me, but I'll have to articulate that in writing later. So, but I do think I understand it now. So that's all I needed to clarify. That's all I got.
I think it was Colonel DeForest that mentioned during our investigation, 7 of the 8 Limas at the 12th Battalion stopped broadcasting ADSB after installation of the APX 123 Alpha transponder. 6 of those Limas stopped transmitting ADSB about 2 to 8 months after installation of the APX 123 Alpha transponder. And we found the time source setting was incorrect for those. Would that suggest the time source setting was changed at some point between the initial installation when it was successfully radiating ADSB for about 2 to 8 months until when it stopped?
I'd be unaware if it was manipulated or changed willingly.
Mr. Van Vechten, do you have anything to add to that?
No, sir, I'm unaware as well.
Do the UH-60M helicopters also have the APX-123 alpha transponder?
Yes, they do.
And on the APX-123 alpha transponder, the ADSB function is coupled to Mode S. Is that correct?
It's an extension of the Mode S function.
So by turning on Mode S, if the ADSB squitter setting was on, it would automatically start radiating ADSB as well?
I'm not familiar with the pilot interface, but typically it does the same functionally in this airspace. So I don't see a reason you would just do Mode S or just do ADSB out.
At the Army Aviation Brigade, prior to flight, under what circumstances would a crew set up a transponder to transmit only Mode S, but not ADSB? In essence, you would have the ADSB squitter setting off, but you would turn on Mode S.
So from a technical perspective, I'll defer to Colonel DeForest and Mr. Van Vechten for operational, but from a technical perspective, as you're probably aware, Mode S functioning in this airspace through multilateration gives the same position information and barometric altitude information to air traffic control and TCAS. So from an operational security perspective, you're transmitting the same information at the same frequency, whether you're doing Mode S or ADSB out.
Okay. And
one thing, sir, from an operational standpoint, it is possible that the Mode S was inadvertently turned on with the interface through the GPS. It could be very easy to accidentally turn on Mode S. Accidentally turning on Mode ADSB is much more difficult.
That leads me to the next question I had was that Colonel DeForest had mentioned that it's with the policy of not changing the transponder modes during flight, that it would take about 20 steps or so to turn on specifically ADSB. Is that correct? But for Mode S, it would only take 2 presses of a button on the transponder control unit?
That's correct.
And so if Mode S is tied to ADSB, my understanding is that the ADSB squitter setting is saved when the transponder is powered down. And so if the ADSB squitter setting is on, and by turning on Mode S, it would automatically start radiating ADSB as well. If it only takes 2 button presses to turn on Mode S and to turn off Mode S, why limit a crew from turning on Mode S for more awareness with ADSB out when you get to a busy airspace like near DCA? If it's only 2 button presses versus the 20 just to turn off the squitter setting, if you could just turn it off by turning Mode S off and on.
So for the flight on the 29th, it included mission locations. So they're going to go through there as they would on a mission line. So that step would be followed.
But from a pilot's perspective, would that be difficult to turn on Mode S? In terms of the policy, is that too constraining if it only takes 2 steps to turn it on and turn it off in flight?
No, that wouldn't be difficult.
And just to clarify, what you're asking is turning on Mode S in flight is less taxing on the pilot or air crew than turning on ADSB out on in a Lima model?
Correct. And since the Mode S is tied to ADSB on this transponder and the setting saves with the power down of the transponder, i.e. you don't have to go on to turn the squitter setting on each time. If you're not using Mode S while flying to sensitive locations anyways, you could theoretically change the Mode S setting, or the transponder setting, sorry, to turn on and radiate Mode S and ADSB once you've left the area with the secure locations. But with policy, though, prohibiting changing the transponder setting in flight, you would, by policy, limit a pilot from turning on that squitter setting and Mode S.
Thank you. No, I just wanted to make sure that clarification was made. Thanks.
Thank you.
Mr. McKinney?
Yes, Mr. Van Vechten, I have one follow-up question to what you mentioned. You said it would be easy to inadvertently turn on the Mode S if when switching GPS. Could you expand on that comment, please?
Yeah, I was hoping you wouldn't catch that. I misspoke a little earlier. I said GPS instead of transponder. Good catch.
Okay, thank you.
Chairwoman Hamady, I believe that's all the follow-up questions we have.
Thank you. Can I forgot to ask one question. Mr. Allen, you said the tower, so I imagine the CDTI display, I don't know, I'm not a controller. So in the tower, ADSB, it's ADSB capable, but you don't have ADSB on. Like you're not getting ADSB information?
What I was referring to is on the radar display, it can annotate if the system is receiving ADSB data or not, and that's not typically turned on.
Can I help clarify?
Yeah.
So ADSB data may go into part of what's interrogated for the purpose of creating a fused radar target. However, there's no requirement for air traffic controllers to specifically monitor the status of ADSB out. It wouldn't impact separation standards, for example, so they're not required to monitor it.
Okay, thank you. Did you want to follow up or no? You've got, okay, great.
And, sorry, there's one caveat. I'd have to get it to you in the 65 in the event of a certain radar outage feeding ASD, but I can provide you that. It wouldn't, I think, have been the case in this instance.
Okay, thank you. So that concludes panel 2 and day 1 of this investigative hearing. On behalf of my fellow board members and the NTSB staff, we extend our appreciation to the participants in this hearing. Before we close, I do want to ask Mr. Baranovsky to please review any new exhibits, and I know we have a few from the Army that were admitted during this hearing.
Madam Chairman, the exhibit from the Army is the 2017 ASAP report that was filed by MedStar.
We can't hear him.
That's-
Step up, step up.
I'm going to repeat it.
Okay.
We got it.
That was by the Army. Yeah, that's the only one that's official.
Sorry, can you repeat that?
It was the 2017 ASAP report filed by MedStar Transport.
Okay, so for the Army, 2017 ASAP report filed by MedStar. Is that correct?
That's what we're looking for.
Okay, thank you. All right, the record will remain open for the addition of exhibits admitted during the hearing. So the transcript will be made available to the parties and witnesses electronically within 7 days of the completion of the hearing. Any corrections to the transcript must be sent to the hearing officer by September 1st, 2025. As a safety agency, we take fatigue very seriously, so we ask that the Board of Inquiry and parties to please refrain from contacting NTSB staff from now until 7 a.m. tomorrow. If you have questions or need assistance in the meantime, please reach out to the Office of Aviation Safety Director, Tim LeBaron, the Deputy Director, Dave Helson, or the Deputy Managing Director for Investigations, Brian Curtis. To NTSB staff, you did an excellent job today. Thank you. So see everyone tomorrow at 9 a.m. We stand adjourned.